Hi everybody, welcome to the Server Virtualization Jumpstart. We got 2 full days of content planned for you covering every virtualization product related to server that we have. We are really going to try to go throughout the stack, with our first day focused on Core Hyper-V, our second day really focusing on how we can expand that management using System Center, specifically Virtual Machine Manager. Let's take a look at a little more detail over what we're going to be covering for the next 2 days. Over on day 1, we're going to really start by looking at the core infrastructure, some planning considerations, best practices for designing our virtualized environment. We're then going to look at how we go and install Hyper-V, get it enabled, get it running on your Windows Server 2012 R2 infrastructure. We're then going to really focus on how we can go and deploy and optimize these virtual machines, create our VMs, our virtual hard disks, and then do some basic management functionality with them. We're going to look at designing our networks, and then really go and try to take up some more advanced functionality, looking at Hyper-V Replica to allow us to do disaster recovery, and finally ending the day looking at failover clustering with Hyper-V. On our second day, we're going to be really focused on System Center Virtual Machine Manager. We're going to kick it off by doing kind of an introduction to the architecture and a review of the different System Center components. We're going to then look at managing our storage, network, and cluster infrastructure with VMware, creating a virtual machine library and managing those objects, deploying virtual machines using VMware, managing clouds, managing services, and then we're going to look at some of the additional System Center components with self-service using App Controller, and then backing up the data center with DPM, Data Protection Manager, and finally monitoring the infrastructure with Operations Manager. Well, let's introduce ourselves. Corey, why don't you go first?
Hi, so good morning. Welcome to rainy Redmond. My name's Corey. I am a subject matter expert, I guess would be the term of the day. For Hyper-V and System Center, in particular around Microsoft's virtualization stack. My day job is basically I run virtualization data centers, design them, build them, manage them, troubleshoot them, support them, and kind of everything in between. So this is my day job, dealing with Hyper-V, System Center, the Microsoft virtualization stack, at a fairly deep level. Been doing this now for going on 15 years, going way back to the days when Microsoft first acquired Connectix back in the early 2000s. I don't know what the right way to say that is. 1900s is okay. The 2000s.
Early 2000s is yeah.
And even back before that was some of the earlier like mainframe type virtualization stuff that was out there. And ironically, I started my IT career as a DBA.
Nice, nice. Now you have data centers today that you run. So one of the reasons why we wanted to bring Corey out here, show his real world experience running these large data centers. Tell us a little more about your data centers you've got.
So we are a hosting provider that focuses primarily on, I guess, a sort of a non-traditional scenario, which is lab and demo hosting.
Mm-hmm.
So, for example, things like the TechNet MSD and Virtual Labs, that platform. If any of you guys have been doing IT Camp, that platform, literally hundreds, upwards of thousands of users on a daily basis that are running VMs. And we have a bit of a proprietary engine that does the deployment, but it's all based on Hyper-V System Center components and then some code that we produced around that. But we deploy literally tens of thousands of VMs on a daily basis.
On a daily basis.
It's, and some of the infrastructure is pretty high end with nothing less than 10 or 20 gigabit Ethernet, nothing less than 16 gigabit fiber channel, and it's all built around some of the newer technologies that are in 2012 and R2, like scale-out file servers, like storage tiering, like storage spaces, and some of those those key things that are there that have really let this scenario kind of blossom and bloom. It's not your traditional IT pro type, set up an accounting server and keep it running and back it up. But a lot of the same fundamental principles still apply. We just happen to deploy and destroy at a much more rapid cadence than most. So.
Very nice. Well, that's why we wanted to bring Corey in as one of our presenters to really take advantage of his real-world data center experience. I'm Simon Perryman. I am a technical evangelist with Microsoft. I've been at Microsoft about 6.5 years now. I spent my first 4 years actually as an engineer working on our high availability and virtualization products. So I got an opportunity to really understand the technology at a different level, actually build it, so really understand it down at the code level. That's enabled me to get a few patents, and for the past 2.5 years, I've been a technical evangelist, covering our private cloud technologies, our virtualization technologies, and really making sure that I'm familiar with not just Microsoft's virtualization stack, but also VMware's virtualization stack. And so you're going to hear throughout the day, we are going to make some comparisons at the technical level between these two technologies to really try to help you guys, if you're VMware admins, more rapidly understand how Microsoft does virtualization and the difference between the two platforms. With that, I am a VMware certified professional as well, and coming out very shortly is the upcoming What's New in System Center 2012 R2 book, released by Microsoft Press and O'Reilly, that I contributed to as an author. So stay tuned for that if you want kind of some more in-depth understanding of what's going on in 2012 R2. Well, with that, let's quickly review what we're going to be covering throughout the day. Now, our target audience is IT professionals, and this exam training, it's not necessarily only to prep you for the exam. We're really trying to give you a broad foundation of understanding Microsoft virtualization. So we may start the day off kind of covering the basics, going, what is virtualization? What are some best practices? To make sure that everybody has a consistent foundation for why we're doing what we're doing. After that, we're going to be going a little more technical, really diving into every feature, every component offered by Hyper-V in the first day, and then System Center Virtual Machine Manager in the second day. So if you're brand new to virtualization, we will get you covered. If you've done VMware virtualization, we have you covered. If you're experienced with virtualization, we also have you covered, because there will be a lot of focus on what's new in our latest releases with Windows Server 2012 R2 and with System Center 2012 R2. Now, we do want to encourage everybody to take the exam afterwards, and there's probably a lot of questions about exam vouchers. Stay tuned. We will be telling you about how do you get the exam vouchers very shortly. We'll be sending out an email that will have all the information for how you can go claim this exam voucher. With that, I think we will get it started, and we're going to kick it off by first talking about some best practices about how we plan our environment, how we evaluate it, how we really make it ready to become a virtualization platform.
It is, and a lot of people, from a very practical standpoint, put too little weight on the planning phase of this. That, if you think back traditionally, if you, go back a number of years, you're going to buy a server. If you make a mistake, you made a mistake, but it's not horribly expensive because you've bought a server. Maybe it was a couple of $1,000s.
You could go use it for something else.
Yeah,
right?
When you're investing in a virtualization infrastructure, you have to look at every single component end to end and make sure that what you're buying is going to work well together and the entire solution is going to work well together. Because at the end of the day, every single component is that much more important. And as a result, the time and energy and at the end of the day, money that you invest in all those components is going to be a lot more. And so I find that, most virtualization administrators, if they've not kind of been in that their whole career, they come at it from the angle of, it's just another server. It's not just another server. It's not just another, fiber channel adapter. It's not just another network card. The impact of downtime is so much more significant that you've got to put that extra effort into planning, into making those purchase decisions, into having good relationships with your vendors, and having partners across the entire ecosystem so that when you put something in place, it's going to be there and be there for the long haul. So we're going to kind of go in and start taking a look at what are the things we think about when we look at evaluating an environment to move towards server virtualization. A lot of the thinking around this has changed in the last 10 years. We began talking about server virtualization back, 7, 8, 9 years ago with the first products around the era of Microsoft Virtual Server, Microsoft Virtual PC, and back then the things we think about, conceptually are similar to what they are today, but they've gotten a lot more involved as the technology has gotten better, and there's more that you need to think about and consider. Primarily as the hardware's gotten faster. Once upon a time, you never thought about CPU related to network cards. It just kind of wasn't an issue. Nowadays, with the advent of 10 gig network cards, you've got to think about impact of CPU on a network card, and the type of network card you use, and the features and the hardware level that it supports. So virtualization administrators tend to be hardware gurus. And they know to a very minute level of detail what different pieces of hardware are, how they work, and what they do. This particular module kind of start off talking about virtualization in general. What are the components of the System Center suite? And I think it's pretty important that we kind of get across this point that we're not here to talk about Hyper-V and then talk about System Center. the two go hand in hand if you're a large organization, or if you want to automate things, or look at things at a higher level. Hyper-V is one piece. Hyper-V is the hypervisor. It's what sort of enables a lot of these scenarios to happen. But at the end of the day, if you're a large company, or even a smaller, a mid-range company, if you've got a bunch of Hyper-V servers and you're not using System Center, you're doing it wrong, because you're creating a lot of effort that you don't necessarily need to create. And in fact, there's a lot of features within Hyper-V that only really light up when you put System Center on top of it to give you that 10,000 foot and down management view of everything. So we'll kind of look at what all those components are and the role that they play, because I think a lot of people in the world of virtualization, they know Hyper-V, they know VMM. Where does Orchestrator fit in? Where does Service Manager fit in? Where does Ops Manager fit in? And then the big question is, where does Configuration Manager fit in? And that one does not, doesn't fit into the virtualization stack quite as well, but it's often sort of forgotten about. We want to make sure we kind of, let you know where that fits in as well. And look at some of the evaluation tools, and then what's the role that Azure plays in all of this, right? Because we know private cloud and public cloud and hybrid cloud, and how does all that fit together? So that's what we're hoping to peel back within this module.
Yeah, that's a great point, talking about how we are really treating virtualization as different. And you're going to see throughout the course of the day that both in the software and in the hardware components that we look at, we will have special considerations just for virtualization. For example, now whenever we deploy a cluster, if it's a Hyper-V cluster, we actually change some of the internal properties. So things get triggered faster, things behave differently than traditional clusters. So that's going to be a key point throughout the day. And the second thing you mentioned was, this comparison of when do I use Hyper-V, when do I use System Center, Virtual Machine Manager. Well, really, you want to think about using Virtual Machine Manager when you start to manage at scale. You have lots of clusters, lots of servers, lots of hosts, and you need consistency. Because consistency is one of the key tenets that we have with private cloud, ensuring every service configured the same way, it doesn't change, it's standardized. That way when we're running our virtual machines across different hosts, we get guaranteed the same behavior. One of the key things of virtualization is abstracting that hardware from the software, but we still want to make sure we have consistency, so VMs always behave the same way.
One of the big things I hear when I talk to network admins about this stuff, they say, VMM versus Hyper-V. They go, well, I like Hyper-V because I really get in and configure things, and I'm very close to it. I can manually do everything. And I kind of look at them and I go, well, you like DHCP, right? That kind of makes it all automated and gives you a nice global view, and you don't got to worry about it. Why would you not take that same principle and apply it apply it to the virtualization layer? And you see the light bulbs starting to go, yeah, maybe you're right. Maybe we'll start thinking about, well, I'm not going to care about the server per se and just define it as, as a policy or as a rule within VMM, and let it kind of take care of it. And there's features within VMM that make this simple and easy to do. So we'll see a lot of that more tomorrow than today. Today is more on the core technology piece of it, how Hyper-V works and all those underlying technologies. So again, just challenges of traditional computing environments. Why people move towards virtualization. Obviously, space, power, cooling, resilience. Essentially, is the idea that this is kind of space, power, cooling is pretty obvious. If you have one server versus 10, you're using less of all of that. And as folks are moving more and more towards hosted data center environments, where I don't want to put the servers in my little my doctor's office or my lawyer's office or my accountant's office. I want to put them in a colo data center. A lot of times you pay based on power, space, and cooling. And so the less you have of that, the cheaper it is to operate. I know we do, so why wouldn't everybody? But then there's another component, which is the resilience. One of the neat things that Hyper-V lets you do, and should say not Hyper-V, virtualization in general, is take any component and make it fundamentally highly available. If you have a legacy application that's not clusterable, how do you go ahead and make that how do you go ahead and protect that from underlying hardware failure? And the answer is you put it in a VM, you put the VM on a cluster. If the hardware goes down, the VM will fail over to the other hardware and come back up again. And so you get that benefit of all of these pieces. Flexibility, you don't need to buy RAM, you can add RAM. Makes it a lot simpler, a lot easier to do, and then using only the resources that you need, because the reality is most servers in small business, medium business, enterprise business scenarios are overspec'd. Because you buy more than you need and it sits kind of idle for a lot of the time. Well, with virtualization, you can scale it so that it goes up and down at different points in time, and you're making better use of your resources. So server virtualization, we're not going to spend too much time on these fundamental definitions here. I think everyone pretty much knows what we're talking about here. The idea of running an operating system in a virtual machine to put a workload that would traditionally run on bare metal into a VM and just kind of go from there. But there is sort of a new concept.
Network virtualization.
And this is a really big, scary, confusing one for a lot of people. You're going to see this today with Hyper-V at a conceptual level, and you'll see it tomorrow within Virtual Machine Manager at a practical level. But to kind of sort of explain what this is in a nutshell, server virtualization is very straightforward. But what if you get into a scenario where you're a hoster, okay? And you want to run multiple tenants or multiple customers on the same fundamental infrastructure, and you want to let their VMs talk back and forth. The way that hosters have traditionally done this is through VLAN technology with switches, but frankly that's a nightmare because there's limited numbers of VLANs. They've all got to be configured.
It's tougher to manage at the end of the day, right?
It's a lot tougher to manage. You know, some of the switching vendors provide tools that can allow you to apply policy across switches, but what if you've got more than one vendor? Are they compatible? It's a very, very complex thing to manage. What network virtualization does is allows you to take one single switch and have multiple VMs that are connected to it, physical switch, that all have the same IP address. And what Hyper-V knows how to do is use something called generic routing encapsulation, which is the same technology that a lot of VPN protocols use, to encapsulate the packets as they go back and forth. So you could have two machines with the same IP on the same network, but they don't conflict with each other because they're in defined virtual networks. Now all the components have to understand this, but once it's in place, you get away from this whole notion of managing VLANs. So it's a very abstract sort of topic. It's one of the more difficult things to understand, quite frankly. So you'll see it today at a conceptual level, tomorrow at a practical level. So just don't worry too much about it for now. But it's there, and it's, you may have heard of the term software-defined networking. That's network virtualization is an implementation of that.
Okay, now one of the things that we do at Microsoft is we have kind of our own way of using network virtualization. Now we have a lot of developers, right? And we don't really want to limit our developers what they can do. Sometimes they need to have their own Active Directory domain controller, sometimes their own DHCP server, but we don't want those on the network interfering with other things. So at Microsoft, each developer, we basically give them their own virtual network. They have their own range of IP addresses. They can spin up to 256 VMs, their own domain controllers, own infrastructure servers, own networking components, and not interfere with anything else. So if you have kind of these developer environments that need to be isolated, yet still need access to resources, this is a great way to really try to take advantage of that.
Absolutely. So let's kind of take a look at some key technologies in the stack and then also how they compare to some of the technologies from VMware.
So first of all, let's talk about the hypervisor. So we both have hypervisors. Hypervisor kind of being the core component of a virtualization platform that basically does the layer of translation between the physical devices and the virtual devices. Now on top of that, we have our management solution. In Microsoft World, we have Virtual Machine Manager. VMworld is the vCenter server. But between both the hypervisor and the vCenter server, we have functionally equivalent offerings, and these are what we're really going to be focused on over the next 2 days. Now when we start to think about self-service, one of our private cloud concepts, the key goal here is to enable end users to request resources and free up time from our infrastructure specialists. Now let's say you have an end user that just needs a new VM. Instead of picking up the phone or sending you an email and asking for it, let's give them a website, give them a button that says, give me a new VM. They push it, they get a new VM. And so what we're trying to provide with self-service is freeing up time for our IT pros, better enabling our end users. And we do that using App Controller, which is equivalent to the vCloud Director. As we look at monitoring, we use Operations Manager. VMware uses vCops, or vCenter Operations Manager Suite. They essentially do end-to-end monitoring throughout the stack: hardware, software, virtual machines, and applications. For protection, we really think about protecting our hosts, our clusters, our virtual machines, and the applications running within those VMs. Microsoft offers Data Protection Manager. VMware offers vSphere Data Protection. For service management, we use Service Manager, and we often see it really used in kind of two distinct ways. First is the traditional IT help desk, getting incidents, solving problems, tracking changes, things like that. The second way that we're often seeing this used is to provide the back end of our self-service portal, allowing again our end users to make any type of customized requests and having us be able to automatically provision that. So we use Service Manager, VMware uses the vCloud Automation Center. And then for automation, we have a technology that was new in System Center 2012 called Orchestrator, similar to vCenter Orchestrator, that allows you to do what we call runbooks, which are predefined automated activities. And this can connect literally any system that has a programmatic interface, meaning functions, APIs, command alerts, scripts. We could go tie those all together to provide any automation end to end. But kind of the key point that we want to just take away here as we compare Microsoft to VMware is we have an equivalent set of features, an equivalent set of products, an equivalent suite of technologies to enable you to go build your own private cloud and to go scale up towards a public cloud. Now, Corey is not a marketing guy with Microsoft. I kind of sit on the fence, half marketing, half technical, but I promise you this will be the only slide you see with a $sign for the next 2 days. What we're just showing you here is a brief overview of the comparisons, looking at Microsoft's suite of products, comparing that to VMware's suite of products. And you can see that generally Microsoft suite, it's a little cheaper. But again, we promise you that's all you're going to get about VMware licensing. Key point here is we have an equivalent set of technologies now. So we really want to encourage you, as you're thinking about new deployments, consider using Hyper-V Microsoft Stack, as it's going to give you a lot more advantages that we're going to cover over the next 2 days.
All right, so next small section we're going to do is kind of a quick rundown of System Center. Now, you've mentioned in that quick comparison slide a number of the different products that are involved in the System Center suite. So we'll take a second now and just kind of define each of those. Yep. So people know what they are. For example, Service Manager, if you're a virtualization guy, you kind of go Service Manager. What do I really use that for? I don't get it. And that's what we'll try and clear up here in this brief section.
Sounds good. So first, let's start from the top here, managing your virtual environment. So Virtual Machine Manager, this is what we're going to be focused on our second day. This is our large-scale virtualization management solution, but it doesn't just manage VMs. It also manages what we call the fabric. Now, the fabric consists of our networking components, our servers and our clusters, our storage components, and then the supporting infrastructure. So this would include our update servers, our Pixie boot servers, and even third-party hypervisors, such as your vCenter server and Zen server.
Can I inject a minor annoyance?
Absolutely.
I don't like the name VMM.
It seems misleading, Virtual Machine Manager, because it really does more than that.
Virtual machines is a fraction of what it does. It should be, Data Center Fabric Manager. It would probably be a better name for it, quite frankly, than Virtual Machine Manager, because it does switches, it does storage, it does fiber channel, it does, what else in there? It does deployment, it does, bare metal provisioning.
Yeah.
So yeah, it's deployment center and switch management center and SAN management center and all those sorts of things. So that just, my
Don't feel scoped down by just Virtual Machine Manager.
Exactly.
We have a whole lot more in there. Now, some of the other stuff, some of the other components, actually, if we could go back one slide, Corey.
Sure, yeah.
So to wrap up, some of the other components, how they relate to virtualization here. So App Controller is, again, the self-service portal. It allows us to basically manage our VMs from an end user's perspective. So if you have an end user, they basically get to see the virtual machines and services that they have access to, but none of the underlying infrastructure. This is provided through a website. So you don't need to go and install a management console. Simply use the website. You're good to go there. Now, we also look at Data Protection Manager. That's going to go back up our virtual machines, those other components. Automation provides automation for our virtual machines and provisioning. Service Manager allows you to make requests for your virtual machines. Operations Manager monitors your virtual machines. And then again, DPM goes and protects those VMs and those different hosts. So as we take a quick look at the overview of Virtual Machine Manager, some of the key features here are simple bare metal deployment. Again, taking a brand new server, installing the operating system on it, booted from VHD, and then making it a Hyper-V host or even making it part of a cluster. We then have the ability to go and actually create these different Hyper-V hosts, create these different clusters, organize them in logical groups, management groups. We can provide cross-platform management covering both vCenter, VMware components, as well as Citrix Zen. some placement optimization, storage management, network optimization, power optimization, and then a whole lot of other detailed features. But again, we'll spend some more time on that one tomorrow.
One of the coolest things I ever did with VMM, and I only ever did this once because, quite frankly, it was a lot of work to set up. But if I had to do this many times, I probably would. Which is, we ordered a stack of servers from some random 4-letter server provider starting with D. And before we got the servers, we knew what the management IPs or the bare metal management IPs were going to be in every single box. We knew what the credentials were going to be. We knew all that stuff. And so with VMM, what we're able to do is go in advance and say, okay, I've got 10 of these things coming in. Define 10 jobs, which represent, find it on the bare metal port, put an operating system on it, join it to the domain, put Hyper-V on it, join it to a cluster, and then we're done. And so when these servers came in, they were dropped in the rack, some cables were plugged in, and some guy went, go. And within, I think it was 2 hours, we had 10 servers in the domain with Hyper-V ready to take VMs.
Very nice.
It was absolutely fantastic. It took a little bit of, like anything, it took a little bit of time to, drivers and get that all built into the images, because you've got to create a WinPE image. You've got to have a VHD that's got everything in it. So that took a little bit of time. But once it worked, it was utterly fantastic.
Now you're teasing everyone. I'm actually going to demo that tomorrow. So stay tuned. You're actually going to get to see one of these bare metal deployments live tomorrow.
I'm keen for that. All right. So if when you think about VMM, so we've got Hyper-V, a bunch of Hyper-V servers. You layer VMM on top, and VMM gives you that global management. But now I want to add in Azure Public Cloud. I want to add in another VMM implementation, maybe from a partner company. That's where App Controller starts to come in.
That's right. So previously we just said App Controller was a self-service portal for VMM. Now it does have a dependency on VMM, but there's actually a lot more you can do with App Controller, as Corey was mentioning here. Let's say you need to scale up to the public cloud. Well, App Controller actually allows you to connect to your Azure subscriptions and deploy VMs that you could deploy on-site up in Azure. So really allowing you to extend your data center to that public cloud. But let's say you don't have Azure, maybe that you don't have it in your country, maybe there's legal reasons why you can't transmit the data and store it in a public cloud. Well, we also support what's called service provider foundations, and this essentially allows you to go and use a third-party hoster's data center, yet still manage it using your own system center components. So when you run out of capacity on site, like I might run out in my data center, I could go run my VMs over in Cora's data center.
I'm not taking your VMs.
You're not taking them?
I've seen your VMs.
You've taken a few of them already in the past.
Exactly. That's my point.
Exactly, yes. Lots of emails this past weekend about problems with VMs.
The Service Provider Foundation is a pretty neat concept in general, because what it allows if you're a hoster, and there's lots of big hosters in the world that do infrastructure hosting, and you want to enable people to, hook into your stuff via APIs, via automation, you would have had to build something, and they would have to adopt your framework. What Service Provider Foundation allows you to do is take this generic layer that we know interfaces with all the Microsoft components that you as a hoster can put in front of all your infrastructure, and gives you all that functionality automatically.
Yep.
And just translates it all through. So it's a really neat component.
And guess what? We're actually going to demo that one as well tomorrow. We're going to go do a deployment out to our service provider. Excellent. Not you, sorry.
No, not me.
You weren't set up for that one.
Nope. So moving on to our next small section, which is looking at evaluating the current environment for virtualization. So what are some of the things we want to think about as we look at moving towards a virtualized solution and some of the different elements of that? So number one, things you got to consider. I mean, some of this is very obvious stuff that relates to any general project. Scope, hardware requirements, compatibility, applications and services, what things are supported and what things are not supported, licensing, availability, and the undocumented political element of it all. There's lots of cases where I've been involved in companies doing virtualization migrations where there was some server that we're sitting here going, why is that not in a VM? Because they won't let us. Why? Because they said we're not allowed. And you never get past that. Well, at some point you go, okay, you're making a dumb decision, but you can lead a horse to water. But and we kind of see that a lot. Two other things you want to kind of think about of this list that are probably the most important. One of them is supportability. You need to look at, are the applications that you're running going to be supported in a virtual machine? And there are, applications out there, especially some older applications, where the software vendor just says, you know what, we're not supporting it in a VM because we don't have the budget to do all that testing. Even though by definition doesn't matter. It does factor in, and I've seen people get burned where, you know, they have an application, they install it, and then there's some issue 2-3 months down the road, and the company that provided it goes, well, we'll help you once you reproduce it, not in a VM. So just, you've got to bear that in mind. It really is a kind of a stupid little thing to have to deal with, but you do have to deal with it. And then licensing. You get a lot of benefit from operating system licensing when you choose to run things in VMs. And we'll talk more about this later on, but for example, on Windows Server Data Center Edition, you get unlimited guest operating system licenses for data center instances. So rather than having to buy 30, 40, 50 licenses for Windows, you only have to license the host. Then all the VMs are free. And they've now introduced automatic activation, so you don't have to worry about activation anymore.
Very cool feature.
Really, really makes it easy to do. Now, to make this all simple and easier, we have something called the Microsoft Assessment and Planning Toolkit. We have also something called the Infrastructure Planning and Design Guides. Many of you, if you're old like me, might remember something called the Windows Server Reference Architecture, which was a set of documentation that Microsoft did about 7 or 8 years ago. That was one of the best pieces of documentation I've ever seen in my life. It was basically, if you're an enterprise, you want to deploy every product Microsoft has in the best possible configuration, here's a 60 million page document on how to do it. Right from hardware to permissions on user accounts on database files. Everything. And it was phenomenal because you could use that as a guide. And a lot of companies did use that as the guide for doing their implementations. Well, that's been improved, chunked up, made smaller, made more consumable, and the result is the Infrastructure Planning and Design Guides, which is a set of documentation that you go search for this using your favorite search engine, and then just download them, and you pull out whatever document you want, whether it's it's virtualization, whether it's application deployment, whether it's configuration manager, whether it's security, whether it's firewall stuff. And it's all the considerations and best practices and recommended configurations are all right there. You take them, modify them, tweak them, just put them in place. Now, the one tool that we mentioned was MAP, the Microsoft Assessment and Planning Toolkit. This is something that gets updated, it feels like every 2 weeks as new hardware becomes available, as new solutions become available, as new recommendations become available. But essentially what this will do, you install it on a machine, it will use anything from subnet ranges, domain memberships. It'll even interrogate configuration manager if you have it. Find every system on your network within the scope you tell it to search, and then evaluate it for things like virtualization. And this applies for not just virtualization, but deployments for, you can do it for security, for firewall stuff, for application compatibility. The focus here would obviously be virtualization, but you can say, hey, here's my network. Find me all the servers out there that are good candidates for virtualization. And it'll go find them based on operating system type, whether or not it's physical machine the hardware it's running on. And then even if you tell it to, watch it over a period of time and gather performance metrics. The result is it will give you direct purchase recommendations on things like, hey, go buy this fast track kit configuration 1. This many disks, this much RAM, this many hosts, and this will cover everything I found. And as I said, it continuously updates itself as new product offerings become available. But it's a real good way, if you want to, kind of impress your boss, you go, hey, give me a week, and I'll come back and give you tell you exactly what hardware to purchase. And you just tell MAP to go do it for you.
Get a detailed report at the end, and it's all free, so it's a free download available online as well.
At the end of the day, you get it comes out and says, hey, go buy this, this particular fast track, click, and here's the link to the purchase option. Click spend $200,000, and away you go. So with that, move on to our next section here, which is extending virtualization to the cloud. So Simon, let's talk a little bit about Windows Azure for a second and where this fits into the overall virtualization strategy.
Absolutely. So Windows Azure, you guys may have heard us mention Azure before. I don't know. You guys may have heard Microsoft mention cloud before. Those terms get used a lot. So what exactly is Azure? Well, simply, it is our Microsoft public cloud offering. It is a set of infrastructure hosted in Microsoft's own data centers located around the world that you can use, that the public can use, that anyone can use to take advantage of infrastructure and different platform and messaging services. So essentially, it's offering IT as a service. Now, there's really 3 different types of service models provided by a cloud: platform as a service, infrastructure as a service, and software as a service. Now, Platform as a Service, this is essentially offering your developers a set of connected infrastructure that they can go build their applications on. .NET applications, Java applications. It's basically providing that foundation with all of the connected components so that these enterprise applications can communicate with each other. Now, Infrastructure as a Service was a new offering Azure came out with about 6 months ago, summer 2013, which basically allows Microsoft's infrastructure to be made available for you to do with it what you want. So if you say, I need a new Windows server, we could go give you a new Windows server in a matter of minutes. So pretty simple to go get spun up, to go get up and running with your Azure infrastructure. And we're going to show a demo of that a little later, going and actually connecting to your Azure infrastructure, deploying a VM. Then finally, we have what we call Software as a Service. And this would be something equivalent to, say, Office 365, where we're actually just providing the software online that you can connect to. So you don't need to go and install Microsoft Office across every client machine. People could just access this type of application.
It's not just Office,
in the cloud.
It's Link,
lots of applications.
Link, CRM.
Yeah. Exchange Online is one of the most popular ones as well.
Absolutely.
SQL Azure, so a lot of applications.
SharePoint is a huge one. We use Office 3. We retired our Exchange servers about a year or so ago at our company. Just we don't want to have to manage them anymore. It's just we're not Exchange experts. We just need email, but we want Exchange caliber email. And so for a couple $100 a month for the entire company, we don't got to worry about it or think about it ever, which is absolutely fantastic.
Absolutely, and actually, if we can, let's switch over to my laptop here. I'll actually show you a quick demo of us doing a Infrastructure as a Service deployment. So what you see here is the Windows Azure portal. I just go to manage.windowsazure.com, sign in with an account, and you can see right now, this is the overview page. I have a couple of services and applications running. Now, as we look along the left side of our screen here, we can see we have options to deploy websites, virtual machines, different types of mobile and cloud services, even Visual Studio if I have developers that want their own Visual Studio instance. But let's just take a quick look at how simple it is to go create a new virtual machine. We go down and say New VM. Now, one of the nice things about Azure, it comes with what we call a gallery, a set of pre-configured applications and services. So as I kind of browse the gallery, this means that if I pick one of these VMs for, let's say, SQL Server 2014, SQL Server comes pre-configured and pre-installed. So I don't need to go through that additional step of downloading SQL, installing it, getting it configured. We get it up and running. Now, we also support other Microsoft applications and also other third-party applications. Recently, Microsoft announced a new partnership with Oracle, and we're actually the only hypervisor that supports Oracle applications, which Oracle doesn't own. Oracle does actually have their own hypervisor, but Hyper-V is the only other one that will support their applications. We have other development studios and frameworks, so JDK, and then, of course, our different Linux distributions. So with Hyper-V, we do have a pretty broad offering of guest operating systems that we support. Of course, all the Windows Server and Windows Client, but then many of the most common Linux distributions.
So Windows Azure runs Hyper-V, obviously.
Windows Azure runs Hyper-V, but within those Hyper-V virtual machines, that's where we can go and configure all these additional components.
But the underlying fabric for Windows Azure is the same Hyper-V that you get in your own data center.
And so that's what gives us some portability between our on-premise virtual machines and moving them up to Azure, because we can run those same VMs that I build, those same VHD files, upload them to my storage in Azure, and once they're in my storage, actually go create a VM using that VHD. So it gives us kind of that portability between the different clouds.
Not to get kind of too far ahead of ourselves, but there's a few more steps to just throwing a VHD in Azure. You've got to make sure that, for example, RDP is turned on, because that's how you get connection to the desktop of the VM. So we'll go through this. I guess tomorrow is when we'll dig into some of that.
Yep.
But it's you can take a VHD off your local Hyper-V server, push that to Azure and use it. A few little things you got to do to make sure it's going to be compatible and work, but those are all very well documented through the tools that you get.
Absolutely. So really, trying to give this flexibility with deployment. Now, let's go ahead and just quickly pick one of our virtual machines here. I want to make sure I'm using the latest and greatest Windows Server 2012 R2. I get to give it a name. So we'll call this Jumpstart. And we'll just give it a unique number as well. We get to pick what type of cores we want to use, so very large amount of memory, very small amount of memory. Provide a username for myself and a password. Click Next. We then get to say what type of cloud service are we going to go run this on. So basically, what logical grouping do we want to go place this virtual machine within? And so this means if you're a developer, you have a bunch of interconnected virtual machines, you're going to try to want to run them on the same fabric so they have faster network communication and can share some other components. We then would get to pick which region we want to go deploy this in. Now, since my cloud is already set up in the US West, and I'm going to be part of that same cloud, we're going to stay connected to that. We get to go and use a new storage account, pick our own, and then we have an option of creating an availability set. Now, an availability set is something we're going to talk a little more about with Virtual Machine Manager, but essentially what it does is it forces two virtual machines to run on different hosts. It does what we call anti-affinity. Now, the reason why we want to do that is simply to provide higher availability. Let's say you had two applications that are running inside VMs. Both of those VMs are on the same host. Well, if you lost that host, that's a single point of failure. You're going to lose both VMs.
Well, where that becomes particularly important is guest clustering.
Absolutely. So, the different cluster nodes running as VMs.
Yeah, and we've got a modular and high availability towards the end, but to kind of briefly describe that scenario, let's say that you want to do a highly available Exchange implementation. Well, you wouldn't want to put both nodes of your Exchange cluster on the same Hyper-V node, because should that node go down, well, the whole cluster goes with it. So you'd always want to spread that out and say, this node of the Exchange cluster goes on this host, and then the other node can go on any other host, so that you don't have a single point of failure. And that's where the anti-infinity comes in. So these concepts of guest clustering, host clustering, is all that will come later today in more detail.
Absolutely. So you're going to see a lot of consistency both within Azure as well as on-premise with Core Hyper-V, and then again up to our data center management with System Center. Finally, we get to confirm the information. I could go configure my connection protocols. Click OK. This is then going to go create, and we will then have our virtual machine up and running. Well, back to you, Corey.
All right, so just kind of taking a look here on the slide deck real quick as a bit of a summary of what Simon had just gone through for virtual machines in Windows Azure. Built from scratch, meaning they're deployed when you define them. They're not in a predefined saved state or in a predefined deployed state, like, for example, our lab VMs would be. They're actually deployed using unattended XML files from generalized VHDs when you deploy them, using any of the available templates. And then any applications that might be part are always going to be pre-installed. And you can customize this all you want. So you can take what's there by default, or you can go very, very detailed on the customizations, applying your own unattended XMLs, your own VHDs with your own applications, whatever level that you want to go to. Or you can upload VHDs and actually import them. So that pretty much sums up Module 1, kind of getting us all started on the big picture of virtualization on a Windows infrastructure, everything from Hyper-V, which is the local on-premise hypervisor, to Virtual Machine Manager and App Controller to manage large-scale deployments, right up to Windows Azure as the public cloud side of things.
Now, there is one other component that we should mention here, which is the Windows Azure Pack. Now, Windows Azure Pack is a new capability released with our latest R2 wave. So it requires Windows Server 2012 R2, System Center 2012 R2, and essentially it allows you to run Azure-like services in your own data center. No internet connection required. So if you like that interface that I just showed you, where you can create virtual machines from Gallery, create your own platform as a service offerings, yet maybe you don't have access to a public internet because you're a government organization, you have certain legal or compliance requirements, being able to go build your own public cloud, being able to build your own cloud on-premise is a great capability, and you're going to see a lot of ongoing investment towards the Windows Azure Pack coming from Microsoft, really providing a much better self-service experience, end-user portal, allowing you to run these great data center services in your own data center.
Yeah, the other sort of reason you might want to consider the Azure Pack is because you're running it on your own infrastructure, you get more direct control than you do with Windows Azure, for example. With Windows Azure, it is what it is, right? They control everything about it.
And there are some limitations, right?
Sure,
you have
absolutely.
to work within those, yep.
You get to kind of expand those a little bit. You get to define what the hardware is. You get to define everything around it by putting it in your own data center. So you get that same Azure level of automation, flexibility, the great user experience, but you can decide whether it's going to be faster or slower, whether you want more disk, more memory, more CPU, whether you want to enable configurations that Azure might not choose to enable because you have more control over everything. They've got to think about everybody. You only have to think about yourself.
Great point, great point.
So.
Well, we will say that Windows Azure Pack, we're not going to spend a whole lot more time on that. If you want to learn more about that, you can go to windowsazurepack.com or microsoft.com/Azure and check out the different Azure services. With that, we are just going to wrap up our first module here.
Yep.
You know, to quickly summarize, we've kind of hopefully given you the foundation, covered some initial best practices, and very shortly we're going to be moving on to our next module where we look at installing and configuring the Hyper-V role. So stay tuned, we'll be back in approximately 10 minutes. Welcome back to Module 2 of the Server Virtualization Jumpstart, looking at Windows Server 2012 R2 and System Center 2012 R2.
You know the best thing about this?
What is that?
Microsoft branded water.
Microsoft branded everything. You could get Microsoft anything nowadays, right? Now, as part of this second module, we're going to really be focused on, of course, core virtualization, really looking at how we go and set up Hyper-V on our hosts. So we're going to look at how we go and install the Hyper-V role. We're going to go and look at how we do some best practices around our storage, networking, and our cluster infrastructure. Essentially, with our goal here of providing you with these best practices to really get your core infrastructure prepared, up and running. I'm Simon Perryman, Senior Technical Evangelist with Microsoft, and I'm joined again by Corey Hines, President and Lead Architect of Whole Systems. Well, Corey, back over to you.
All right, so how do we get Hyper-V? If you choose to install it, and I'll explain what I mean by that in just a second. So this module, a couple things. How to install Hyper-V. For those of you that are not familiar with the basic management tools like the MMC console model, how we navigate through, how we set up VMs, create VMs, configure the basic settings and what they all mean. There's a lot of settings in there, and I don't think people fundamentally understand some of them, so we'll kind of look at some of the implications. And you know, I've seen plenty of admins install Hyper-V, create a new VM on really fast, really big hard drives, and then 2 hours later go, why is it slowing my hard drives full when there's all kinds of disk space? And I'll explain how that happens, because it's a pretty common mistake. And then when you're considering the host infrastructure, the fabric, what do you think about for networking and storage? Huge decisions you've got to make because they have massive implications down the road. And I'll also explain, what I'm in love with now in terms of hardware. There's kind of a new generation of hardware that's out right now that we've invested a lot of money in that I am utterly in love with.
I'm just going to tease us. Save that for later, though.
Oh, absolutely. Utterly in love with. So first of all, installing Hyper-V, first lesson, and some of the considerations around the hardware that you're going to use. So first of all, the Hyper-V, when you look at it architecturally, it's described as the hypervisor which lives below the operating system. The process for getting Hyper-V on a machine is to install it as a role. But when you install the Hyper-V role, that's a radical transformation of the system. What used to be the operating system is now, by pure technical definition, a VM. It's just that when you boot the operating system, you've got to go somewhere to manage it. So you boot it, and it goes into this parent VM.
The parent partition.
Right, the parent partition, the parent VM. And then you create child partitions, which contain other VMs beyond that. So in terms of installing Hyper-V, it's pretty straightforward. We'll show you how to do it in just a second. But there are two ways you get Hyper-V. If you choose to install it on server standard or server data center, whether it's the core edition or the full GUI edition, doesn't matter. And in fact, nowadays, there's no difference anyway. With Windows Server 2008, when they first introduced Server Core, you made a choice in the beginning.
It was that one-time decision,
core or nothing, right? And everyone did core until they realized there was no property page on that device driver, and so they kind of shot themselves in the foot. Nowadays, it still requires a reboot, but you can add the GUI, you can take it away again. In fact, there's 3 levels. And if you want to see all kinds of examples of that, look up the jumpstart that your colleague Rick and I did a number of months ago, and we go into all that stuff. There's also Hyper-V Server, right? Hyper-V Server is the free one that you can go download. Now, the thing that's amazing about Hyper-V Server is that it is the exact same performance and functionality level of Data Center Edition. So what you get with the highest value, highest performing SKU of Hyper-V, you get with the free edition. The difference is that it doesn't come with any licenses. So if you already have your licenses, or say you're doing VDI, where the licensing is provided through desktop licensing solutions, or you're hosting only Linux distributions, for example, it's absolutely fantastic. This is the one that we primarily use. And And then starting with Windows 8, you get Hyper-V as part of the client. Now, it's not the same level of Hyper-V that you get on the server. You don't get live migration, for example. You don't get clustering, but you get the ability to create on your Windows 8 or Windows 8.1 client the exact same VM that you could create on the server. Same configuration, same memory, same everything, and then you can take that, port it to a server. And a lot of people use this for, if you're a developer and you want a couple of operating systems to test in, it's a great way to do it. If you're, developing lab environments like you do, for example, that you then give us to host for you, great way to do it as well, because it translates easily from the client to the server. Now, on the client side, there's a few requirements that you have to meet. For example, you have to have SLAT on the CPU. Because of the way that it does video, but it's pretty straightforward. And essentially, if you have an i7 or later, or sorry, an i5 or later Intel CPU, I don't know exactly what the generation of AMD one is. So someone I'm sure out there can post that in the chat window. But you're basically good to go. You don't got too much to worry about.
Now, I do just want to kind of talk a little more about this free version, because a lot of people are kind of confused, right? Why would Microsoft offer this completely free version of Hyper-V?
Well, first of all, it doesn't do anything else, right? It's not a full server.
It's not free Windows Server.
No.
It's free Hyper-V with clustering. So this means you don't have Active Directory. You don't have file services. And if you're ever going to want to build a cluster or make these VMs highly available, clustering has a dependency on Active Directory.
Yep.
So you're still going to need some type of Active Directory infrastructure in your data center if you want high availability.
Yep.
Now, if you're building this in an isolated lab environment, you don't need any AD credentials, not a problem. Just go use that core Hyper-V server. But essentially, we wanted to go and really try to increase adoption of the Hyper-V platform, offering this free host. But beyond that, it offers a few other benefits. First of all, the fact that it has no GUI and none of these other components, other than the core network, storage, virtualization, and cluster features, it means that it has a smaller attack surface. It means it has a smaller installation footprint. It means it needs fewer patches. Fewer patches leads to fewer reboots. Fewer reboots, higher availability. So we actually recommend our customers go and use this Hyper-V server or use Hyper-V core to really, get that higher availability as well. But some people, the top, concern I get about it is that, hey, it's core only. I don't want to go and kind of use this minimal interface.
Well, if you're managing the server by logging onto the console, I'm sorry, you're doing it wrong. You're doing it wrong.
There you go.
You should be using tools to do it. And okay, fine. You've got one server. You're the guy, and you've got one Hyper-V server in a corner in some client's building somewhere. All right, that's fine. I'm not telling you you're doing it wrong. But if you're a large company, group policy, configuration manager, which curiously omitted from the System Center stack earlier because it's not part of the virtualization framework. It's part of management, configuration manager, for example, VMM, group policy, all those tools. It's a first-class citizen. It's an equal citizen. The fact that it's free, you're not losing anything, except you don't have things like Active Directory and file server components. The $C share still works, but it's not a file server.
Right.
It's not licensed to be a file server. It's licensed to be a Hyper-V host and nothing else. And it's primarily what folks that do VDI use. And a lot of folks that do large enterprise data centers. If they have licensing agreements outside of the equivalency licenses that come with things like data center, it's ideal to use. It's my preferred solution. Now, how do you manage it? As I just said, using management tools from somewhere else. You don't really do it interactively, although you do have PowerShell if you do need to.
And there's also other remote management capabilities. So you can actually manage either a server core box or a Hyper-V box using Hyper-V Manager with a remote connection.
Yep.
Likewise, Failover Cluster Manager gives you a full GUI, remote management. Same with System Center Virtual Machine Manager or Remote Server Administration Tools, also known as RSAT. And RSAT is basically it's basically like Server Manager that you could go run on a laptop, a Windows 7 or a Windows 8 laptop, actually connect to your data center resources and manage them just as if you're logging onto the system and have the full console in front of you.
So let's take a look real quick from a hardware standpoint. What can you run on Hyper-V from a scale standpoint?
And it's important to know this is both full version of Hyper-V as well as this free version as well.
And quite frankly, it's a lot. And I'm not going to read the slide, but if you can find me a server that can exceed these requirements, I'll be impressed. This is a lot. And speaking from a real, honest to God, person that does this on a daily basis viewpoint. you're going to hit issues with performance long before you reach things like 320 logical processors, 4 terabytes of memory. At that level, you're looking at what's the speed of the PCI bus on the machine. That's the level of detail you got to get into where you're going to start seeing bottlenecks before you run out of things like this. So
yeah, I mean, 1 gigabyte of RAM for a virtual machine. When I go and present to customers, I regularly, ask the audience, is there anybody in the room who needs something beyond what we meet? And occasionally there's that one guy in the room, the back of the room, who's trying to be smart. Usually they work for a large government organization, and I always get the same answer when I say, what service are you running? If I told you, I'd have to kill you. So it's like that type of extreme high-end service and application that we don't quite get to.
There's so many good wisecracks I could make right now, but I did have a customer of mine last week come to me and go, we need a super high-end server. Because we had performance tests in application. And I said, well, can I put it in a VM? But it won't be fast. Trust me, it'll be fast. How big do you need? Because you tell me you need huge. I need 32 gigs of RAM. I had to refrain from laughing at him because we don't have servers with less than 512 gigs of RAM. It's like, okay, sure. And I need 4 processors. That's huge, right?
The big 4.
I've got 32 processors, but if that's big to you, absolutely, that's fine. So in terms of disk and storage, now we're going to jump into some, because I know a lot of folks saying, show me some demos. We got plenty of demos we're going to show you, but they're coming. We've got to kind of run through this stuff first. So what we do for storage, the big thing with Hyper-V for storage that's different today than what it was a couple of years ago is we now have the option to store Hyper-V on an SMB share. This is new, and this is a game changer, right?
So I guess first, what is SMB?
Server message block, a file share, right?
Okay.
You want to get really geeky. The Common Internet File System, CIFS, is where file shares eventually evolved from, and that branched off to a couple of different implementations. NFS being one of them, and then Microsoft's version of server message block, which is what a Windows file share. So a server message block is the protocol Windows file shares use, and Windows Server 2012 introduced Server Message Block 3.0, which was to go from 2, it was more like going from 2 to 200 than 2 to 3. It's that much better. This is not a minor update. This is a massive, massive update to what Windows does for file sharing. And the scenario that they fundamentally enabled was you can now run applications on file servers. In the past, you couldn't because of the way file locks worked. And so they've added features like SMB multipath, SMB transparent failover. So you can now run Hyper-V SQL databases and all sorts of server applications on file shares and on file clusters. It's a fundamental re-architecture of the way you think about a data center if you go down this path. So big thing to think about. You're going to see me do some of this as we start working through and creating different VMs. And there's 4 things that you have to define storage for when you create a VM. The hard disk files, this is the one that everybody thinks of. It's the big one, but it's not the only one, right? Obviously your VHDs is where most of your I/O is going to come from. Your configuration files, these are little XML files, but they've got to be somewhere safe. They're usually stored, with the VHD.
And they basically define what that virtual machine will look like. Yeah. So the name of the VM, how it attaches to its storage, the amount of memory.
If you open up one of the XML files, you'll see things like network interfaces, hard disks, memory, CPU, all that stuff you would expect to find. Checkpoints. Checkpoints, by the way, is the R2 word for what used to be called a snapshot. VMM called them checkpoints all the way through, and they've now standardized the terminology. So checkpoint, snapshot, same thing. This is the one that shoots a lot of people in the foot, and here's kind of the scenario, right? When people create a VM, if you just take the defaults for everything, it's going to put the checkpoints on your C drive. Mm-hmm. So you go through and you say, I'm making a new VM, I'm going to put the VHD on a hard disk somewhere, nice high performance, big old SSD array, and then the first thing I do is snapshot it. I take a checkpoint. Well, guess what? All the I/O is not going to your VHD file, it's going to your snapshot file. And if you left the defaults, that's on your C drive somewhere. And all of a sudden, your little, 40 gig OS mirror C drive is slow and full. And you're sitting there going, what's wrong? You've got to consider where you're putting these things.
And I mean, as you kind of alluded to, that takes up a lot of file space. And so we often hear, a lot of enterprise admins, they now actually limit their end users from taking checkpoints because a lot of end users, they'll take a checkpoint every 5 minutes as they're doing development, giving them an easy way to kind of roll back if they want to reset something, but not really consider the underlying infrastructure.
Yeah.
Go flood the storage system and then cause other types of problems.
Yeah, and there's other issues with snapshotting and checkpoints as well that you've got to be cognizant of. And one of them, for example, has to do with the way time rolls back. Because when you roll a checkpoint back, you're reversing time, and that has all sorts of negative implications, especially with things like domain controllers. A lot more on that later on. Then finally, your save state. So you can save state a VM, which is the virtual machine equivalent of Hibernate, and it's got a write to a file. So it's going to take all the contents of memory and put it in a file. Well, if you've got 3264 gigs of memory, you need 3264 gigs of disk space to do the save state. And when you boot a VM, Windows wants to make sure you can do a save state, so it'll reserve that much space on disk. So you get this bin and this VSV file, and it'll actually reserve the space. So you all of a sudden have this big file, and you're thinking, what is that big file? It's a reservation, essentially. And you can turn that functionality on and off. In terms of networking, on the host, what do you got to think about? And here's, what's here on the screen is really obvious and really simple, but there's a couple of things that are not as obvious. Number one, today you're probably using 10 gig, okay? If you're using 10 gig, you can almost be guaranteed that if that 10 gig adapter is being heavily utilized, you're going to have CPU issues, right? 10 gig today is, not only is it faster, it requires a lot more out of the CPU. So you can't just go buy any old 10 gig card. You've got to make sure you have a 10 gig card that has proper CPU offloading, supports things like VMQ and SRIOV, which are designed to optimize network throughput, and is not going to put a substantial load on your CPU. Now, there's a couple of ways you can achieve this. One of them is, there's a bunch of different standards for 10 gig. You can do 10 gig over fiber. You can 10 gig over what's called CX something. Forget. It's another type of fiber, CX4, CX5. Someone will type what it is in the chat, I bet. And then you can do also 10 gig over traditional Cat6e copper, which is the cheapest alternative to all of those. And it's all just standard TCP/IP, but it creates a lot of CPU overhead. So, 10 gig is fast becoming the standards. It's hard, whenever I buy servers nowadays, they've got up to 4 10 gig adapters on them. So how do we start to address CPU? Well, now we start looking at something called SMB Direct or RDMA. RDMA was originally incorporated into things like InfiniBand. And essentially what it does is it takes some of the knowledge that people have learned from using Fibre Channel to create a connection between the host, between say like a server and a file server. So like, let's say we put our VHDs on a file server. So between the Hyper-V host and the file server to create this channel that removes the overhead of TCP/IP and therefore completely reduces CPU.
Remote direct memory access.
Remote direct memory access, exactly.
Yep.
And so within Hyper-V terminology, they call it SMB Direct within the file server world. But you've got to make sure that the network cards and the switches support it, right? Not every network card does, and in fact, there's precious few at this point. Now, we've been trying to buy some that actually support it. And they tend to be on a little more of the expensive side. But if you're looking at scenarios where you want to do live migration really fast, it's worth taking a look at that. Because you can do live migration over SMB Direct over RDMA. And they did, I know if you go, it's free right now if you go on the Microsoft Tech Ed North America website. I believe it was Jose Barreto, one of the cluster guys, did a demo where they took a couple of RDMA-enabled NICs and they put them between two Hyper-V servers. And their bottleneck for transferring VMs between the two servers was the speed of RAM.
Yep.
That's mind-blowingly
I'll actually
fast.
go post the link right now to the chat.
Okay, perfect. I mean, think about that. The speed of memory is the bottleneck for live migration. That's pretty impressive.
The way I like to simplify RDMA and explain it is as you're copying memory from one server to another, you're really bypassing a lot of the actual system processing components on that secondary server and almost kind of injecting that information directly in the memory on the remote server.
Yeah, what the two servers that do is they say, okay, you're RDMA enabled, I'm RDMA enabled. Can we talk RDMA? We can, and essentially it just drops TCP/IP entirely and just DMAs, direct memory access, direct memory copies the data. So all the negotiation, the IP addressing, the ARP, the TCP session handshakes, none of that happens. The TCP stack's dropped entirely, and it just sends raw data. Larger packet sizes, larger everything, faster everything. So in terms of high availability, Windows clustering has obviously come a long way. You were originally on the cluster team. It's come a huge way. Back in when in the
Thank you. Since I joined, right?
Right. Well, I mean, you're 100% responsible for this, right? So back in the days of Windows NT, it was you need an engineering degree and a letter from God to make a cluster work. Nowadays, the validation wizards basically validate every single scenario you can think of and tell you if it's going to work. You've still got to make sure you've got good components. Good enterprise-grade components that are well supported, have good, good documentation, but it's real simple to do. You got a couple of choices here for clustering. You could do Hyper-V host clustering, and today with the advent of shared nothing live migration, it's good to do Hyper-V host clustering, but you don't necessarily have to because you can still move VMs between hosts to do maintenance at Windows. Clustering is obviously better, but it's an additional layer of complexity. You have virtual machine-based clustering, or what we call guest clustering. So I can have two VMs that are members of a cluster within the VMs themselves. And this is commonly done for highly available application scenarios. Like you see this typically with, Exchange databases or with SQL databases.
SQL in the VMs.
Yep. So they have two SQL VMs, one on one host, one on another host, and the two VMs are actually a cluster in and of themselves, an application level cluster. And then finally, you can do network load balancing, which is going to, not so much clustering, but make sure that traffic is routed equally to both. And so, it's designing high availability and fault tolerance is an art form in and of itself, but you have all these choices.
Now, a lot of questions that I get is, when do I use failover clustering? When do I use network load balancing? What's kind of the design decision point between the two? Now, the way you want to think about this is you're going to want to use failover clustering whenever you're using shared application data, meaning that you have a single, consistent, authoritative source of the information. Let's say a SQL database. That would be using a failover cluster. SQL service runs on one node, writes to that shared database. If the SQL service fails over to a different node, it still has access to that same shared set of information, consistent shared information. Now, network load balancing, on the other hand, is really optimized to distribute traffic across identical hosts. So if you have, let's say, just a front-end website, local attached storage for the actual IIS server, and all you want to do is distribute incoming clients across these different servers and provide high availability through redundancy, that's when you'll use NLB. And so if this comes up on the exam, do I use failover clustering? Do I use NLB? You want to think whether it needs a single, consistent shared source of data. And that's why one of the requirements of failover clustering is to have shared storage. Now, in the past, we've had to use traditional SANs for shared storage. iSCSI, Fiber Channel, serial attached over SCSI, or even Fiber Channel over Ethernet. But one of the biggest advantages of this new Hyper-V capability over SMB is the ability to actually use a file share, an SMB share, as your shared storage. If you kind of think about it, you have one server that can access a file share, a second server that can access that same file share, see the same information. You've essentially created an easy to implement version of shared storage.
If anyone has ever had to run Fiber Channel, oh dear God.
You've had fun with it?
Oh dear God. I've run plenty of Fiber Channel, and it's the thing I dread more than anything in the world because it's complex, it's scary. You make a mistake, you take everything down. And we'll talk more about that. We've got a whole section of failover clustering towards the end, so I don't want to kind of get too deep into that right now. Let's take a look at my screen for a second. We kind of talked about the installation for Hyper-V. Let's actually look at how we do this, right? So there's two ways you can install Hyper-V. The first way is PowerShell. PowerShell is a piece of cake. We're going to use the get Windows feature commandlet. Windows feature, there it is. And I'm just going to look for anything that has the word hyper in it. And so it's going to go through, do a quick interrogation. There's all the Hyper-V stuff that I can install. And so I can literally install Hyper-V by taking this and just saying, just install Windows feature. I'm not going to run that because I'm going to do it through Server Manager, but this is all you would have to do. That would add all the Hyper-V components. You can add things like include management tools, include all the sub-features, and get every component of Hyper-V done this way. And the neat thing about doing it via PowerShell is you can, with PowerShell remoting, just send it to your 10 servers, run the command on 10 servers. I can take this exact same command and do something like this. ICM, which is the short term for invoke command, server 1, server 2, and then just run the install PowerShell command right there. So again, not a PowerShell course, but this is how simple it becomes. From Server Manager, under Manage, Add Roles and Features, hit Next a couple of times. Not that many times, one less time. And we just check Hyper-V. Click Add Features to get all the dependent features. Click Next a few times, and we're done. So you're going to see a few initial questions when you go to install the role. The first one is, do you want to enable virtual machine migration? So this is what we refer to as shared nothing live migration or storage live migration. We'll do more on this in the virtual machine mobility module towards the end of the day. I'm not going to turn this on right now. I'll show you how to turn it on once Hyper-V is installed. Default storage locations. This is what I had mentioned a few minutes ago when we talked about the storage options. These are the defaults, right? So when you create a VM, if you just do what I call the mother-in-law method, which is click next, 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 which is what my mother-in-law does, you're going to wind up with VHDs on your C drive and snapshots on your C drive. The configuration location is where the snapshots wind up living. And I have make a habit of changing these when I install Hyper-V.
Now we could of course change it later as
Absolutely.
well. You're not locked in.
It's just a default. So I do, for example, I've only got one drive on this box, this little demo server.
Now, when you go and do this using Virtual Machine Manager, there's actually a capability called a physical computer profile, or also known as a host profile. And that actually allows you to kind of create a template for your virtual machine host, this being one of the settings, so that you could consistently apply that across all your Hyper-V hosts, get that updated storage.
So you could deploy 10 Hyper-V hosts, use the mother-in-law method, and then just apply the policy. It'll fix everything for you and put everything where you want it to be, and they're consistent at that point. And then, so we click Next a few times, hit Install, and it's now going to do the work. Now, this is going to require reboots, so we're going to leave this server, do the old cooking show method, and go, here's one I installed previously.
Nice.
And so what you get when you're done, to kind of jump back to the slide for 2 seconds, number one, Hyper-V is installed as a role, and the hypervisor is added and starts automatically. And you can see this by going to there we go. By going to a command prompt as an administrator. Let me just increase my font size.
Now, while you do that, one question that we often get asked during these exam prep courses is, how much do I need to know about PowerShell? Now, we can't tell you what's on the actual exam, right? But some best practices, some recommendations I have from taking the other exams, just kind of familiarize yourself with the most common command list. Things such as installing the cluster, installing the Hyper-V role, enabling the different types of storage, creating new virtual machines. It's probably not worth investing the time memorizing every single commandlet, but definitely spend a few minutes kind of getting the overview. Now, one nice thing about PowerShell is their naming consistency across all these different modules, all the different commandlets. So if you're kind of familiar with other types of PowerShell, the get verb means I need information, install means install. There's a lot of consistency built throughout these other modules. So you can intuitively kind of figure out a lot of them. But nevertheless, definitely worth spending a few minutes kind of reviewing them before you go take the exam.
The other thing there I would say is know what you can and can't do in PowerShell. That becomes a pretty key thing, because there are cases where there's something you can't do in the UI you can only do in PowerShell.
Ah, so the gotchas kind of.
Those are,
which do you?
Yeah, those are fairly important. To know if you need to go to PowerShell to do a particular task. And there are lots of things in Hyper-V, for example, network virtualization, that you can only do in PowerShell or VMM. You can't do through the UI management tools. So I'm just doing a BCD edit here real quick with an enum parameter. And you can look, if you look at the very bottom here, this standard boot configuration parameter, hypervisor launch type auto, tells me Hyper-V is booting. And you can look at this on any machine. One thing I've seen this more times than I care to count. Heck, my own data center admins are guilty of it all the time, if you guys are watching. You should be watching if you're not. Most servers, when you first get them, virtualization is not often turned on in the BIOS. You would think it would be. 90% of the time it's not, or in some cases it's even from the same shipment it's inconsistent. If you install Hyper-V, it says hypervisor launch type is auto, but you can't boot a VM. You got to go into the BIOS and make sure that virtualization switch is turned on, and that's in various places on various pieces of hardware. The thing to look for is the event log. So if you go, Hyper-V is installed, can't boot a VM, what's going on? Look at the event log. There'll be a whole bunch of big red X's saying hypervisor couldn't be started. because hardware-assisted virtualization is not enabled. It's you can't miss it.
You know, one time I've kind of come across that same problem is when I've installed the Hyper-V role but forgot to reboot. It was just installed, pending in the background. I launched Hyper-V Manager, same error, cannot connect. So if you get into kind of one of those troubleshooting scenarios, you know, want to double check this, make sure it really is installed. And
the other kind of real-world gotcha, and this one's really dumb. There are servers out there where if you install the Hyper-V role on them and reboot it, and turn on virtualization in the, well, actually, there's nothing to do with the install of the Hyper-V, but turn on virtualization in the BIOS and just reboot it, it's not enough. You've actually got to power it off, as in like pull the
power cycle,
ton the power, like no power. I've seen servers over the years where that's been required. Not recently, but you know, you might not have some of the newer hardware that we have. But certainly that's something that's, you know, it's on in the BIOS and what's going on, and you spend hours troubleshooting and just pull the power cord, wait 30 seconds, put it back in. Oh, it works now. So Hyper-V is now installed. We're going to take a little bit of time and just kind of walk through some of the admin tools for Hyper-V and what they are, what they look like. So first of all, the Hyper-V console. This is the standard MMC console that's used to manage Hyper-V. So what it looks like is this. So within Server Manager, I'm just going to grab Tools, Hyper-V Manager. Here it is right here. Pretty straightforward list of Hyper-V servers that you can connect to over here. I wonder if there's 4 done yet. We're just going to let 4 reboot itself. I'll kick that off in just a minute. And then over on the right-hand side, the standard actions pane. And as you click VMs, you know, obviously you get different settings and things of that nature. And so you've got a few things in here that we're going to work with throughout the course of the day. Obviously a new virtual machine, new virtual hard disk wizard, the ability to import virtual machines, run through the settings, work with disks, work with the Hyper-V management service. The Hyper-V management service is the component within the Hyper-V server that gives you the ability to manage all the different VMs and perform actions like start, stop, pause. You can restart this service if it misbehaves. From time to time, we found it'll hang or something will happen. You just recycle it, like any service. Doing that is a safe thing to do. It doesn't actually restart the VMs or anything. The whole console goes dark and it looks really horrible and scary, but the VMs are quite happily running in the background and still servicing clients on the network. And then with individual VMs, you've got some summary information, whether they've got what type of memory they've got enabled, the types of networking information that's available, even network adapters and IP addresses, and then whether they're set up for replication. Now, 2 things I'll kind of point out about Hyper-V Manager. Number 1 is this tool, for some reason, tends to use a lot of memory. So if you're running it locally on a server, I would not advise leaving it running. We see a lot of people that will, log into a server, fire this thing up, and then just disconnect as opposed to log off, and it's just churning in the background using up, lots and lots and lots of memory. And secondly, if you have a lot of Hyper-V servers in this console, like I've seen upwards of 30 servers listed over right here, it can slow down pretty badly. But if you got 30 servers over here, why the heck ain't you looking in VMM, right? Because this is a really, really bad way to look at that much. But regardless, those are kind of the two pieces to that. So in terms of getting that console, you'd mentioned earlier RSAT. You can add this console on a Windows 8 machine, as I've done here as well. So I've got a Windows 8 client machine here, and on this Windows 8 client machine, we've got Server Manager. And within Server Manager, now what I've done is added the remote server administration tools. I can add Hyper-V Manager, which I actually haven't done. Ooh, excellent tip. That reminds me.
There you go.
Excellent tip. So I've added the remote server administration tools. Why isn't Hyper-V Manager there? Do you know?
You tell me.
Ah, I think I got it on one. Because Hyper-V is available as a local role on Windows 8, it's actually separate. So to add the Hyper-V management tool here,
I did not know that. That's a good tip.
Need to go to Programs and Features.
And go add Hyper-V through there.
Turn Windows features on and off. I love ad hoc demos I didn't think of. And then there's your Hyper-V management tools right there. So we check that, we hit OK, and it goes through and does its thing. Takes but a couple of seconds, or a minute for that little tiny 0.10% on the end to finish. And at that point, we get the Hyper-V management tools, right? Now, there we go. So we go back to Server Manager, and there's Hyper-V Manager now. So there you go. and I can now go connect to, obviously other servers and just do administration from here. So HV3, and away we go. So now we're a happy little camper here using remote server administration tools.
One of the most common questions I get, though, about using Hyper-V on a laptop, Hyper-V on Windows, is about these other data center capabilities, like can I live migrate a VM from my laptop to someone else's laptop? And the answer to that is no. When you're actually using client Hyper-V, we do really kind of scope down the features so they are running local. So you don't have Hyper-V Replica, you don't have a live migration available. So be cautious about that. If you have an exam question where someone's having trouble doing these types of migration, that could be a reason why, because they're developing on a Windows 8 computer instead of on a Windows Server computer.
Can I be in really, really uber geek for a second?
Absolutely.
True story. I run server on a laptop. Myself and a colleague of mine were in a hotel. He was a floor above me. He was exactly above me, one floor. I was working on a VM, and he needed, and we're just lazy because it was late. So a little shared wireless connection. Live migrated the VM over wireless to his laptop.
Very cool. Now, just to clarify, you were running server on the laptop.
Server on the laptop. But yeah, it was like,
cool.
Want a VM? Here, let me toss it through the air. I mean, it was just one of those things where we both kind of went, think we could do that? Well, we got to try.
That'd be cool.
It took like 3 hours to live migrate over wireless, but it worked. At that point, we're like, well, we should just walk it downstairs. No, we're going to do this just to see if we can, and we did. So yeah, it's air toss for VMs.
Nice, nice.
So in terms of the PowerShell module for Hyper-V, there's a lot of things you can do in here. One of the common questions that I see come up is, okay, PowerShell Hyper-V, right? With Windows Server 2008, there was a set of community commandlets that a guy by the name of James O'Neill produced. Great, fantastic, not supported community stuff. They're on Coplex. Server 2012 introduced a native PowerShell provider, or a PowerShell module, which is great. Very similar. If you're on 2008 and you're using that community commandlet, the structure is very similar. There's some syntactical differences, obviously, and there's some noun-verb differences, but it's not a huge leap. But there's a ton of things in here. If we just go over to a Hyper-V machine, let's take the client here, because I should have this module available to me, and I do get command module Hyper-V. Should give me all the available Hyper-V commandlets once it compiles the module.
Yeah, and there's quite a lot, several hundred of them actually. I think 178 last time I checked, which was actually surprisingly recently. So you can really do a lot using PowerShell, kind of end-to-end coverage, deploying, managing, getting information, and then taking advantage of PowerShell's other capabilities like its batch scripting, taking information from one commandlet, passing it to another commandlet, and really trying to use it as a conduit between these different systems. And we're going to be talking a little more about automation later, but we definitely want to remember that PowerShell is one of our key automation capabilities.
Yeah, so there we go. Here it is right here. So just kind of scrolling a bit. There's a ton of stuff in here. And when you add VMM on top of that, VMM brings another somewhere on the order of 600 commandlets that you can use to manage a Hyper-V infrastructure. So there's really nothing that you cannot do via PowerShell. Whatever the question, the answer is always PowerShell.
Always PowerShell.
So I certainly don't need to obviously know all these, but be familiar with what you can and can't do, and generally how you go about doing things. And then we have Windows PowerShell ISE, which is the graphical version of the tool. And the ISE's come a long way with R2 from where it was with 2012. Probably the best and most valuable thing is this show commandlet, which is part of the ISE framework. And what that actually does is it's a graphical way to write a command line tool. It feels kind of bizarre because I'm sitting here going, well, we got PowerShell so we get away from the console, but in order to write good PowerShell commands, we need a graphical tool.
Now there may be
some spins.
Well, there may be some questions that could come up about PowerShell ISE. PowerShell ISE stands for the Integrated Scripted Environment, and as Corey's kind of demonstrating here, it's basically like a Visual Studio type experience, but for scripting. So giving you some guidance of how you can go build these commandlets. So if you get questions about, hey, there's a bad PowerShell script, how would you go about troubleshooting it? A good example might be, go use PowerShell ISE. It gives you the ability to step through the individual commands within your scripting environment. And so you can kind of use this to ensure your scripts are working, test them with different breakpoints throughout.
Yeah, so there's the ISE right there, and it's just a matter of, get VM server, or computer HV3. And so this is how I begin, write in document to script. And then when I'm ready, I can highlight individual lines and run the whole thing, and it goes out and does the work for me.
Nice.
And so I actually use this quite a bit. We use PowerShell a lot for automation, so this is a place where I spend a significant, disproportionate amount of my day. Is doing little automation things to figure things out and adjust things and fix things and tweak things and whatnot. So in a workgroup environment, so you mentioned we need a domain. If you need to run Hyper-V in a workgroup environment, or the other scenario is, you need to manage a Hyper-V server on a domain that you don't necessarily have local access to. You bring in your laptop and you're not in the domain, but you need to manage a server on the domain. You can do that. There's a utility called HV Remote. HV Remote is on Codeplex, I believe it is. It's somewhere on the TechNet or MSDN Download Center, and it's just a little community-based tool produced by Microsoft that allows you to enable authentication to a Hyper-V server outside of a domain. So it turns on things like CredSSP, set certain firewall rules, set certain permissions, and you go from there. So that's the HV Remote tool, pretty straightforward. Within Server Manager, you have the Hyper-V Best Practices Analyzer. And so this is a good thing to run on, essentially, once you get your server up and running, you pop in here to Server Manager, and Server Manager, without getting too deep into it, is new for 2012 and 2012 R2 and breaks things down based on role. So we click on the Hyper-V role, which it auto-detects based on when it interrogates the machine what's installed, and displays information only relevant to Hyper-V, including events, server names, and as you scroll down through, services that are running, and then this thing called the Best Practices Analyzer. So you can take that and run it, and what it's going to do is run a scan on the machine and see if it matches the recommended practices for a Hyper-V server. This will take a little bit of time to run. This is not going to be instantaneous. And the reason is that it's got to go through over 110 rules. And it looks at things like, hey, where are your checkpoints stored versus your VHDs? What's the percentage of RAM versus running VMs? How do you have management switch? Do you have a network interface for management and a network interface for VMs to use? All these different things, and then give you a series of recommendations. You could take that and action it, not action it, whatever you want to do. But it certainly is a good, if you're not as familiar and you go, okay, did I do a good job? It'll tell you if you did a good job.
And that's actually a good troubleshooting tool and technique that you may get questions on in the exam. Now, there's actually two different types of best practice analyzers that you may get exposed to. There's this one with Core Hyper-V. There's also one with failover clustering, known as the Cluster Validation Wizard. We'll cover that later, but essentially they cover many of the same standard tests, making sure that you follow these best practices for virtualization. They are complementary, and but the difference is you would only run the cluster one if you're actually going and building a cluster.
Yep.
But not only are they good for when you first deploy the environment, but also troubleshooting while in production. So all of a sudden something doesn't work, go run this best practice analyzer. It may point you to some type of configuration change that could have shifted, some other setting that maybe a different administrator had changed without you being aware. So it kind of gives you that foundation again. Make sure everything is as it should be.
All right, so next topic is security. How do I secure access to a Hyper-V server? This is a bit of a huge kind of question, right? And there's two big answers to it. One is, locally on the server, there's a very rudimentary kind of security model, which is you're either an admin of the box all up, in which case you can do whatever you want. There's also this notion of a Hyper-V administrator, which is an administrator account that can only manipulate Hyper-V settings. Then we often get the question of, well, individual access to individual VMs. There is almost no support within Hyper-V by itself for an administrator to give someone access to a VM, right? It's server level. You're either the entire server, the Hyper-V role, or you can get to a level where you're allowed to do specific things. But there's 4 VMs on a server. I want you to be able to modify VM 2. There's no way within this framework to do that that's easy. It can be done, but I wouldn't advise someone try it. It's complicated. That's when VMM comes into play, because VMM is designed to address that scenario through clouds and fabrics,
delegated administration,
where you can get very, very granular over what users can do what on very specific VMs. Within native Hyper-V, what VMM essentially does is manipulate something called the authorization store, which I'll show you briefly. So here's a Hyper-V server. I'm going to run azman azman.msc. So azman authorization manager.msc. This is kind of a generic generic framework that's within Windows to do authorization to different kinds of things. And it uses an XML file for Hyper-V. So I'm going to go open authorization store, and I'm going to go see.
And you certainly could get questions about Asman.
Program data, Microsoft.
So good to understand the best practices around how to set it up, what it does, and what type of security privileges it gives you as compared to doing security using Virtual Machine Manager.
So there's the path, program data, Microsoft Windows, Hyper-V, initial store.xml. And if you open that up and take a look at it, you've got this ability to define access to a Hyper-V server. So there's role definitions. There's only the administrator initially. There's task definitions, of which there are none. And there's role assignments. So you can create groups, for example, you create role definitions. So this one may be interact. And then you can add in specific tasks. Specific operations that you're allowed to do in that role. And so you can see this is, very particular things like start service, stop service, unbind port, view Ethernet ports, and you got to know what all these mean. So it's not simple to do. But when you make these settings, they apply to every VM on the system, unless you get into embedding scripting in here to identify particular VMs based on their GUID. And so yeah, I don't do this. I don't want it. I'll never do this. VMM does this. So when you apply all these roles and policies in VMM, this is essentially where they all land, if you would. Now with 2012 R2, they have simplified it a little bit. One of the scenarios that often came up was, I've got a VM, the VM's broken. I want to be able to go troubleshoot it, but it won't talk on the network. So like something's happened and I'm not getting to it over the network. And the way that you want to do it is give console access. And if you're kind of a hoster, or like within your own company's private cloud or internal setup, giving console access to a machine is not a simple thing to do. So they have introduced a new commandlet with 2012, which is essentially grant VM connect access, which allows you to grant only a specific permission for a particular VM. And so someone that has that VM Connect application, which we'll talk about here briefly, can now connect to the console at one specific VM. They can't make any changes. They can't snapshot it, start it, power down. They can only see the console. So it gives them the equivalent experience of, say, plugging a crash card in the data center. This is new for R2.
So let's move on and talk about our Hyper-V settings now. We kind of went through a few of them briefly, but I think we're going to spend a little longer kind of talking about some additional capabilities from Hyper-V. Remote FX, NUMA, these concepts.
Yep, absolutely. So let's begin with overall settings for Hyper-V. These are the settings that you find in the Hyper-V MMC console. Let's dig down to that guy right here under Hyper-V settings. And so you've got server level settings and you've got user level settings. These user level settings are not something we're going to worry too much about, with the exception of one called enhanced session mode, which we'll get to now in just a second. But at the server side, here's those defaults we showed you when we did the install. So for config locations and for hard disk locations, you have physical GPUs. Now, when we start getting into VDI scenarios, where we want to do remote FX, having a physical GPU in a server gives you certain benefits.
Sorry, what's a GPU?
Graphical processing unit. It's a video card for a server. Now, before you go, video card in a server, they make server-specific video cards. Like there's some of these bigger companies. I think there's AMD. I think makes one.
This is for like computer-aided design,
yeah, exactly.
graphics manipulation, animation companies.
NVIDIA, I think, does one, where it's actually a rack-mounted video card, and it supports like up to 10 servers at a time through a special port. So it's a video card with no video out, for the purpose of getting a GPU to a VM. And again, as you said, this doesn't make it look any better. It doesn't make it perform any better. But if you're doing CAD, the GPU is what allows CAD to flow and spin and twist and be possible. That's the scenario that it enables. So if you're doing something in a VM where you need a GPU for better performance, it doesn't make it look any prettier, but it certainly makes it process things better. Otherwise, it's using the CPU, and that's not efficient. NUMA, we'll talk about NUMA here in a little bit, but NUMA spanning. This is how you configure, enable, or disable live migrations. So this would be the shared nothing version of live migration we'll get to later on today. Same with storage. And then enhanced mode session policy. We'll talk about enhanced mode here in a second. So I'm just going to go ahead and turn this on. And then we talk about Replica a little bit later on in the day. This is where we configure Replica. So these are all just the server level settings that are available. So NUMA.
Non-uniform memory access.
NUMA is one of these technologies that has come about as we've gotten bigger and bigger and bigger with hardware. So as we've moved to servers that are multi-socket, 2, 4-socket, multi-core, multi-threaded. I've got servers up to 32, you open Task Manager, you got 32 processors in there in Task Manager. And then massive amounts of memory. What it does is ensures that the access from the CPU to memory is as efficient as it can possibly be by allowing different CPUs to leverage different physical banks of memory. So you don't wind up with bottlenecks and backlogs. Way back in the past, the CPUs were the memory was a lot faster than the CPUs. Nowadays, the CPUs are getting faster than memory as they get bigger and more powerful. And so it's a way of distributing the workload for CPUs. So this CPU uses this bank of memory, this one uses another bank of memory, and creates this NUMA topology that's more efficient. You don't really have to configure this or do anything, but the applications that are NUMA aware can use this to be better. And Hyper-V is one of those applications that is NUMA aware if you turn it on. And then VMs that have large quantities of memory and large numbers of virtual CPUs can map that underlying physical NUMA topology to be faster and more efficient.
Now, it's actually faster by actually logically grouping all the different memory chips, the transistor chips together. So it really is trying to optimize the actual distance between these different components. And when we think on a microprocessor, the distance is, micrometers. But when you're doing millions of transactions every minute, that distance actually will add up over time. So at the end of the day, it's going to give you better efficiency, faster throughput, and just better memory read.
Absolutely. And if you look at any VM, so I'm just kind of jumping into the settings of a VM here. So here's one that I've got configured. Under the processor section, under NUMA, this is where we can actually tell it to go look at the underlying hardware topology of the machine and mirror it. Now this VM's running, you can't change this when it's running, and it's just a single core VM. But if I put a number of cores in this VM, it may create multiple NUMA nodes within the VM and then tell the VM to use multiple sockets. And so you do this when the VM's powered off. You can't change it once it's running, but when you put it on the machine, if you've got a very powerful machine, and the machines are, if you're building a cluster, for example, likely your nodes are going to be essentially the same. As it moves between them, it'll preserve that optimal topology. So something to think about if you're making, large high-performance VMs for databases or things of that nature. Things like SQL, things like IIS for high-performance web servers, they care about NUMA. They want to do this. RemoteFX is a very misunderstood technology. RemoteFX came around initially with the advent of VDI on Windows, and it was often thought of as, hey, this is going to make, graphical desktop, RDP better over a WAN link, and it's not what it is at all. RemoteFX is a way of manipulating the user experience so that it's equal on the local machine, so on the machine you're working on, if you're in a VM, to what it will be if you're on the physical machine. So things like USB redirection, bidirectional audio, cameras, automatically detecting devices that you plug in, but at the same time it also enables the GPU. And so you get this when you enable the remote desktop host virtualization role for VDI. This isn't really relevant to server level applications. So if you're virtualizing a SharePoint server, a SQL server, you're not really caring that much about RemoteFX. But when you get into VDI, this matters. And it only matters really when you want to have highly graphically intensive applications that use GPU for processing. GPU has nothing to do with how good something looks. It's how fast it can draw a picture that's based on 3D rendering and a lot of mathematical calculations. So the GPU is a big math processor. And so it puts that math processor in the VM, optimized for graphical work in addition to the CPU.
Well, next we're going to talk about enhanced session mode. This is actually my favorite 2012 R2 feature. Essentially what this does is gives you the ability to go and have remote desktop for the VMs running on your host. So when would you use this? I mean, how do you take advantage of this?
Well, so for starters, if you're an admin and you want to work in a VM, and you just kind of access it by double-clicking on it, what's going to happen is, I'm going to just hit X on this. This is what you're kind of used to working in.
That's the default, that kind of reduced spacing.
And you go, I'm going to log on to this guy.
I mean, we had some trouble with that not too long ago. Our team was trying to create some demos using this, and due to the reduced frame size, we actually couldn't capture our full demos.
Yep.
We needed to go connect additional network connections to our VM, and then do a full login over remote desktop to that VM.
So the only way that I can get data into this VM right now is over the network. This is a kind of an RDP session, but I can't copy paste. There's no audio. There's nothing. And in fact, to kind of prove the point, let's go take this little VM right here and let's just drop them off the network. And so this is a VM that I got to troubleshoot, and it's fallen off the network. I need to get a log out of it. What do I do? There's no way to do it. The network's the only way to get data in and out of the VM. With enhanced session mode, rather than the RDP connection coming into Hyper-V, it actually plumbs it all the way through a special integration component to the remote desktop services endpoint in the VM. So you get the functional equivalent of a traditional remote desktop session without going through the network stack. So even though that network adapter is unplugged, which you can see down here, if I just disconnect, reconnect again, this time, because I've enabled the enhanced session mode, I'm going to drop this down really small here, hit connect.
You'll be able to do the full copy and
Absolutely.
paste. And now you could copy and paste, not just out from VMs, but also back and forth. So I've actually been using this quite a lot frequently as I've been building a lot of virtualization labs. I'm in the process of building a whole bunch of system center labs. And every now and then I need to go and add new content, add a new VHD to our library, add a new template, go and add some the Cloud Services Process Pack for Service Manager. And being able to just do a copy and paste has saved me many hours, because when I want to add something to the VM, just copy and paste it. And this can even hop across multiple RDP sessions. So I can connect and copy something that I download onto my laptop through to my Hyper-V host over my initial RDP connection, through to the actual VM running on that Hyper-V host directly. So it'll save you a lot of time if you do a lot of kind of VM deployments, VM configurations.
So while you were listening to Simon, you probably saw that folder copy right on the machine. Again, no network connection. That's what this lets you do. Works great for code, works great for text, anything you want. 3 things you got to do to set this up on the Hyper-V server level. By the way, only R2. On the Hyper-V server level, Hyper-V settings, you got to turn it on right here under the server. You got to turn it on right here under the user section. And then within the VM itself, under its settings, pull those up. We go down under integration services, and we'll talk about those in a little bit. And we've got one called guest services. So those 3 things. So turn it on, server settings, user settings, and then there's an integration component called guest services, which is turned off by default when you first create a VM. And that's it, and that's away you go. And it uses NTLM for the authentication protocol. So it's pretty neat. We don't need that. So the next component here that we're going to kind of talk about is resource pools. Resource pools are it's a new thing for R2, very powerful thing that increases the flexibility of the data center. This is another one of those components that you don't see unless you do PowerShell on Windows Server, but VMM exposes this quite well. So the idea here is that if you were going to, in the past, migrate a VM from, say, one cluster node to another, you needed matching network adapters. Okay? If you have those matching network adapters, if you don't have matching network adapter names, the live migration would fail. So your VM's connected to, for example, external, and you need a matching network named external on the other host. With this, you can have 2 network adapters with different names associated with the same resource pool. And as long as it's got an adapter in the same resource pool, it'll choose any one of them, any one of the available adapters. So you can add, remove. It gives you that flexibility without having to change anything around, that the VMs can rely on the resource pool. And this is fine for processors, for memory, for Ethernet, for VHD files, a lot of different areas. So it's a container of objects, and any object in the container is considered valid for the purpose of moving a VM around.
So moving on, let's talk about host storage and host network in here. So what we're really trying to do is go and figure out how we could best design our data center. Now, since we're at the top of the hour, we're actually going to go ahead and take a 10-minute break. We'll see you shortly, and then we're really going to focus on these best planning, best practice considerations for deploying your storage fabric. We'll see you soon. Welcome back to the Server Virtualization Jumpstart. I'm Simon Perryman, Microsoft Technical Evangelist, and joined again by Corey Hines, President and Lead Architect of Hull Systems.
And I'm sorry. Well,
Sorry for what?
Well, we ran a bit over on the last one. The problem is I love this stuff so much, I can't stop talking about it.
A lot of good content, and I mean, we had so much on storage, we didn't want to hold you guys back.
Yeah, well,
I know you're pretty passionate about storage.
Storage is my favorite thing
And
in the world.
SMB as well,
Yes,
right? I know we're going to hear a lot about SMB storage.
Yeah, you could stop me because we might be here till 5 talking about this thing alone, but we got a lot to do, so let's jump right in. So first of all, I mentioned earlier, get this thing done here. Okay, there we go. There we go. So mentioned earlier, there's a thing I'm basically in love with now, and it's called a cluster in a box.
Cluster in a box.
Cluster in a box. Now, in and of itself, it's not an entirely new concept, but if you start looking at deploying, especially Windows file server storage, right? So if you're going to deploy Hyper-V on SMB, which is Hyper-V on a file share, you better make darn sure that the file share is highly available, right?
Okay.
Just like if you talk to any guy that's building a cluster, you say, okay, your SAN, right? What do you tell me about your SAN? They're going to say, well, it's going to be dual controller and going to have multiple paths through multiple switches, and they're very, very passionate about the particular configuration that this SAN has to have to make sure that it's not going to go down, right? It shouldn't
redundancy
go down.
everywhere.
Exactly, and so when you start looking at building a Windows file server, if you're going to run Hyper-V on that Windows file server, you've now got to have, if you do what's traditionally done, which is like fiber channel SAN, you've now got to make sure that you have that exact same level of redundancy and availability on the file server level. So you've got this kind of twin layer of uber complexity where I've got multiple HBAs going to multiple switches, going to multiple ports on the SAN, the lunning, the zoning, all that work's got to be done. Then on the front side of the file server, I've got to make sure I've got Ethernet ports that go to different Ethernet switches that go to different Hyper-V servers, and it just becomes very complex. And so what Microsoft wanted to do was introduce this idea of a storage appliance running Windows to kind of remove some of that complexity. And I love these things. I've already bought 3 of them. I've spent over $150,000. I'm planning on buying 3 more real soon. So this is I love this stuff. But if you think about it, have a look at what typically makes up the back side and the front side of a SAN, right, of a traditional SAN. So to relate this back to you guys that do SANs for a living. So on the back side, you got multiple physical interfaces, pools, LUNs, storage management technologies. On the front side, behind that, you've got a SAS bus, which is what's on the inside of most SANs, and then disks plug into it, right? So 6 gig or multiple 6 gig SAS buses, and the disks are all plugged in there. And that's what everything is. Period. And you have all these abilities to do pools, to do LUNs, to do provisioning, to do snapshot zoning, and depending on the amount of money you spend and the grade of the SAN you buy, you get all sorts of fun stuff. On the front side, you've got interfaces. Might be fiber channel, might be iSCSI, or might be SMB, for example, fiber channel over Ethernet. But this is basically what a SAN enclosure is. It's 2 controllers on the back side, a SAS bus on the inside, and a bunch of disks plugged into it, and then a piece of software that presents all the disks as logical units of storage. That's what, and you deploy more than one of these. That's what a Windows storage appliance is, right? It's a set of cluster nodes, so 2 cluster nodes in a single enclosure with a shared SAS bus and a bunch of disks and a JBOD. JBOD, just a bunch of disks. It's the coolest acronym, I think, in IT, personally. So JBOD of disks, 2 Windows Server file server nodes that have multiple Ethernet ports out the front end. So you have the exact same logical architecture of an enterprise-grade SAN without any of the complexity of having to plumb the storage in addition to the cluster nodes, typically on less power, in less use, and typically very, very simple and easy to configure.
So who actually is building all of these pieces and putting them together? Is this the OEM that's providing these?
It's an OEM-based solution, and there are companies that do this. The one we're using today is from a company called DataOn, which I bought 3 of their things recently. And we'll show you some pictures of it here in just a second, but it's essentially a 2-node cluster powered by storage spaces. So the storage spaces engine, which does tiering, deduplication, all those enterprise-grade SAN level functions, and just presents it as a 2-node file server. So when you're going to store Hyper-V, if you want to bring up another Hyper-V server, all you got to do is add it to a file share.
Now you mentioned spaces. What exactly is storage spaces?
Well, actually, we'll get to that in just briefly in a second. Want to kind of just show you what the architecture of a cluster in a box kind of looks like. So this is this block diagram kind of shows you what the logical architecture is. So you have two server nodes, typically inside the same enclosure, each one with a storage controller. The storage controller has multiple paths through local storage or through an expander port, which can go to external JBODs. You just add them as you go. We've done two configurations of these for our data center. One is 12 SSDs plus 24 or 48 external disks in two JBODs. Actually mount them back to back, so we use up less space. And then one that has 72 disks inside the single enclosure. That's a 4U enclosure. And with having a mix of SSD and spinning disk, we get to take advantage of storage tiering, which is a great new technology as well. So this is what it literally physically looks like. And this is actually one of the ones we own, two of these. We're planning on getting a couple more. If the Data guys are listening, they're probably going, "Hey, another order." It's coming. But you can see at the back where, if you were to look at a traditional SAN, you'd probably be thinking, well, that's where the controllers slide out, and that's what they are. The nodes function as controllers. All controllers are in big enterprise SANs are little mini operating systems that control disk I/O, and that's what these things are. With the benefit of, rather than you having to run fiber channel, deal with multipath, deal with DSMs, deal with LUNs and zoning, all you do is present a file share. It's so easy. And then when you want to create a new VM that's on the new wave SAN, the cluster in a box, the new age SAN, you make it on a file share and you're done. And I'll show you this here in a little bit because I've got this running on my demo environment. So as a comparison from traditional storage, like a fiber channel or a SCSI array, storage tiering, you get that. Data duplication, you get that. RAID resiliency groups, pooling, disk pooling, high availability, write back cache, copy offload, and snapshots. Now, a lot of the guys that are real SAN gurus, there's this, my big huge SAN I paid $150,000 for, this isn't as good as that, and they're right. The really high-end enterprise SANs offer functions and features well truly above and beyond what the Windows storage appliances with cluster in a box offers, and that's fine. There's a place for those, right? But as a low-cost, highly performant, highly flexible solution for failover clustering for file servers, you really can't beat them.
Now, another advantage as well is since you're actually managing this using Windows Server itself, the underlying hardware can vary. You're not really going to have to be locked into the same OEM, the same hardware provider. You could get a cluster in a box from one organization, another from another, and have a variety of actual different back-end storage providers, yet you still manage it with a single consistent interface, still using Windows Server file services. Yeah. So give you some more flexibility with your pricing and costing model as well.
The big objection that I hear when I talk to people about this is they go, well, it's a two-node cluster. I want to add a third node. And okay, you can't add a third node if it's a two-node cluster in a box. But that's just a trade-off you have to decide to make. If you use, for example, a traditional SAN, you want to add a third and fourth node, you can. With these, they're fixed, but they're not. There's not just two-node cluster in a box. There's also some companies make 4 nodes.
16 larger. Yep.
So, it's a matter of kind of planning in advance. But you're right. Like when you buy a SAN, you can't choose to add a third controller to it. This kind of operates in the same methodology. One of the things that's new for Windows Server 2012 R2, we're not going to spend a lot of time on this because this is not a virtualization technology per se. And I know there was a jumpstart recorded a couple of weeks ago that focused on storage. So you want to find the link and post
that. Say that on the Microsoft Virtual Academy. Yep.
You'll be able to kind of get more detail on this. And I also know that Rick and I did this in our jumpstart a number of months ago. We showed some demos of storage tiering. But essentially, you can have some solid state drives, so some expensive fast SSDs, and some less expensive, not as fast hard drives. And the ratio that a lot of people have kind of settled on is 10% to 90%. So 10% SSD, 90% spinning disk. And what the storage tiering will do is automatically move hot data to SSD and leave cool data on hard drive. So you get the performance of SSD for the data that you hit most often. And it's done at a block level, not a file level. So literally, if you have a VM, part of the VM could be on the SSDs and the rest could be on hard drive. So if you've got a VM that's running SQL, for example, it might work out that the blocks containing the SQL transaction logs need to be on SSD. And you get the benefit of SSD speed for SQL transactions without needing all the SSD space for the entire operating system, including the stuff you wouldn't necessarily need. You can pin files. which means you can force certain files in their entirety to be on a certain tier.
You know, conceptually, I kind of think of tiering as almost like memory, you know, on an actual server. So the things you need to access faster, those get cached in local memory. Quick access, the stuff you don't need gets stored on the actual hard drive. So you could kind of think of it as a similar concept of that.
For those of you that are, you know, really geeky and technical, the tiering, the evaluation as to what should be on SSD versus hard drive is done once a day at 1 a.m. and it's a scheduled task using the task scheduler, so you can change that. Right? You can go in and say, well, I want to do it 4 times a day or twice an hour. It's up to you, depending on how often you think the hotness of data will change. Right? So you can adjust that, and you can also force it with either PowerShell, or you can also force it with the old defrag command. Are the 2 ways that it actually does it, and both those tools can report how effective that's actually being. So.
Now, we mentioned storage spaces a few times. Let's go into some more depth here.
Okay, sure. Actually, let's go have a look at a demo real quick. There we go. So what I've got here, if you want to kind of take a quick look, this is a scale-out file server. We're not going to get too much into the file server component of this, but let me grab Failover Cluster Manager and just connect to this. So what I've got here is a cluster in a box. This is one of the data on units that was actually in the photograph in the slide a few slides ago. And I've set up a file server that's got a file server role, which is running a scale-out file server, which is a new type of file server. This isn't your traditional Windows file server. This is a scale-out file. It's a new kind of file server. And it's got some shares that are running. And there's a share here called VMs, where I actually can run VMs from. And to kind of give you a very deliberate example of what I'm doing here, this Win client VM that's over here on this first node is actually running off that scale-out file server. So you can see here in the path, the VHD for this VM is running on the scale-out file server. Not the actual VM itself. The VM itself is still on the local storage of the cluster, but the VHD is actually over on the scale-out file server. And so this scale-out file server, for its storage, uses a storage pool using storage spaces. You can see that it's got some virtual disks and it's got some physical disks. And you can see the status of each physical disk, slot number, enclosure number, bus type, and all sorts of information on it. So this is the type of thing that if you're a SAN administrator, you're used to seeing in the UI for your SAN. So if you go into, if you use like a Dell SAN or an HP SAN or EMC or XIL or any of those, when you go in there, this is the type of stuff you see. Disks, pools, allocations. And then within Server Manager is where you actually get to administer all these storage pools. So we got a storage pool area that shows physical disks. And this exposes things like, on the physical disks, toggle drive light. Right? So if you have one that, for example, reports as failed, you go, well, which one is that? You can toggle the drive light and replace the failed drive. Creating storage space is just, I've already got this done, so I can't do it again, but it's just a matter of running through a simple wizard, picking the physical disks, and away you go. When you go to create a virtual disk, and again, we're not trying to get too much into this, but you can do what's called thin or standard provisioning. Thin provisioning allows you to define more space than you actually have and add it later, which is a traditional SAN function. If I go new virtual disk, choose the storage pool, give it a name, let's call this one test, and because it's identified that there's a combination of SSDs and hard drives in here, I can do create storage tiers. It'll say, all right, what type, simple or mirror? So we'll do a mirror so it's replicated and protected. We'll do a two-way mirror, and then it go, all right, how much hard drive space do you want and how much SSD space do you want? And I've got very little available because I've used most of what's on here, so I've got just like a couple of gigs left. So we'll go specify maximum size for each of these. Finish the wizard.
Now, you did mention that this tiering is only available on 2012 R2, but Spaces is available on 2012 and 2012 R2.
And 2012 R2.
So you could get some questions, actually asking you about what has come out on the latest version. So as far as the storage capabilities go, Spaces is 2012 RTM. tiering, and what we're going to be talking about, tiering is 2012 R2. And the other thing we're going to be talking about shortly is data deduplication. That was also available on the older version, 2012 RTM as well. So really tiering is the only new one that's unique to 2012 R2.
So moving on to disk duplication. This is something that was introduced with 2012. It's gotten better in 2012 R2. It essentially allows you to take a bunch of disks on a drive, it's not compression, right? The net result is kind of the same, where you put 100 gigs on a drive and you run this and you go, now I got 10 gigs on a drive. Compression does that, but what compression does is removes white space in files. What this does, it looks at it, says, okay, you have this 4 times on the disk, we're going to store it once and record pointers to it. So it eliminates duplicates at the block level, which means it's incredibly efficient on VHD libraries. If you think about it, VHD is an operating system. You got 200 VHDs in a folder. That's 200 copies of the Windows operating system. Think of the duplication. I did a test with one of our archive drives. So we take all these lab VMs and we archive them off just once they're all up and running. We put them on an archive drive, put them on a shelf in case the SAN dies and we got to pull them out again. And we're burning through 50, 60, 80 terabytes of drives on these 2, 3, and 4 terabyte USB drives. Run disk duplication on it, or deduplication on it, and went and got upwards of 98% of the space back.
Well, and that's because so many of them are just Windows
identical.
Server.
Just Windows Server, Windows
With
Server, Windows Server.
Top, tiny bit on top.
And they're so identical that 98% compression. That's not the right technical term, but that's sort of the net result of it. With R2, it now supports running VMs. So phenomenal in BDI scenarios, because if you can run deduplication and you can take all your VHDs and get them down to a smaller disk footprint, that's more of the actual data that can be in RAM cache, which means it'll run faster, which means
so
more
performance benefits as well as
more
storage
can
benefits.
live on the storage tier and the SSD tier. So the result is the coverage you have is much better. So the performance is much better.
Now, one other catch you could see on the exam is R2 also added support for cluster shared volumes, or basically virtual machines that live on shared cluster disks. So if you have a question around troubleshooting, deduplication doesn't appear to actually be saving you any space, make sure you check what version you're running, because deduplication will only work on the CSV on 2012 R2.
And I don't know the answer to this, but parity is or is not supported on cluster shared volumes for deduplication.
Oh, good question. We'll have to ask our team of experts to go look into that one.
There's something about, there's a support, experts figure that out and post up the answer. I know there's a difference there somewhere, but I don't remember what it is off the top of my head. And then finally, offloaded data transfer. This is, so this is not something that's on Cluster in a Box. This is traditional fiber channel, high-end SAN, where if you want to move a file from one server to another and they both live on the same SAN, even though they're on different LUNs, traditionally what you have to do is actually move the file through one server, over the network, into the other server, back onto the same SAN. It might actually land on the same physical disk. That's, in theory, dumb.
Network traffic as well, right?
Yeah, so what ODX allows you to do is say, hey, SAN, move this file to here and reassociate it. And it'll actually, the file will never leave the SAN, and the move is almost instantaneous.
It's often redirecting pointers, not even copying data in a lot of cases.
So, it looks like the file copy happened, but instantly.
Now, could you use this for, say, VM deployment? You want to go deploy a lot of VMs.
I don't know. Could you?
Absolutely.
All right. Excellent.
Do much faster VM deployment because you're basically starting with a VM on a storage array. Say, I need to clone this 50 times.
Yep.
Could be much faster because you're not actually copying that, 10 gigabyte file to a different location. You're essentially keeping it within the same storage.
Can you think of any service that copies VM files really, really, really fast? I can think of one. So finally, SMB3, we mentioned this earlier, huge improvement, right? And so if you look at this list of features that are added in SMB for R2, this is all the stuff that you would traditionally find in a SAN, okay? Transparent failover, meaning if I got 2 cluster nodes and I'm running, this is one of the differences with a scale-out file server. So I've got a VM that's running off cluster node 1, and cluster node 1 goes down. Now, in the past, VM's going to blue screen, storage went away. With this, it doesn't, it just fails over to node 2 automatically, because it maintains a primary channel on the first node, and then through a program called SMB Witness, it has an alternate node that it can flick over to immediately. So if the node goes down, it just falls over, which is what multi-channel is. Which is what you get when you have multi-channel with transparent failover. You have scale-out, which means you can add additional nodes, and it will automatically start to use them. So in the past with traditional file server clusters, the file server lived on one node and the other node was idle. So all the traffic was here.
Active, passive.
Exactly. This is active, active. So all nodes will automatically balance everything. SMB Direct we talk about, there's additional SMB encryption, and there's now a volume shadow copy provider for SMB shares to make sure that if you're doing backups over shares, they can be consistent by taking the snapshot and rolling ahead transaction logs, things of that nature, and then it's all supported via PowerShell. This has to work on both sides. It is not backward portable to 2008. It's 2012 and later only. And then finally, because of all that, you can now run VMs over SMB. That's the end of the day. That's the goal for all this. Is that Hyper-V, almost better than direct attached storage or SAN or iSCSI. It's almost better on SMB because it's much simpler, easy to configure. All the stuff you need is fully supported if you put the right infrastructure in place, and you're basically good to go.
A lot of diverse OEMs as well. Yeah,
absolutely.
Using that single consistent management framework.
Absolutely. So.
All right, well, we've gone and we've wrapped up kind of our host deployment steps, really talking about how we set up our infrastructure, do some planning and best practices. Now we're going to move on and actually look at deploying our virtual machines and managing those VMs on our applications. So what are we covering in this module, Corey?
So essentially, this is your, how do you administer Hyper-V from the standpoint of just, without VMM, how to just do basic admin tasks. Hard disks, virtual machines, types of hard disks, installing and importing virtual machine checkpoints, and some monitoring. And we're going to try to take this to a little bit of a more technical, deeper technical level than what the bullets would imply, and kind of sort of teach you the best practices, the things that are maybe not so obvious. For most people, creating a VM is, it's run through a wizard. It's pretty straightforward, but there's some things you got to be aware of and think about to make sure that when you do it, you don't put yourself, in a bad situation or, kind of paint yourself into a corner, so to speak. So the first lesson that we deal with is VHDs. So first of all, essentially what is a VHD, right? VHD is basically a file format. You don't need VMs to use VHDs. They're supported natively in the Windows operating system. You can use Disk Manager to create a VHD. You can use PowerShell to create a VHD. It doesn't have to contain an operating system. I've had people use VHDs like a zip file. It's a container file format that VMs happen to use. And it comes in different formats and styles and whatnot. When you attach VMs, again, it's the hard disk that a VM is going to use. There's two ways you can do it: IDE or SCSI, so they support both formats. With IDE, it's the limited, maximum 4 disks IDE implementation that's been around for eons. Or you can do SCSI, where you have multiple SCSI controllers, lots of disks per SCSI controller for VMs that have, many, what would appear to be directly attached hard drives. They mentioned Gen 1, Gen 2 VMs in here. We'll get to that in just a second. That's a new thing for R2. So in terms of formats, there's 2 formats you'll bump into: VHD, VHDX. VHDX is the newer format, bigger, badder, faster, better. Right? That's kind of all you need to know. 64 terabytes in size, much more consistent in terms of failure. It's the default format. You can convert from one to the other as long as your VHDX isn't so big it can't become a VHD. And then if you're going to upload to Azure, you want to use VHD formats. There's a convert command with PowerShell, or within the UI for Hyper-V. So you can cancel here real quick.
And for our VMware administrators out there, that'd be equivalent to a VMDK file. Again, just the hard drive that's used by our virtual machines.
You can actually come in here under Edit Disk, point it at any VHD or VHDX file, and do things like convert it, shrink it, make it smaller, change the format
types.
Inspect it, make sure it's valid.
Yep.
So it's all there, and it's all real simple, real straightforward to use. There are 2 basic types of hard disks. There's fixed and dynamically expanding. Think of these as reserved space versus use it as you need it. In the past, there was a performance difference. Today, there's really not, but there are some things you want to think about. With a fixed size, if you create a 2 terabyte fixed size VHD, you're going to wait a little while because it's going to go in and write 2 terabytes of data to your disk. And so depending on how fast your storage is, creating that disk might take seconds, minutes, hours.
But you might not even be using that full 2 terabytes. Right?
Correct. But you have a 2 terabyte disk. With a dynamically expanding, it's instantly created, and the file will grow physically as you add things to it. The downside is it can become fragmented, and you can overcommit your storage. So you've got to plan it accordingly. If you're looking at, I'm going to put, I've got 2 terabytes of storage, and I'm going to put a bunch of stuff on here, and you start adding things to those VMs, it can fill and saturate your storage. So it's something you've got to plan and monitor. I tend to rely on dynamically expanding 99.9% of the time because I monitor storage. I know when I need to make it bigger. I know when I need to be concerned on things. Then periodically we'll defragment stuff during maintenance windows just to get it all nice and clean. But the benefit is I get to provision more than I effectively have and use what I need.
Now, exam question you might see is if you troubleshooted a Hyper-V host and the virtual machines stop, what is a good thing to check? Or check it to make sure that they have additional disk space is one of going to be those best practices. Because if you are using this dynamically expanding disks, you are over provisioned and you run out of space to write, this will cause your virtual machines to shut down. So a good troubleshooted step to check for that, but an even better best practice is implement monitoring so you can detect this ahead of time.
Yeah.
We'll cover that one soon.
So differencing disks, again, they're pretty standard across all virtualization platforms. Essentially what it allows you to do is create a parent disk, and then a differencing disk is effectively a clone, but that doesn't contain any data. And if you look at the little graphic here, as you read data, it's read from the parent. As you write, the writes are intercepted and dropped in the differencing disk. So over time, the differencing disk will grow as you modify it, and eventually, it'll become equal to or greater than the parent. Differencing disks are not generally recommended for any kind of production scenario, except for VDI. Right? Because with VDI, you often will redeploy the VMs, and differencing disks are a good way to do this. In fact, the wizards that come with, I know with VMware, I know with Citrix, and I know with Microsoft, all leverage differencing disks as part of their VDI deployment as a way to quick deploy VMs. So I start with a base image that contains an operating system, rather than deploying the operating system over and over and over and over again. You make differencing disks of it. The only thing you got to make sure is that, if you're doing this, as soon as you make a differencing disk, if you modify the base in any way, shape, or form, the diff is corrupt.
Good best practice.
And I've seen people, that are not familiar with this, create a VM, create a base disk, create a bunch of differencing disks off of that base, and then, I want to put some patches in there. So they go install the patches in the base and think it's going to mirror up. You've just corrupted everything by doing that. Mm-hmm. So as soon as you make a differencing disk, the base is off limits forevermore. If you delete the differencing disk, fine, go edit the base, but if a diff exists that's linked to a base, the base is off limits. If you modify it, you corrupt the diff. That's simple. You can use direct attached storage for Hyper-V. So instead of VHD files, you can directly attach hard drives to VMs. And this is done, it's pretty straightforward. If you go into a VM, you look at the settings on it, and you come down here under the storage area, and I want to add a hard drive, you can see that I can actually go pick a physical disk. And what that will do is map the physical disk directly into the VM. So why would you want to do this? Well, there's a lot of reasons. There are some for, we talked about in the beginning with virtualization, maybe your vendor doesn't support their app in a VHD, so they require it be on a native drive. Maybe you're doing, there's some performance element or some file format they want to use that requires a native drive. It's also a good way to get, if you have a hard drive that you want to, full of data you want to get into a VM, you can directly attach the hard drive. So there's reasons you might want to do this. From a performance angle, there are scenarios where, SAN performance, native SAN performance might be better than VHD, and you want to directly attach the SAN disk to the VM. This is what allows you to do that scenario. So you can directly attach a hard drive if you need to. If you do direct attached, you don't get to do things like checkpoints. You don't get to do things like, live migrations and exports. So you're bound to that physical machine. So you lose a lot of the benefit of virtualizing when you go to a directly mapped hard drive. there's a new capability that's been added for R2, and this is one that you want to spend a little bit of time on when you're looking at preparing for an exam and studying and whatnot, which is virtual hard disk sharing and QoS. So these are two brand new things for Hyper-V R2, and let me kind of explain briefly what they are. So if I take a VM here and look at the settings, and I take a hard drive and just kind of expand my way down through into this advanced features area, I have an area called Enable QoS. Now, what this does is limits the IOPS that Hyper-V will allow a particular VM to write to a VHD. So this is something that I know folks have wanted in Hyper-V for a couple of versions now. The ability to not have a single VM that's consuming all available disk I/O.
Because that could negatively impact everything else on that host, right?
Absolutely.
They'd be starved for their own disk I/O.
And so folks are well and truly used to the guys, talk to the guys that do your firewall, right? They've got QoS policies on what you can FTP, what you can stream for media, how much you can put on Facebook to prevent any one protocol or method or whatever from saturating the entire line. You can do the same thing now with storage. You can do this with networking. So this is, on the network adapters, this has been in there for a while, where you can actually go in and configure somewhere in here, there you go, network bandwidth management. But it's now been added as well to the VHDs themselves. So you can come in here and say, for example, 100 IOPS is all it allows. It does an 8K increment. Now, the 8K is relatively important because if your underlying disk system uses 4K IOs or 16K IOs, you've got to factor that into what this is. So, for example, if you're looking at your underlying storage and saying, I want to limit it to, 200 IOPS on my SAN, but my SAN does 4K IOPS. You would put 100 in here, right? Because this is twice as big. Likewise, if your SAN did 16K IOPS, you might put 50 in here. You might put 400 in here because you got to do the math on it, basically. So pay attention to that. Know that this is an 8K IOP, and know that if you've got a SAN that does a different level of IOP, you may have to configure this a little bit differently.
Now, minimum bandwidth for networking and minimum IOPS for storage. This guarantees that particular VM always gets at least that much, right?
Correct. And if not, it's going to generate warnings, right? So if it cannot satisfy the minimums, you're going to see warnings appear in the event logs. It doesn't guarantee it per se because it might not be possible, but it will tell you. It will tell you that, hey, you don't have enough to meet your minimums. And then the max is how you would limit something entirely. So that huge SharePoint VM that's consuming all your disk I/O, you come in here and say, you know what, no more than 200 IOPS, you're good to go. And so it has that effect of leveling out the hills and valleys of everything. And then the other one is as a shared VHDX. So this is a huge item for hosters, right? So if we go back to this scenario of guest clustering.
And again, that's the VMs that have an application running within them, right?
Correct. So guest clustering. I have, let's say, a scenario of SQL Server. Okay, so I have two Hyper-V hosts, and on one Hyper-V host I have SQL Server Node 1. On the second Hyper-V host I have SQL Server Node 2. If I want to cluster those, right? Because remember, if with live migration and quick migration and failover within VMs, if the host goes down, the VMs power off, transfer over, and power on again. That's downtime, right? That's maybe minutes or seconds or whatever.
For an unplanned failure.
That's for an unplanned failover. By doing active guest clustering, if that node goes down, the application can just fail to the other, can automatically fail to the other application that's running on the other node. To accomplish that, you've got to get shared storage to your VMs. Now, there's only one way to do this in Server 2012 and Server 2008, which was iSCSI. And people just went,
Now, why? Is that because iSCSI performance isn't optimal if you're trying to run SQL?
iSCSI performance is never as good as something like Fibre Channel because it's got the overhead of TCP/IP. There's all kinds of people that claim it's good and better, and certainly there are good implementations of it. But iSCSI is it's not something that I'm personally a fan of. For big production systems, I prefer things like Fibre Channel. So you can kind of do two things. One, you can attach Fibre Channel directly to a VM now, which we'll get to later on. But you can actually define a VHD as being shared between two VMs. And by having the two VMs share the same VHD, you get shared storage inside the VMs. Now, there's some requirements for this, and one of them is the shared VHD has to live on a scale-out file server. So you're back to this Hyper-V over SMB scenario, where both SQL instances live on a scale-out file server. They're clustered under Hyper-V at this level. Up here, they're on a scale-out file server. There's a shared VHD on the same scale-out file server, so that becomes their shared storage. And it's much, much easier to implement and manage at the fabric level than having to, attach iSCSI, which requires network connectivity, or fiber channel, which requires physical cable and fiber connectivity.
And I think another nice advantage for our hosters as well is it kind of provides a layer of abstraction for security. So you don't actually have to expose that underlying storage fabric. You can just say, here's your file, here's the path of your file, go connect to that, and now you can go build a guest cluster.
And the implementation is literally a piece of cake. All you do is you add a VHD to a machine, you point the VHD at a file share, and you come in and check this box called Enable Virtual Hard Disk Sharing, and just point 2 VMs at the same file. And they'll both see it as shared storage, just like an iSCSI LUN or a fiber LUN or anything else. So it's the simplest way to accomplish it if you're running in a Hyper-V over SMB implementation. So that's that. So that's kind of some of the storage considerations for what you can do within the VMs themselves. There's a lot there. There's a lot you can do. There's a lot to think about. So let's move on and look at creating and configuring some virtual machines. So first of all, there's 2 types of VMs, Generation 1, Generation 2. I'm just kind of flicking back and forth there between the 2 slides. Generation 1 VMs are your traditional VMs. They're based on the spec of what is a PC from circa 1921, I think, which is, a couple of IDE controllers, a BIOS, CD-ROM drive, a 100 meg network card. So it's what we all traditionally thought of as a PC back, in the days when a PC was a 400-pound screen and a couple of floppy disks. That's not what PCs are anymore. And if you think about the logic and all this, right, it's kind of funny to me. When virtualization first came out, the whole goal of virtualization was to make it identical to a physical machine so that there was no drawback. Now that virtualization's accepted and people go, it's not a bad thing, we might actually use it a little while. Now it's, okay, how can we take advantage of the fact that it's virtualized and get something better because it's virtualized? And that's where this idea of a Gen 2 VM came from. Now, to create a Gen 2 or a Gen 1 VM is real simple, and in fact, there's not a whole lot of difference. These right here, by the way, are Gen 2 VMs. Server 1, Server 2, there's nothing any different about them. What's different about them is the hardware that they're based on. If you'll notice in here, there's no BIOS option. If I go look at a Gen 1 VM, which I believe, so this guy right here, this Win client is that's Gen 2. I think I have a Gen 1 here. Nope. We'll make a Gen 1.
Let's do it.
So a new virtual machine. We'll actually do it over here to make it easier to see.
Now, while you created that, one thing that you'll notice that comes up during the wizard is it actually prompts you, do you want to create a Gen 1 or a Gen 2?
Yeah, so,
go ahead.
So there's Gen 1, Gen 1. We'll take the defaults for this one. I'm not too worried about it. So there's your prompt. And this is, by the way, you pick it now, you can never change it.
That's the important thing.
Well, actually, no, not entirely true. I'll get to that in a second. So you pick this now, and you can't come back through this wizard and change it. There's a tool that one of the Hyper-V guys released that will actually convert from Gen 1 to Gen 2 by essentially destroying the VM and recreating a definition using the same VHD. It's not a conversion, but it does get it done.
Technically, it's unsupported. So we do want to, kind of caution you on the exam. If you get a question, can you convert? There is no built-in utility that's supported by Microsoft that allows you to do that. But there are third-party and community applications that can let you do that.
So we're just hitting next on this a bunch of times, and we'll come back to this wizard in a second, but I want to show you the difference between G1 and G2. So here's the Gen 1. If I look at the settings on it, it's got the stuff you would expect to find in a PC, BIOS, right? You got memory, IDE controllers, things of that nature. If you look at the Gen 2 is actually based on a UEFI.
UEFI.
It's one of those acronyms. UEFI BIOS as opposed to a traditional BIOS. So it's got a firmware configuration in here which does similar things, and it doesn't have IDE. It's only based on SCSI.
So a little more flexibility.
And a Gen 2 VM is generally better because the SCSI bus is generally better than IDE for everything within a VM because they're going to handle transactions better, commits better. So when you can, default to a Gen 2. That's my recommendation. When you can, default to a Gen 2. There's no functional difference other than, it's like buying a newer generation piece of hardware and putting Windows on it. There's nothing any different in how you administer it or manage it or work with it. It can still do everything the same way, but it's just a better architecture in general.
Absolutely. Now, some qualifications around that, you do have to make sure that the guest operating system is still specifically supported for Generation 2.
Correct.
So as you go through and create it, I will give you those options.
Yep.
But another thing that's we're seeing a lot of adoption or a lot of benefits from Gen 2 are this fact that they do boot from SCSI. Now, this has been specifically interesting as we started to see people migrate from VMware. Now, VMware virtual machines, they always boot from IDE. Previous Microsoft Hyper-V virtual machines had to boot, they boot from SCSI. Previous Microsoft VMs had to boot from IDE. So as part of the migration process, you actually had to go and update the OS mapping within the VMs. Now using Generation 2 VMs, they can both boot from SCSI, skips that step, and simplifies the migration between the platforms.
So today, 2012 and Windows 8 or later are supported for Gen 2 VMs. So in terms of configuring settings for VMs, as you can see from the wizard that I ran through very, very quickly, you basically go memory, network, disk, done. Right? Generation, memory, network, disk, that's all you pick. Once you create the VM, by the way, if you do it through PowerShell, you can specify everything. You get really, really granular. Once you're created, that's when you can come in and modify all the different settings of the VM. So for example, the memory, and we'll come back and talk about dynamic memory here in a little bit. Number of processors, let's bump this one to 4 processors. Things like compatibility, the NUMA topology. So if I click use hardware topology, it'll actually go out, interrogate the hardware topology and pick the best configuration for NUMA. In fact, if I bump this up high enough, it should actually alter itself. Let's take this one all the way to 12 cores. And let's apply that. And so it's still using one socket for the VM. So, okay, let's do that. Yeah, still wants just one. You can manually modify this. There's no reason you would ever do it. So Hyper-V figures out the optimal topology. You can then add additional network adapters, connect network adapters. For example, just adding a network adapter here. And notice we've got options for legacy network adapters, which we'll talk about in a little bit. So add another network adapter, connect it to another switch, for example, or the same switch I want to do teaming. And then configure things like the integration services. So here's where I would go in and turn on the guest services, which is the enhanced session connection option. And then also configuring things like the checkpoint file location, which is the snapshot location, and also the smart paging file location, which we'll talk about here in just a little bit. So these are your basic hardware settings. And then again, this is all exposed under VMM with actually a little more detail. And you can create profiles for which are collections of these settings. So when you create a VM, you don't got to go configure all these settings. You just go create a VM and apply the high performance VM profile, which says 4 procs, 16 gigs of RAM, SMB based storage, and some other things. And so you define all these, and you'll see this where you define all these within VMM. So dynamic memory. This is something that again came about around the time of remote effects and was initially targeted at VDI. Okay, so this isn't something that you will typically find on server implementations. This is something you typically find when you're virtualizing client operating systems for VDI, because user usage patterns tend to elevate and decrease a lot. There's a lot of variance in them. It's very easy to predict server resource consumption, right? If you're planning a SQL server, a SharePoint server, an Exchange server, there's tools that will tell you, hey, 20 users doing 100 emails a day, this is what you need, and it will be very consistent. With client operating systems, how much memory the client VMs are using, depends on what the Kardashians are doing at any given point in time. What's trending on Twitter? I don't know. I don't know, but that's the nature of it, right? It's funny. I was actually in, I believe it was Amazon, I think, a number of years ago. There's their social media center where they track all this stuff and they allocate resources based on what the Kardashians are doing, because it depends on determines what people buy, and they have it that precise. It's incredible. I'm embarrassed to even know that name. I got to admit it. I think I'm leaving right now. So with dynamic memory, what this will do is it will make more efficient use of your RAM by allocating memory up and down as VMs actually need it. So as VMs need more memory, it balloons up. As they no longer need memory, it balloons it back down and allocates it to other resources. So there's a couple of settings in here: startup, minimum, maximum, memory buffer, memory weight. Rather than look at the slide, let's look at the actual VM setting for that. Let's take this G1 VM and go under memory here.
Now, one question that you may get asked is around what settings can be modified while a virtual machine is running, what settings cannot be modified while a VM is running. And so that's something that we definitely encourage you to spend a lot of time on. You are going to get asked that. Now, if you want to modify the static memory, not possible. Can't modify dynamic memory settings when it's running. But the dynamic memory itself will adjust on the fly.
You can modify the weight while it's running.
Okay.
So startup RAM is how much RAM you give the VM when it boots. Minimum RAM is how much it needs to operate. And there's a scenario where startup might be higher than minimum, which is you need a lot more memory to actually get the VM booted than it needs while it's up and running.
And that's to like load drivers, connect TCP IP, all of that stuff.
Pretty common, to be quite honest. The max is, how high will you let the RAM actually go?
Now that looks larger than you maybe even have on that host.
Why
is that?
It just defaults to as much as it'll put in there. I don't know why it's that number, but
that's actually exactly one terabyte of RAM. That's what that number translates to with the binaries. But essentially, what we try to do with the virtual machines is, by default, give you the max. And if that host can use it, if that VM, that host has free resources, we'll go max it out. We'll make that VM run as fast as possible on the host.
The buffer is, here's what the buffer does. So as the VM boots and it begins to use RAM, once it reaches less than 20% of available memory, it will add 20%. So that's where this buffer value comes in. So it'll always maintain 20%, and it will do it in increments of whatever the buffer value is. So if you have a gig of RAM, you take it to 800 meg, it's less than 20%, it'll bump the VM to 1200. You can go up, once you hit 1,000, it bumps it another 20%. It just keeps going up. And the weight is, if you have more than one VM, how it chooses which VMs get RAM if there's not enough and they all want some.
So some basic level of prioritization.
Yeah, exactly. So the real important VMs get higher weight, the less get lower weight. It's real simple, real easy to configure, and it's native within Windows. There's nothing you've got to do. As soon as you configure this here, the operating systems actually take care of it. The only weird sort of thing is that Task Manager in Windows actually shows the high watermark until you do a reboot. And so at some point, I'm sure that'll get tied up. It doesn't really matter, but it actually shows, the VM will go down, but Task Manager doesn't go down with the VM, unfortunately. So just be aware of that, and you'll typically be fine. So here's kind of a little sort of animated example of this to help get the point across. So at 15 minutes in, you can see that we've started at all about a 1 gig. As people have been using the VMs, it's adjusted the memory dynamically. Now we bring in another VM and change the weighting around, and you can see that it's now lowered some of them as one VM has wanted more memory. And so this is, essentially what would happen as you work through that scenario.
And so based on those maximum settings, though, you can, in theory, overcommit memory on a host because, while it can bump up to those maximums, that'll be supported. You can't overcommit the minimum memory, though, on a host.
And the thing is, it's all about capacity planning and just kind of playing the averages. You're gambling a little bit by saying, you know what, I need, I have 100 users to support on the server. Each new user needs 2 gigs of RAM. That's, 200 gigs of memory, but they're going to average maybe 1 gig. So, maybe
128 might work.
Yeah, exactly. And you kind of, figure out that best cost balance. And it's all based on, it'll kind of based on timing as well. These guys need it in the morning, these guys need it in the afternoon. And then you block Facebook. Smart paging. Smart paging is a technique that's used to ensure that in a scenario when you have dynamic memory, when you have the startup RAM bigger than the minimum, that you can still boot, right? So let's say that you've got, your memory is so committed that you want to boot a VM that needs 3 gigs to boot, but there's only 1 gig left and its minimum is 512. You can still boot that VM because it will actually do an additional level of what's effectively a page file to allow the boot to happen. It'll be slower, but it will boot, and then hopefully after boot settle down into running an actual memory. So it's a technique to allow virtual machines to boot when the amount of memory they need for startup is not available. That's what smart paging is. And it uses basically a page file on disk.
And so basically what you're saying is we're temporarily creating more memory, but rather than doing that in the memory itself, we're actually doing it on disk and kind of simulating
Yeah,
that.
you do it, but it's basically a page file.
And then as soon as that memory gets freed up, we will actually, take it out of the page file, put it back into fast, real memory so that you can continue using it as a, normal virtual machine.
Absolutely. Next piece here is the integration services. The integration services, we kind of alluded to a little bit already, are something that we don't really have to worry about anymore, to be quite honest. Back when Hyper-V first came out, because it wasn't released with Windows, it was released a little bit later than Windows, people would make VMs and the performance would be horrible because they didn't add integration components. Integration components are basically drivers. So VM additions, VM integration components, what does VMware call them?
They call them VM tools.
VM tools, there you go. Are just the drivers you add in to make the operating system virtualization aware. Now the cool thing with Windows is they're there by default, starting with 2008 R2 and Windows 7. They're just in there already. I think it might have been Vista SP1 even where they started including them.
It's been a while.
Yeah,
but one of the more interesting investments Microsoft's been making recently is investment around Linux and open source. Yeah. So you've actually built up an entire open source Linux team. They contribute to the Linux kernel, so the actual open source project. And now we actually include our integration components directly in the Linux kernel. So if you get a Linux distribution, CentOS, Ubuntu, SUSE, Red Hat, any of those that are built based on those Linux distributions, those integration components come out of the box. So you just
already there.
Boot the operating system, it knows it's running inside a VM, and then you can do things such as live migrate those VMs, do backup using Data Protection Manager with consistency, and even take advantage of dynamic memory for those Linux virtual machines.
Yeah, so dynamic memory for Linux is actually a pretty significant thing. That's fairly new as well. And
brand new, yep.
And that's great. It applies there as well. And then you'll see within the VM there's some services that run, and then on the VM itself you can actually control some of these integration components just under the settings under integration services. And to be quite frank, there's not a whole lot of reason you would ever disable any of these in production scenarios. There's not a whole lot of real good reasons. But the only one you might want to disable is time synchronization. The reason for that is what this does is when the VM boots or when you save it or apply a snapshot, it syncs the time with the host and keeps the time of the VM synchronized with the underlying host operating system.
Yeah.
If you're using an external time source and you want to make sure all your assorted operating systems and VMs are using the time source as opposed to the host they're running on as the source of time, you turn this off and point it at the time source. And that's the only real fairly common, I guess, I don't even really know how common it is, but sort of legitimate kind of production scenario for turning off one of those integration components.
Now, the other time that we use that host integration components on is actually when we do some development testing, and we want to kind of always roll back to a specific set of time so that we could kind of see active items in the logs, in Event Viewer, in Perfmon. So by disabling that host time synchronization, and having a snapshot, you can roll back to the snapshot. The host does not sync to the current time, and so you can kind of simulate still living in the past, being frozen in a previous point in time. So that's kind of the only time I've used that.
Yeah, absolutely. So in terms of, we mentioned storage and ways of attaching storage to VMs, you have now a virtual fiber channel adapter. And this is a pretty significant addition because what it enables you to do is directly attach fiber channel storage to individual VMs. So you actually have a virtual HBA that you can connect. Now, to kind of show you where this goes, I can't do it because I don't have a HBA. But if we go add hardware, we can add a fiber channel adapter, and then it will you actually define virtual SANs, and you can connect the fiber channel adapter to a virtual SAN, and it has the same worldwide names, which are fiber channel for MAC address. That you would see when you do real, honest-to-God, physical HBA configuration. So if I go up under Virtual SAN Manager, I can actually create a fiber channel SAN. Left the default name. Under the VM, I believe I had cancel on that before, so we'll add the fiber channel adapter. Connected to the fiber channel SAN. And away we go. But the problem right now is there's no host bus adapter in the machine, so I can't legitimately complete the configuration, but that's really all you do. You then take these worldwide names that you can edit, you can modify, and your fiber channel SAN, so if you have an actual host bus adapter card in there, your VM will now appear as a host on your SAN, and your SAN can now be made available to your VM. In order for this to work completely across the board, there are certain fiber channel adapters you have to use. They have to support a function, which I forget the name of, unfortunately, that relates to virtual fiber channel. But if you go in and you look up the Windows hardware catalog, I want a fiber channel adapter that supports a virtual HBA. There's just a series of functions that adapter has to support. If it does, it can pass those calls through to the VM, and the VM can be on the fiber channel SAN. And what's neat is you can still live migrate the VM, and it won't drop the fiber connection. So we can actually migrate from one host to another onto a completely different HBA, but the VM will not lose its connection to the SAN because the worldwide names go with it.
Great. And we're actually seeing a lot of people using guest clustering taking advantage of this fiber channel, because fiber channel, whether it's on a physical server or connected to a VM, can still be shared, give you distributed access. So whether you want to go and use iSCSI for your guest clustering, a shared VHDX file, or use fiber channel, these are now all supported for your guest virtual machines.
And the reality of it is that most IT organizations that have made an investment in fiber channel, they hear me say, fiber channel is kind of hard, and they kind of go, no, it's not. I know how to do it. Yes, they know how to do it. They've invested in it. It's not hard for them, and so this is a godsend.
Highly recommended. Yep. Yeah. No reason not to use this.
Because we tell them, hey, you can plumb fiber channel to a VM. They go, okay, cool, no problem. Do it all the time. So it becomes another option for guest clustering. And I know, for scenarios like SQL and whatnot, where they want really, really fast, like fastest possible disk throughput, this is the way to go. To fiber right to the VM, you can still get the benefits of being a virtual machine. So huge move forward.
Great. Well, let's move on to our next section and talk a little more about installing and importing virtual machines.
So when we talk about installation, what we're really talking about is how do I get an operating system in the VM, and this isn't rocket science. You install the operating system, right? CD, DVD, ISO file, to PXE boot it, doesn't matter. But you can also do what I think is pretty cool, which is the what used to be Wim to VHD and is now called Convert VM Image, I think. So there's a PowerShell commandlet that you can go download off of Codeplex that you basically point it at an Wim file. So you take like your Windows installation ISO file and you extract it, which Windows supports now natively. Get the install.wim file, point this tool at it, and it makes a VHD for you.
Very nice.
And it can be VHD, VHDX. It can be 10 gigs, 20 gigs, 1,000 gigs. And you just make a VM off that VHD file. And that's done the effect of installing your operating system for you. So installing VMs, the operating system, piece of cake. VMM makes it even easier because you just go, hey, this VM, that host, that operating system, go. And it's got everything it needs ready to go, and you'll be showing some of that tomorrow.
Yep.
Importing. Ooh, something near and dear to my heart. Best way to tackle this actually is this. There's been a lot of changes on this front, okay? The first thing is, with 2012 and 2012 R2, you no longer have to export VMs. Okay? With 2008, if you've used it, in order to get a VM from one host on, you had to export it. We made a copy of all the hard drives, which was a lot of I/O. Then you copy all those files over, and then you import them. And the import, if there was anything out of whack, if there was files that had moved around, or there was an ISO file missing, it would fail. And it was not the best of experiences. And there was an API where you could fix all that, but it was an API. And Microsoft recognized that this is a pain point. So what they've now done is you can just take the files from a VM and you can just copy them and do what is the equivalent of a registration. And so for those of you that are intimately familiar with this, you may have noticed in the past there was these .exp files and config.xml. They're no longer there. You now just, an imported folder structure and an exported folder structure are identical. And if you just copy the files, you can register them. So it's a huge step forward to make this simple. And the UI now figures out all the things that might be broken, or might be messed up when as paths change and whatnot, and switch names change, and prompts you to fix those as you do the import. Virtualizing a physical machine. I know there's a bit of a sore point here because there's the notion of P2V conversion, right? Physical to virtual conversion. System Center supported that in the previous release. This release, it actually doesn't support that anymore. Hyper-V doesn't include native P2V functionality. So there's a couple of ways that you can actually do a physical to virtual conversion. And one of them is using a tool called Disk to VHD, which is a sysinternals tool. Looks like this.
We'll go post that link.
Looks like this right here. You point it at a drive on a machine. It takes a snapshot of the drive, makes a VHD, and you can then boot that into a VM. Now, having done this a couple of times, about the only real annoyance to this process is you've got to deal with all the driver changes. So you boot it, detects a bunch of drivers, you reboot it a couple of times, but generally it works pretty well. In terms of application, we've kind of covered this a little bit already, so we're not going to spend a great deal of time. The way that you interact with a VM interactively on the host is through Virtual Machine or VM Connect. VM Connect is this application right here that I'm running right now. It's native on part of the RSet tools, part of Hyper-V. Double-click a VM, this is what comes up. Runs on port 2179 and just does an RDP connection to the VM. The enhanced session mode, I believe we've kind of covered this already, so I'm not going to cover it again in the interest of time. But as we mentioned before, available for 2012 R2, gives you RDP level access in the console session, regardless of the network.
All right, so let's talk about checkpoints.
All right, so checkpoints are the equivalent of snapshots. Now, simplest way to do this is to do some examples of them.
Okay,
right?
let's do it.
So first of all, a snapshot is basically a point in time on the VM that you can roll back to. So for example, this VM is running right now. I can take a snapshot of it. So I right-click it, click checkpoint. And so what this will actually do, you can see it right here, create the checkpoint. So I now have a point in time at the 19th at 12:11 p.m. where I have a freeze frame of that VM. I can continue to work, I can make a bunch of changes, and I can roll back to that state. So for example, if I open up this VM, which is right here, and I go, well, let's take this folder and let's just do something like, let's make a new one. Make a new bitmap image right there. So I've made a modification to the VM. And I go, you know what? Didn't quite work out. I can now go back and apply this checkpoint. By applying that checkpoint, I'm saying this is the version of the VM that I want to be made active. And it's going to prompt me and say, hey, you're going to apply this checkpoint. If you do, the way it is now is going to get removed. So do you want to take another checkpoint, or do you just want to apply it? And I'm going to choose create checkpoint and apply just to show you what it does. You'll see a bunch of stuff happening up here as it does the work. And so now I've got, you see, kind of structured around my VM roll back to the point where I didn't have, let's reconnect to it, or I didn't have that bitmap on the desktop. Oop, let's drop that screen resolution all the way down to super small. So there we go. So it's back to that point in time where there was no bitmap on the desktop, but I've also now got an additional point in time, and I can actually rename this, or have the bitmap on the desktop. And so I can now move that VM essentially back in time and forward in time as I work with additional configurations of it. This is great for dev, for testing. If you're working through, you're building a server, and you're maybe not sure if you're doing it the right way, you can take snapshots at points in time of the build, and if you get to a point you go, oh man, I screwed that up, rather than trying to uninstall the application, which maybe doesn't always go as well as you would like, you can just revert to the previous snapshot, and it's as if it never even happened.
Right. I've been using this actually through demo type environments to kind of show different states of a system. So, Corey and I have been working together to build a lot of Windows Server systems set to demos, and we constantly want to say, hey, we just need to show demo 3 out of these 10. And so by using these checkpoints and taking them serially as we're building up this infrastructure, it allows us to move not just back in time, but also forward in time, and really jump between these different states to really show a dynamic infrastructure.
Now, where checkpoints can get confusing for the uninitiated is deleting versus applying, because it's not as straightforward as you might think it is. For example, if I apply a snapshot, I'm deleting changes. If I delete a snapshot, I'm saving my work. And so it's a bit of a confusing concept. So let me try to explain this a little bit here. I've got this bitmap on desktop right now. That represents a state. if I were to delete that snapshot, what that's going to do is merge the changes of that snapshot up one level. So I'm basically saying I want to keep up, by deleting a snapshot, you're saying you want to keep all the work. By applying a snapshot, you're saying you want to discard everything but this current state in time. And you can create, very complex. I can create snapshots up here, so I can apply this one.
Different trees, different
trees, and you can have multiple levels in very complex snapshot environments. Take the time to learn how to do this before you start doing it en masse, because inevitably you'll delete something you meant to keep or keep something you meant to delete. So you've got to get your head around the terminology for it. Now let me kind of show you an example of what happens sort of at the file level. So here's an example in this whole screenshot of what I was talking about before: adapter patches, applications changes, kind of showing what that might look like for the process of maybe building out a server, for example. Now what snapshots are actually doing at the file level is creating differencing disks. So when you create a snapshot, we talked about diffs and bases a little while ago, it's actually creating a differencing disk. And that differencing disk contains all the changes from this point in time forward. And when you delete the snapshot, the differencing disk is merged back. When you apply it, the differencing disk is deleted and a new one is started over. So you got to think of it as how things were at a particular point in time. So here's an example of what happens at the file level. I want you to focus on not the stuff on the, I guess what would be the right-hand side, but the stuff on the left, which is a much simpler example. So we take a snapshot. The snapshot was taken with that little red dotted line. Now we've got the changes that are being captured in the what's called the AVHD file, or the auto VHD, which is the snapshot. Take another snapshot, and you now get another VHD file. So you're creating this tree. Okay. So if you were to apply the snapshot at this point right here, what you're saying is how the machine was at this point in time, which is everything from here backwards. So everything from here, there we go. Everything from here backwards is what you want to keep. All this stuff up here goes away. So that's why apply is delete, essentially. Delete everything from this point forward. Now, what that does, basically deletes the AVHD and recreates a new one. If you were to delete a snapshot, so let's say I delete this one back here, you're saying, I no longer want the ability to go to this point in time. You're not saying delete the files, you're saying delete the ability to go to this point in time. And when you do that, remove this point in time right here, all these changes become permanent and merge. So it looks like this.
And you'll actually see a merge operation displayed in Hyper-V.
And that can be done while the VMs are running, which is new and cool. So exporting, first of all, you don't need to do it anymore, but you can do exports of VMs. When you do an export of a VM, it creates a really nice little package of files, very structured, very neat, very tidy. I love them. But you can export a VM while it's running, and you can export a snapshot. So if you export a snapshot, it's going to take all the related differencing disks, merge them, so you get one VHD as the output of the snapshot. And when you import the VM on the downstream system, there's no snapshots. It's that state of the VM. So, talking about snapshots, when should you use them? Well, first of all, you only use them dev test, use them in isolation. And if you have an infrastructure, like for example, you said you're building some demo environments that can, presumably contain more than one server, you always apply and delete the group. You never do individual servers because they get out of sync. For example, let's say that I join a domain, right? There's a domain password that happens, and I revert the VM, I revert the domain controller, but not the client. The client still thinks it's domain joined. The VM doesn't know what the client is, so there's a disconnect and it's broken. That can get really, really, really ugly in production environments. So look at this example here. This is why you never checkpoint a domain controller. Well, there's a fix for it now. So here's a domain controller, right? And what we're looking at here is what happens when we create users. So I create a checkpoint at a particular point in time. Pay attention to, in this example here, the RID pool and the USN. So pay attention to these guys right here.
And what are the RID pool and the USN?
The numbers used to generate the SID for the user accounts that are created. So I create 100 users. The RID pool has now been advanced, so I've used some of them. I've made 100 updates to Active Directory, so the update sequence number right here has gone up and the RID pool has gone up. And I then replicate that to my second domain controller. So it's now identical to domain controller 1. I then go, oops, I didn't mean to make those users. I'll just revert the checkpoint. Really simple way of doing it. Well, look, it's gone back to 100. The RID pool's gone back to 500. However, this guy still thinks it's 200. He still thinks there's a bunch of users out there. So I create another 150 users to get it right this time. Advances, but again, there's a disconnect right here. The result of that is we have 50 users replicated. There's a bunch of duplicates. The RID pool's all messed up. You have conflicting SIDs, and you're spending Saturday night restoring Active Directory.
Fun.
So, people did this in production. And, Microsoft Tech Support had dozens and dozens, if not hundreds of billions of millions of calls about, replications broken in AD. Well, did you checkpoint your domain controllers? Well, yeah. Well, that's why. So Microsoft introduced something called VM Generation ID, right? This is a way for a domain controller to be supported for scenarios where you're using checkpoints and snapshots. And here's basically what it does. So first of all, it's a 64-bit integer, basically a GUID, that is tied to the VM configuration. And it's used to identify when an action has taken place on a host that has the potential to move the VM forward or backward in time. That's the key. And so these would include things like save states, snapshots, import exports. So something that has the ability to take a domain controller and change its time forward or backward. And it's that change of time forward or backward that causes potential replication issues. And so if it detects that there was possibly a change in time forward or backward, it immediately assumes that it's wrong and tries to essentially sync up with all the other domain controllers that it assumes are correct. And so by doing that, it protects itself from that scenario that I just described. There's a component called the Hyper-V generation counter. There's a GUID stored on the domain controller's Active Directory object, which represents this, and it's also stored in the XML configuration file of the VM definition. If you were to look in the event log when you apply a snapshot or a checkpoint, you'll see an entry like this. A generation ID change has been detected. And what that means is you performed an action on Hyper-V that has the potential to change the time of a domain controller. Hyper-V then changes the GUID in the config file of the VM. The domain controller, the service in the domain controller, this guy right here, detects that the config file's got so it passes the GUID via memory into the domain controller. It detects that, wait a minute, the one that I had and the one that's on the host are different. Therefore, something happened on the host to change time. I'm immediately going to assume I'm wrong. I'm going to inbound replicate from everybody else. I'm not going to accept any new objects until I inbound replicate. And once that's all done, I'll be happy. And so it prevents that bad scenario from happening again. So that's that.
So what are some of the ways that we can, just make sure that our hosts and our VMs are monitored?
Well, this is going to be pretty simple stuff, so we'll kind of end this on a lighter sort of piece of information. But performance monitoring is what it is. It's pretty straightforward, and people generally know how to do it. And the fact that it's you're monitoring VMs doesn't fundamentally change anything, but you have to realize that you're no longer monitoring a 100% isolated environment that you control. There's other things that you maybe can't see that are impacting it. So first of all, we know what performance monitoring is. Yay, cool. Tools you have available to you, Task Manager. Might seem trivial. This is probably my favorite tool for performance monitoring. That whenever someone says, hey, there's a performance issue on either a server or in a VM, this is the first place you go. And what you're looking at is that performance tab and the applications to go, what's using memory, what's using disk. And usually, after I stop here, step 2 is this guy. So if I go I'm just going to grab this guy real quick on a host here. So I grab Task Manager, and if you're dealing with a little more advanced server, you can go. Let's look at NUMA nodes to see how the sockets are being utilized. Change graph to logical processor; those are being utilized. One of the real neat things, by the way, is if you're dealing with, and I've seen this on some of the original generation 10 gig network cards that we bought. They were single socket, so they would do offloading of 10 gig. But they'd hammer one socket only. And so we go in there and go, why is the CPU performance what it is? And you'd see one NUMA node, which is one socket, pegged at 100%, the other at 0. So you're not getting you're getting the performance of one socket out of that machine. And so you get to see these things just here in Performance Monitor to see exactly where the performance is being used. And you should see, equal performance across all the sockets, i.e. the NUMA nodes. And then on the resource monitor, which is typically your next step, you go, okay, quick overview, what's using memory? And I'm typically looking at what's the working set of memory for any given process. I'm typically looking at the network utilization to see what services are doing the most network input-output. So I just look at total, and then the same thing with disk. What is actually using the most disk within a VM or on the host? Now, looking at the host will not tell you what's going on inside the VMs. So that's where you start looking at individually within individual VMs to see what they're doing. But this tool here, in my mind, is very often overlooked because there is a wealth of resources available. So you can see how memory's been broken up, how disk is being broken up, and I love this view right here for disk. Just looking at the queue length, right? What's the the lag on disk I/O right now? And if this is low, we're good. If it's high, we're bad. And then finally, your event viewer, which everyone is pretty intimately familiar with by now. but Hyper-V has within, and I think few people are aware of this. So we're just looking at event viewer. There's actually an entire subset of events dedicated to Hyper-V under server roles. So this is focused explicitly on Hyper-V, so system level events that are generated by the Hyper-V role, but then also under Windows logs. Sorry, application service logs, Microsoft, Windows. And we just start digging down in here. Hyper-V config, Hyper-V VMS. So this is the management service. So this is where you see things like, are VMs booting? Do VMs have, adapters? What's the, have I created things, modified things? And then you can also, with these guys, under view, there's an analytic and debug log option, which gives you
more advanced,
nauseating detail.
A lot more data.
It's performance impacting data, but if you're in an advanced troubleshooting scenario, it's valuable
trade-off
data.
You need.
It's valuable data.
Now, a good best practice related to the exam here is just kind of get a brief understanding of what each of those different Hyper-V event logs are used for. For example, you might have a question that says, hey, you're noticing a lot of disk I/O, where should you go to troubleshoot that? And then you can kind of look at those tools we mentioned here, Task Manager, Resource Monitor, Performance Monitor, and then the event logs to try to drill down.
Yeah, Task Manager gives you virtually nothing for disk, which is, on the client, it has a nice little disk tracking tool. I don't know why that's not in the server. It's
interesting.
It's, I can show you right here. On the server, you've got, under Task Manager, you've got, CPU memory Ethernet. On the client, under Task Manager, more details, you get disk.
Look at that. Well, my assumption with zero knowledge behind it would be that on a server you're using SAN storage more so, you still got local disk,
server,
right?
I would care about that on a server more than on a client.
That's true, you would.
And it's very useful because it tells you average response time milliseconds, activity, and then the read and write speed, which tells you how much you're pushing through your storage. So this is very, very valuable.
So maybe you called out a good point there. If you're looking for local disk stuff, you would not use Task Manager. You would go and use one of those other tools for server. Indeed.
And then finally, the reliability monitor, which you can access through Task Manager as well, shows you things like when patches were installed. So you can kind of go back and go, well, what's changed? That's, server was doing well, now it's not what's changed. Well, this can show you potentially, what it was that was changed. And then, of course, your traditional performance monitor. And then finally, this is new for, there we go. This is new for Server 2012 R2, resource metering. Now, resource metering is a way of measuring the I/O of a VM for memory, disk, and network for the purpose, it was basically for the purpose of chargeback. So if you were looking at, okay, what does it cost me to run a VM so I can charge back to either a tenant, a customer, a department, a cost center, it gives you a tool to calculate that. Now, this is very rudimentary. It has the framework to capture the data, but the reality is the captured data is almost of no use within PowerShell. The only way you can get at this, when it's bubbled up into things like Service Manager, that's where the data is actually turned into actionable information that you can make decisions with. But to do it, it's actually quite trivial. If I have a couple of VMs running here on this node, let's do this. We can do a git VM. You can see this VM has a couple of nodes on it. Or this node has a couple of VMs running on it. And let's do an admin PowerShell, which is what I need. So those are the two VMs. And I can just enable VM resource metering. And it's a per VM setting. I just turned it on for all VMs. And then after they've run for a while, I can come in here and go measure VM. There we go. So it measured, I know I didn't measure the first one, but it measured the second one for me. So you can see that it's got an average CPU megahertz, average RAM, new RAM, min RAM, total disk, network inbound megabits per second, total network outbound megabits per second, and total disk megabit disk size. So it's the basis for, chargeback. So as over time you collect this data, the data is stored with the VM. So it actually moves with the VM, but you can then capture this data, use it for a chargeback solution, feed it into things like Service Manager, and go from there.
Great. Excellent. Well, anything else on this module?
No, that pretty much concludes it. It was a big one.
That was a big one. So in summary, we kind of covered the basics of creating your VMs, managing them, testing them for performance. And with our next module that we're going to return to in about 1 hour's time, we're going to go basically take a look at how we manage our networks, do network virtualization, and really make sure that our VMs can go and connect to other hosts, to each other, and to our outside world. We'll see you in an hour. And welcome back to the Server Virtualization Jumpstart, looking at our new technologies with Windows Server 2012 R2 and System Center 2012 R2. I'm Simon Perryman, Microsoft Technical Evangelist, and joined again by Corey Hines, President and Lead Architect from Hull Systems. Now, up to this point today, we've really kind of laid the foundation of building our infrastructure and then building our virtual machines that run on top of it. In this next section, we're really going to focus on networking, how we design and optimize our networks for our VMs so they can communicate amongst themselves and to our other environment variables. So what are we going to cover in detail then?
So we're moving on to networking. And networking is not much fun without networks. It's, it's like multiplayer solitaire. It just doesn't fit. So we're going to take a look at a module on Hyper-V virtual networks, and this is the same sort of content that, again, like as we move into System Center, will bubble up in there, and because you do the same sort of management in System Center, but you can do it at a policy level across lots of hosts. What we're going to take a look at in here is how you basically define and manage the assorted types of networks that exist on a Hyper-V server, and then additionally take another look at network virtualization. Now, that's a big thing, and that's a big, complicated, scary thing. We mentioned it in the beginning. We're going to do a little bit on it right now from a conceptual level, and then tomorrow when you get into System Center, we'll actually see how you implement it within System Center, because it's not until you begin defining things like virtual networks and provider networks and ports and IP ranges and subnets that network virtualization becomes a tangible thing as opposed to a fuzzy concept. If anything virtual can be tangible. So this particular module, essentially three things: creating and using Hyper-V switches, some of the advanced features for networking, and then looking at using network virtualization at a conceptual level. So to begin, Hyper-V virtual switches. These are the things within Hyper-V that allow VMs and ultimately the host operating system itself to go connect to other resources on the network. So at the end of the day, you need something with an IP address, and the switch is what allows you to have that. And you think of Hyper-V virtual switches in the same way you think of physical switches. It's a layer 2 switch. So if you want to, for example, I've done this plenty of times in offices and home offices, not so much in big data centers, but I need another 10 ports because I've got 10 computers to plug in. You take a cable from one switch and you plug it into another, and you've extended the switch. And now you've got more ports to plug things into. That's what virtual switches are. It's a software-defined switch within Hyper-V that you can plug VMs into virtually, electronically, and give those VMs access to the physical, essentially the same resources that the physical switch that the host is ultimately attached to has. And so they're managed essentially by PowerShell or by Hyper-V Manager or by System Center, and you can have as many switches as you want on a Hyper-V host. There are no theoretical limits. There are practical limits. If you start getting up to hundreds of switches, you'll start to see some issues. But from a production server standpoint, there's very little limitations on what you can do. Generally speaking, you will have one switch per physical adapter, or if you do teaming, you might have 2 adapters in a team and one switch for that adapter. So typically on a production server, you're not going to have that many, right? You're going to have one per essentially one to represent the extension of the physical switch into the different VMs. So if you've got 4 ports or 8 ports, that's about as many switches as you would traditionally see. Now, again, in the VM world, compares with the VMware vSwitch, not VDS.
As you want on a...
Wow.
Sound.
So let's take a look at, essentially what the switch is and how we create it. So this little example right here is just a PowerShell snippet, right? So we can see that we're making 3 switches. Okay. Now we'll talk about switch types in a minute, but what happens when I go to create those 3 switches is it creates 3 virtual network adapters within the host. So as you look at connections, as you create more switches, you're going to see additional connections appear on the networking connections of the host machine itself. So you can see I got 3 examples: management, storage, and live migration, and the corresponding created 3 virtual network adapters, each one representing the connection to that switch. There are 3 types of switches within Hyper-V. Okay, so if I jump out real quick to my Hyper-V console here, and I go to where we are. Here we are. So I go to my virtual switch manager, and I go new virtual switch type. You can see there are 3 types listed: external, internal, and private. So it's pretty important to understand what the difference is between these. An external switch essentially connects me to a physical adapter, okay, or to a wireless adapter, right, which is, the reason the wireless adapter is there is not for your production data center that we run everything on wireless, but for primarily support for laptops running Windows 8.1, and because it's one code base, you get both in the server and in the client. So the external adapter represents a physical connection. The internal represent a connection between the host and the VMs only. So this is what we would have, traditionally thought of as a loopback adapter. So it can't talk to anything on the real network, but the host can see it, and the VMs that are connected to it can see it. And so this is often used in scenarios where I want to build up, a sandbox environment, maybe for development or testing, but I want the host to be able to see that environment as well, but the environment not necessarily to be able to see the internet. Or in those cases, I've seen folks use the host as a NAT device. So they put routing remote access on it, and they can do a NAT from the VMs out to the internet, so create a sandbox that way. And then finally, private is virtual machine connections only. There are very few reasons in a production world where you would use private. Those are primarily reserved for test dev scenarios where, when a couple of VMs, domain controller, DHCP, and all this stuff that, if it were to get on the real network will create havoc, but I want to run it, so private switches are a way that's done. And it's constrained to one host and all the VMs on that host on that switch.
And I think, if you're taking the exam, you can definitely expect multiple questions on this. Here's a scenario. Which is the best type of switch to deploy for that? So definitely familiarize yourself with those.
So here's a good kind of animated example of this. I've got a parent and 2 virtual machines. The parent has a physical adapter. The virtual machines have virtual adapters. Private switch, you can see the switch is created in the parent, but the parent has no access to it. Only the virtual machines do. Internal, the parent gets a virtual adapter, and it can, using standard TCP/IP protocols, talk to both the clients and to itself as well. And you can optionally inject NAT, as I mentioned. And finally, external, the parent gets an IP, the virtual machines all get IPs, and it's actually bound to a switch. But what you'll find is that the physical adapter it binds to has no IP address. That adapter is limited to only the Hyper-V switch protocol. And it essentially expects to pass the IP address through to the virtual adapters, either on the parent or in the actual virtual machines themselves. So here's some examples of what that might look like. So if I create a standard network adapter, this is an external adapter. It's bound to a particular network card. Here's an internal one. You'll notice that it creates a network adapter, which is right here. Let me get my little guy right here. So it creates the network adapter right here, but It's not bound to any physical adapter. And then finally, if you do a private, there's no adapter created, but the switch is actually created itself, right? And so that's essentially what happens under the hood with Hyper-V. Whether or not it creates virtual adapters on the host determines what it can actually communicate with. VLAN tagging is something that is supported in switches across the board, and this is pretty key. Like, so if you're not used to working in large data centers, you probably don't encounter VLAN tagging a lot. But in large data center environments, everything's VLAN, right? This is standard practice on switches across the board, and it's important that when you're buying switches, if you're planning on doing VLAN tagging, you've got to make sure they support all the different scenarios you want, and make sure that they support, in particular, using virtual machines that are also VLAN tagged. You can't just put any physical switch out there and expect it all to work properly. You've got to make sure that it's enterprise grade, supports all the features that you want. So when we start talking about these switches that are, $5,000 versus $1,000, that's the feature set you're getting into, which is, per VLAN spanning tree, support for VLAN tagging for virtual machines, MAC address, multiple MAC addresses per VLAN. So you can have the same MAC address across multiple VLANs in some scenarios. So there's a lot of things you got to think about. But what VLAN tagging essentially is, it allows you to create virtual segments on a switch. So for example, if you have the first 10 ports on a switch tagged as VLAN 1, the second 10 ports on a switch tagged as VLAN 2, if you put a DHCP server on VLAN 1, anything on VLAN 2 is not going to get those packets. So it's a defined broadcast and communication domain that's mapped to particular ports on a switch. And every single port on a switch is mapped to a single VLAN. Some switches support multiple VLANs per port, depends on the operating system. With Hyper-V, you can define on, you can define on a virtual machine. I'm not going to do this because I wind up breaking myself, quite frankly. On a network adapter, you can define VLAN identification. The default is 2 if you turn it on. So the default's turned off, but if you turn it on, it defaults to 2. You can change this to any value you want up to, I believe it's 4096. And when you do that, all traffic that leaves this particular adapter has that VLAN tag on it. And as long as the switch honors VLAN tagging, it's going to make sure that that traffic only goes to other switch ports that have the same VLAN tag. And so you can have 2 VMs, for example, in the same host. You VLAN tag them, if they're on the same VLAN, they can communicate. If they're not, they can't. So it's a way of logically breaking up a switch. The whole reason people do VLAN tagging is because you don't want to have, lots and lots and lots and lots of different switches representing different customers and subnets and segments. You want to be able to use single larger switches and just logically isolate them.
Now, Corey, you being a hoster here, you obviously run lots of these kind of isolated environments where you'll have multiple DCs. What do you regularly do? I mean, have you kind of changed your methodology? Used to use VLANs, moved since then?
So our scenario is a little bit different in that we're creating disposable VM environments. So
they're temporary for a couple hours, right?
For a couple hours, at most a couple of days. So we actually use private networks extensively. To isolate VMs on private networks on hosts. And then if we need to cross-host, we can implement VLAN tagging to make sure that VMs on this host can talk to VMs for the really large scenarios where we want to span hosts on them. We don't use a lot of switch-level VLAN tagging in our infrastructure. We do it on some of our edge switches for we have a couple of different internet drops that come in, so they all come into the same pair of switches that are VLAN tagged and then aggregated together to distribution switches to different logical segments. So we do a couple of different ways that we take advantage of those things, depending on one. That's a pretty typical sort of configuration where you have an edge switch or a top of rack switch that everything kind of goes into, and then typically it's used for distribution, so you're not dealing with a lot of ports. So you buy a fairly high-end, powerful switch, usually 2 of them, make them redundant, and then you carve up that into different VLANs that represent different egress points for all the traffic. So it's fun stuff.
Nice.
So that's kind of the background on VLAN tagging and the different types of switches. As I said, as you create switches, we'll just run back here real quick and just kind of show you how I create some of these. So here's an example. So this is, you might remember Server 4 that I installed earlier this morning, or if you're watching the recorded version of this a couple of videos ago. We actually took this HV form, we added Hyper-V to it. And I don't think I rebooted it. Oops.
Uh-oh.
Let me just check and see real quick. I didn't reboot it. So let's go to HV3. We'll reboot this guy when we take our next little break here. And we just go into Hyper-V Manager. Let me close down some of these extra windows. Virtual Switch Manager. And so we'll just do an example of a private switch. Create virtual switch. We'll just call this one private. And I'm just choosing the type down here. I can set a VLAN ID on the switch if I want. This would be a switch level VLAN, which means all traffic on this switch is VLAN to a certain point. And we click OK on that. That'll actually create the switch. And I can then use PowerShell. Get VM switch, and it'll actually list all the switches that are there with the types, the names, everything of that nature. So very simple, management process to create them. And then as I work with VMs, I can then take any given VM and just by going through the properties of the VM, take an adapter and connect it to a particular switch. And you can change switches while the VMs are running. You don't need to shut them down to do this. Right. The final thing I'll add, which is not in our slide deck, but is a particularly important thing. And I've seen people take down their, well, not taking their data center, but run into a lot of problems by ignoring this. Under a virtual switch manager, there's a little setting here called MAC address range. Now, this is really, really important. When you add a virtual adapter, so when you buy a physical adapter, and you may, I don't know if you remember this or not, but when you buy a physical adapter, the MAC address is actually predetermined. It's burned into the adapter. There's some adapters where you can change them through BIOS flashes and stuff. And the first 3 digits, or the first 3 bytes of the MAC address, generally represent the manufacturer, and the last 3 generally represent the serial number of the card. Hyper-V works kind of the same way. When you create a virtual adapter, obviously you can't stamp the MAC address in because it's virtual, so Hyper-V allocates MAC addresses much the way DHCP allocates IP addresses. And so when you create a VM, and for the first time, before you boot it, there's actually no MAC address allocated to the card. If I just kind of drill down in here and I go under Advanced Features, it's got no MAC address, and it's set to dynamic. When I boot this VM, I'll just turn this one on. So this is going to go nowhere. Oh, I got a fiber adapter card. So I may need to just remove that and reboot it. Just bear with me 1 second. Or I might get lucky. There may have been enough. No, it was. Let's just get rid of this fiber card.
Now, while you're doing that, one question that did come up is a question around network extensibility with these switches. If I have something like a packet forwarder, can I go and forward that information? And you can. The Hyper-V switch is extensible, so we do try to work with our partners and forward things over to Netmon, 5.9s, all of these kind of packet inspection extensions you can use. So that's fully supported.
So I've turned on this VM here, and there's no operating system. So we talked about installing operating systems earlier, but turning it on is actually enough to get it allocated a MAC address. I'm just going to power it off again, and we'll go look at the settings of it. And we'll go down here under Advanced Features, and you can see it's been allocated a MAC address. Now, look, if you pay attention, 00155D 317100. Okay, so I don't expect you to be, that'll be on the test, right?
Oh, I memorize
What
that.
was the MAC address of Corey's server? 387100. Remember that. The 00515D is kind of the generic Hyper-V manufacturer code, but you can change it. But point being, this now has a MAC address, and that MAC address falls in the range from specified on this particular server. Now, if you look real close, I took the first MAC address in the pool, right? Now, the reason the other 2 servers didn't is because they actually were migrated from another machine, so their MAC addresses were already set. But I took the first address in the pool here. The second VM I create would take the next one, and so on. And what Hyper-V does is it allocates MAC addresses out. Now, if you look at this real close, you say, well, if you do your hexadecimal math in your head, there's only 256 addresses here. So does that mean if I try to, what happens when I try to start 257 VMs? The answer is it'll fail. Where does this number come from? The number comes from the IP address of the machine when you installed Hyper-V. So that means that by default on a Hyper-V server, if you were to set up all your machines with the same initial IP address, like you might in a build lab before they go into production, they'd all have the same MAC address range, and you'd wind up with two machines with two VMs with the same MAC address. That's happened to people, right? It's up to you as the administrator to modify this MAC address range so that it doesn't conflict across all the different servers. You start thinking, well, that's really dumb. What a horrible thing to have to do. And the answer is you're right. But if this is managed by VMM, VMM manages the global MAC address pool. So if you have a lot of Hyper-V servers, this right here alone is one of the reasons you would want to put VMM in place. Because you don't want to have to worry about MAC addresses all across all your different Hyper-V servers. You want to put VMM on top of that. You can set this through script if you want, but this is set as a fixed range based on the initial IP address of the machine. And like what we do, for example, on our servers, is we immediately come in and just go, we just do this, and we make it huge.
Okay.
Right? So you have much less of a chance of and you can actually change these as well. And what we do when we're trying to track down MAC addresses. So for example, in our hosting infrastructure, we don't use VMM to manage the hosting servers because of the turnover rates. It doesn't work for VM. We use it to manage all the deployment stuff. But in ours, we use the first digit to represent the server the MAC address comes from, and then we give it a really big range, and it works fantastic.
Nice.
So you can muck with this and play with this and do all kinds of fun stuff with it. Or you let VMM take care of it for you. So I just want to make sure I point it out because I've seen people in the past get in trouble by just kind of forgetting about this. So some advanced networking features, just kind of talk about a couple of different things in here. You may have noticed within the settings of the network adapter a couple of different settings. ARP, neighbor discovery positioning, DHCP guard, port ACLs, trunk mode, and then network traffic monitoring and bandwidth limit and burst support. To kind of explain what these mean, have a look at the settings of a network card in a VM. And so we can look at the different settings in here. So we'll start with bandwidth management. Just like we did storage IOPS earlier, storage IOP limiting, this limits the bandwidth of a network adapter to a certain amount. So for example, you can have some VMs limited to 1 gig, some VMs limited to 10 gig, some maybe 100 meg or 10 meg, whatever you want to do. So this is just standard QoS for network traffic on the VM. Under advanced features, MAC address spoofing will actually emulate the MAC of the host machine. Okay, so there are scenarios where that may be necessary if you're running a firewall device or something of that nature. DHCP guard is pretty straightforward. It prevents DHCP packets from leaving the server. So someone can't set up a rogue VM with DHCP.
Now, why would that be bad? Ultimately, they could go and redirect those packets somewhere else, right? Steal information?
Well, if you have a rogue DHCP server on your network, that's a world of hurt right there. There's no easy way to get out of that.
Well, we should also not necessarily consider that people are doing that maliciously. You could have a developer that's going and setting up their own environment. They weren't correctly isolated. That could cause that type of problem. So definitely a nice security feature that's built in here.
So move this virtual machine to another cluster node if the network is disconnected. So again, if it's cluster aware, it'll actually migrate the VM if it detects a network fault. And then finally, you can enable port mirroring. And what port mirroring does is allows you to do network traffic analysis by having a VM that monitors the traffic of another VM. So for example, if you're doing advanced troubleshooting, so why my application's so slow, you want to do a packet capture. The way that most network analysis folks do packet captures is they take an old hub, a dumb hub, and they put it between the host and the switch, and they plug into it so they can see all the traffic. This emulates that sort of functionality. So you can monitor network traffic. And then finally, you can do NIC teaming. We'll talk about teaming in a second, but you can enable the adapter for NIC teaming, which passes the connection state of the actual physical adapter into the VM, so the VM can detect if you pull a cable or not, which is a nice thing to have. You have a VM where you want to do teaming. So you were mentioning a second ago virtual switch extensibility. One of the neat things about the Hyper-V switch is that you can extend it to do different things. And so, for example, there are companies out there that do this I believe the Cisco Nexus is one of those, where they inject filters into the switch that allow you to do advanced filtering of network traffic, advanced monitoring of network traffic, and just take that Hyper-V switch and make it more powerful than what it is. So this isn't something that the average admin is going to do. You may buy a product that does Hyper-V switch management, and it does so by injecting a layer into the switch to give it advanced functionality. When you do when you work with Virtual Machine Manager, Virtual Machine Manager actually does this. So it interjects a Virtual Machine Manager switch extension that allows you to create virtual adapters and pipe them through single physical adapters to give the switch more capability that's only available through VMM. So it's this is present, it's available, and as you get products and as things evolve, you'll be able to add extensions to the switch to get different functionality. SRIOV, a little drink of water real quick, I'm getting dry here.
Stands for Single Root I/O Virtualization.
Good timing. SRIOV is a way of passing calls directly from the NIC into the actual VM.
Skipping the hypervisor layer?
Skipping the hypervisor layer entirely, going around it and straight into the NIC. So this is something that you would do on very high network throughput VMs, okay? Very high network throughput VMs. So for example, that database that's handling tons and tons of transactions, and you want to get the highest possible network performance. Higher throughput, lower latency, reduced CPU overhead by essentially bypassing the parent and paging that data directly into the switch in the VM. So it's not something you really have to configure. You need an SRIOV enabled network card. You typically turn that on through the properties of the NIC, and then on the VM itself, on the switch, sorry, on the switch, but on the network card, under advanced features, or sorry, hardware acceleration, you would enable SRIOV.
Now, as a hoster, do you actually use this?
No.
Is this something that you would think about with future acquisitions?
No, it's not, because we're not running VMs that require high network throughput.
They're generally local, right? A kind of isolated environment within the host.
So, if you want an example of what might be this, let's say you have a file server in a VM that's holding user profiles for 1,000 users, right? Very high throughput VM. You have an Exchange server in a VM that's got mailboxes for 10,000 users. You've got a SQL database or a SharePoint site. It's an application role in a VM that's passing a lot of data on the network and handling a lot of connections. And you just shortcutting the path so that you're not going through the parent partition's driver model into the VM, you're going around it and straight into the VM. But you require SRIOV enabled network card, which most of them have that capability, quite frankly. There's very few that don't. You just have to, by default, it's typically not turned on. You just enable it on the NIC and away you go. And the only gotcha is that if you want to live migrate a VM and it's an SRIOV enabled NIC, you've got to make sure it's on the other side as well, or it won't work. So it's something you just enable across a cluster, for example. Virtual machine queue. This is another very similar piece of functionality to SRIOV in terms of concept, in that it allows data to be paged directly into the VM, it's essentially shortcutting the path. This is turned on by default on all network adapters you add to VMs. It's not necessarily turned on by default on all network cards, but once you turn it on, it's simply going to be used. And it allows the CPU load in particular to be reduced on the host by just bypassing some of that host stack going directly into the VM.
So a good example might be, a high CPU intensive application is running inside a VM, so you want to kind of offload some of those CPU cycles from the host over onto the network.
Absolutely. Again, these are functions that can make throughput better, where there's nothing you really got to do to configure them other than turn them on or off. And if you turn them on, the operating system, Hyper-V, knows how to figure this out and make it work. And so as I showed earlier, this is where the advanced features live, just under the settings of the switch. And then finally, before we move into network virtualization, talk about NIC teaming for a little bit. So NIC teaming is a way of, and this is a very old concept, there's nothing new here. It's a way of taking two network cards and pairing them so they act as one, right? Just like you want fault tolerance in your storage channels, you also want some fault tolerance on your network. There's basically three fundamental ways that you can do teaming. There's link aggregation, which you can take, two 1 gig ports and you aggregate them into a 2 gig port. Requires the network card and the switch to communicate together to treat it as one channel. You can do standard, what they call switch independent teaming, where the operating system teams them together, but the traffic only goes over one of the two cables, essentially. And if one of the cables fails, it seamlessly goes to the other cable. So it's redundancy, but not a performance throughput. And then there's other variations that are, kind of vendor specific, that do different, variations of link aggregation, of standby, active passive type cables. And you can go upwards of, there's like 32 cables to a single link. The one thing that teaming doesn't do is make data necessarily go faster, right? Because a 1 gig cable is still a 1 gig cable. However, in the past, when you wanted to do NIC teaming, this is 2008 R2 and sooner, you needed drivers from your network card vendor to do this. That is no longer the case now. If you have a network card, you have two network cards, you can team it directly within Windows. And so to kind of show you how this operates and how simple the teaming is to actually do, let's go over here to server 1. What I'm going to do is just shut this guy down and add a second network card. Adding a network card is not something that you can do while the VM is actually running. So we're going to shut this guy down.
Now, I think, to kind of add to what you were mentioning here about the inbox NIC teaming, this is driving down some costs for our customers as well.
Absolutely.
In the past, when they had to learn this NIC teaming software, it can be kind of complicated. And so there's often a lot of vendor lock-in and investment in training just how to use these particular driver models, this teaming software. So now that we've kind of standardized it, almost virtualized it conceptually, it's much easier to do it using these inbox tools.
Absolutely. So what I'm doing here is just adding 3 network adapters to this server. And this is the generation 2 VM, so I can only add synthetic adapters. I'm going to boot it up. So once this guy boots up, we're going to go ahead and log on to it and configure a network team. So that's all I've done. Just multiple network adapters. These can be, these can be virtual adapters in a VM or physical adapters on a host. If you go down the road of using virtual adapters in a VM, and there's a lot of theory around, kind of how should you team things? Should I team the host? Should I team the VMs? And this is kind of the way I describe it. If you have 2 cables going to a switch on a Hyper-V host, it's worth teaming them. If you have 2 cables going to different switches, what you would do is create a Hyper-V virtual switch for each interface, go into each switch, and then team within the VMs. So if either switch goes down, the team within the VMs will actually take over and keep the link up. And you would check that box on the settings of the VM to say that the interface is enabled for teaming, so that the link state, connected, disconnected, up, down, can be passed to the VM, so the VM knows, hey, the actual physical link went down, and can respond in the team accordingly. So we're going to go ahead and connect to this one. Let me, once again, because of the screen resolution, drop this way down to itty bitty. We're just going to log on here. And so teaming's a piece of cake to configure. We're just going to go into Server Manager and do it. Let this guy boot up. Server Manager should fire up for me.
Now, we did have a question come in, kind of asking how these virtual network adapters and virtual networks interact with firewalls. They just work with Windows Firewall and same way, no special considerations here.
There's nothing special about them, right? It's just an adapter. There's nothing special. And then when you make a team, it creates an additional teamed interface on the machine, and that just becomes the one that you configure. So I've got Server Manager up here. I'm just going to go to my local server area. And this is just still taking a second to settle down right after I boot the machine. So we'll let this collect up here. Yeah, so nothing special on the firewall, nothing additional you've got to do. You would just manage the interface a little bit differently. So if I go down here under network teaming, so there's my adapters that are all DHCP enabled. You'll see NIC teaming is disabled. Click on that disabled link. It's going to open the network teaming configuration tool. And I just go Teams, New Team. And I'm doing this in a VM, obviously, but you could do it on the host, right? The process is the same. Check the 3 adapters. My team. Because I'm in Seattle, I call them the Seahawks.
Nice. Good to have a winning team up there.
Yeah, that's right.
Where are you from, Tampa?
We're not going to go there.
We got an international audience. We won't go too many football jokes here.
Yeah, we'll just get laughed at. So that's going to go ahead and create the team, and you'll see it's now kind of querying the status, trying to figure out what's connected, what's not connected. And this one, this one, in all fairness, is not going to work 100% properly because I haven't configured it as a pass-through team. So what I need to do is come down here under each of these adapters, under advanced features, enable this to be part of a team, enable this one to be part of a team. There we go. All right, so now it's actually picked everything up. And so I've got a 3-adapter team. It's showing all links as active. The team is up. And if I look at the actual network adapters now, so I was going to refresh Server Manager. You'll see an additional adapter appear down here, which is the team. And you'll see the other adapters kind of went away, right? Because now the only adapter that we're really concerned about is the teamed adapter. If I look at the actual network connections, here's the team. Here are the actual physical adapters. But when I want to configure things like IP addresses, this is now where I do it. I do it on the teamed interface, not the adapter interfaces. So this is where I configure things like a static IP or whatever the case might be. On the teamed interfaces, if you look at those, all they've got on them is this Microsoft Network Adapter Multiplexer protocol. So they've had everything else removed because they're managed adapters as part of a larger network team. So there you go. That's how you essentially configure teaming. Now what I've done here is, quite frankly, pretty dumb because I've teamed 3 adapters plugged into the same single cable. It's not, not...
Yeah, I mean, that's still pretty simple to set up. There's actually a pretty funny comment that I'm just reading coming through here saying it was harder to actually break our old team than it was to go configure the new team, just to go use that new feature. So as you can see, pretty straightforward to implement. And again, regardless of the underlying actual NIC or hardware manufacturer, we support all the different APIs, all the different
I can mix. I can mix. Broadcom NICs, Intel NICs, 3Com NICs. Are there still 3Com NICs?
Who knows?
I don't know. I primarily use Intel NICs, so some Broadcom, but primarily Intel. So yeah, you can mix manufacturers. You can even mix 10 gig and 1 gig, but don't, because it won't. Just don't. Same speed. Same, ideally, as similar as possible. Because you want all links to behave the same. And like I said, what I've done here is inherently stupid because I've got a team of 3 interfaces plugged into 1 cable. What I would ideally want in this scenario is I would want three external switches, each going through 3 external physical cables to bring the team all the way into the VM and have it actually protected from one of those links going down. So that's pretty much what that's all about. But wanted to show the example of how you actually configure it.
Cool, so that's really covered kind of the host networking pretty well and even kind of extending up to our virtual machines a little bit. But now we're going to kind of move on to a new concept and talk about network virtualization. Yeah. So I guess let's kind of kick it off. Why do we care about this?
Well, we care about it for this reason right here. So this is a really complex animated slide where little colored balls are going to slide around, okay? But put yourself in the position of either a hoster or a company that has acquired another company needs to bring them in. In either way, you have, say, multiple logical subnets that need to cross around your data center. So I have, a 10 dot subnet over here that needs to talk to a computer on the 10 dot subnet over here, 4 switches down the chain, and there's another 11 dot, and these, we had isolated traffic crossing switches. That's kind of the scenario, right? Isolated traffic crossing switches. And if you look at this, I have 3 VLANs. I've got kind of red here, I've got kind of green here, and I've got kind of the sort of a bluish purplish color there. And I've got different servers that are on different colors. And so what you're seeing here is this green server can only talk to other green servers because the switches, as you can see right here, have been configured with the same VLAN ID. So every hop along the way has to understand the VLAN. So let's look at a scenario here now where, I want to erase a little, there we go. I'm going to get rid of some of this. A scenario where I'm adding another server. And because of physical limitations, rack space and cages and whatnot, this VM comes over here. Now what I've got is a scenario where, let me get my pen, where I've now had to add additional VLAN information all across the board to make sure that these two hosts here can talk to each other. All right? Let's look at another really bad example. I add another host all the way over here. Now look where I've all the edits I've got to make.
A lot of things happening, huh?
Now, look at all the potential to screw things up and take everything down. Right? When you start messing with things like VLANs and whatnot, it's scary. Like, anyone who does that will tell you they're terrified. And how do they manage it? Most of them do it with Excel. Massive spreadsheets. Remember the days of managing static IP addresses. If you create a conflict, something bad happens. Well, it's amplified if you screw up or mess up VLANing and you take half the data center offline. Very, very tricky stuff. And so the result of this is, managing VLANs, not only do you have a limited number, but you've got to update them constantly. You've got to track where everything is because it's port specific. Port goes down, I'm going to move it to a new port. Is it on the same VLAN? Am I going to inadvertently plug, Pepsi server into Coke's VLAN, and all of a sudden the recipes are going to cross over and we wind up with Mountain Dew or something? I don't know. So that's kind of the problem. Software-defined networking is the solution, where we don't define things at a physical level, we define things via software and via policy. And what that allows us to do is say, we don't care about the physical, we only care about the logical. We only care about, what is this host or this VM logically contained, what is it logically allowed to talk to, and rely on software to govern everything else. So what that means in real terms is we're allowing Hyper-V, because this is all with network virtualization. These are VMs running on Hyper-V servers, and we don't worry about VLANing switches. We let Hyper-V figure out which VMs on which hosts are allowed to talk to which VMs on which hosts, and take care of isolating the networks that way. Now, the way Hyper-V is going to do it is using generic routing encapsulation. So here's I'm kind of jumping a little bit ahead of myself, but here's kind of what it looks like in practical terms. So in this example right here, I have two customers, right? So I've got a blue customer and I've got a red customer. Okay, so you can see them right here. They need to talk to each other, but they're on different Hyper-V hosts. And if you'll notice, they've also got the same logical IP range. Now, you start thinking, well, how would you make this, two machines with the same IP address on the same host talk across the real network? The answer is the only way you could really do it is VLAN things, which is lots of cables. But what network virtualization does is allows you to take all those IP addresses and create what are called mapping. So the host tracks what the IP addresses of the VMs are, what the IP addresses of the hosts are, which VMs are on what hosts, and builds what is essentially this type of routing table. And says, hey, you want to talk to, if 11 wants to talk to 12, 12 is over on this interface on another server, and is able to take that packet, wrap it in a generic, an additional TCP/IP packet with routing information, figure out which host it's on, and ship it over there. And this is all possible through Virtual Machine Manager. So Hyper-V has these inherent routing tables, is a good way of thinking about them. Virtual Machine Manager keeps them synchronized across all the hosts. So when a VM wants to send a packet to another VM, Hyper-V knows which virtual network it's on, which host owns that virtual network, and where to route the actual packet. So in effect, the host acts like a big NAT device. You want to kind of, one way of kind of thinking about it. And it's all governed through policy. And the policy comes from Virtual Machine Manager. Okay. Now, I know this is a very conceptual topic. It's somewhat confusing to understand, and I totally get that and I totally understand that. Where it'll hopefully begin to, to kind of gel together is when you start looking at the actual objects you create in VMM. So when you define, for example, a virtual network, and you say, here's the hosts this virtual network is allowed to live on, and here are the ports that virtual network's allowed to connect to. And is it a network virtualization enabled virtual network? So when you create a VM, that's all turned on by default, and it just figures out where to send everything. And the key here is that when virtual machines move around, this is all updated. So when a VM's running on a host and you say live migrated to a new host, part of SCVMM managing that live migration is it goes and updates everything. So that now that particular IP address, maybe of this SQL server, is now on a different host, and all the network virtualization, quote unquote routing tables get updated accordingly so it knows where to send that data.
So good questions kind of covered here. What are the components actually used to manage this? Is there any hardware involved, or can everything be software based?
Everything is fundamentally software based, right? So there's the only hardware piece that would be involved would be a network virtualization gateway.
And that's optional whether it's hardware. You can have virtualized ones.
So what I mean by that is the network virtualization gateway provided by Microsoft is a VM and a host combination. So you have a certain Hyper-V host running the network virtualization gateway that's able to talk to assorted virtual networks and then route that traffic out. Or you can get hardware-based network virtualization gateways. So there are some hardware companies that actually manufacture these. But otherwise, no, this is 100% software-based. So you can create a whatever switching fabric you want, and then you define a virtual network that is across all the hosts in your data center. And then when you create a new VM, you simply say, this VM's on this virtual network that all these hosts know about. And so when that VM goes to communicate on the network, if there's another VM on that same network on another host, the routing tables know that 10.1 over here, 10.2 is over here, 10.2 is on host A and is able to route the traffic to host A and then into the virtual network again. So every Hyper-V host acts like a mini NAT device that's publishing everything and bringing everything in. And GRE is the generic routing encapsulation, industry standard protocol for just putting a TCP/IP packet inside of another one for the purpose of shipping it somewhere, is used to move the data around. It doesn't incur overhead, a tiny bit, not a lot. Certainly it doesn't outweigh the complexities of not having this in place. So that's the basics of network virtualization.
Alrighty, well, we have just about wrapped up this chapter now, so we're going to go ahead and take a 10-minute break. After we return, we're going to go and look at Hyper-V VM mobility, so things such as live migration, as well as Hyper-V Replica, being able to do point-in-time replicas of our virtual machines for DR.
Some really cool stuff coming up.
Very cool stuff, so stay tuned, we'll see you shortly. Welcome back to the Server Virtualization Jumpstart. We're now starting Module 5, where we are going to look at virtual machine movement and Hyper-V Replica. I'm Simon Perriman, Microsoft Technical Evangelist, joined by Corey Hines, President and Lead Architect of Hull Systems. So Corey, virtual machine movement and mobility, what is this? Why is it important?
This is probably one of the coolest things that Hyper-V does. If you think about, the idea of a running operating system, and you think about, well, I want to move a running operating system somewhere else. Well, the first thing that typically comes to mind is, well, okay, you got to shut it down and move something. And with Hyper-V, you don't. You can move anything, anywhere, anytime, without any downtime at all. And that's utterly phenomenal for every scenario known to mankind. A lot of this originates from clustering. Now, the next module is more about clustering, but we're going to be alluding to a lot of things as we work through this. So, as an example, your VM's on a disk, and the disk's running out of space. You need to get the VM to a bigger disk. You don't need to turn it off. You can just move it. Your server's got a hardware issue. You need to get your VM to another server. You just move it. It never has to shut off for anything. And so what this fundamentally means is you get to move the configuration of the VM. You get to move the VHDs of the VM without any downtime. That's where we get this idea of live migration, and whether it's shared live migration, which is within cluster environments, or shared nothing, which is not a technically correct term, but it's a very accurately descriptive term of moving a VM from a host to a host with nothing but an Ethernet cable, and then also moving the storage, which through what's called storage live migration. And then finally, Replica, which was introduced with the previous version, has gotten better with this version. So those are the things that this module is going to address. So first of all, when we talk about high availability and redundancy for virtualization, why is it important? Well, I love this because, as a person who owns a hosting company, as soon as well, here's what I find, and I'm going to say you're guilty of this as well as anybody. As soon as you give your stuff to someone else, downtime becomes, why is it down?
Right. Your problem, right?
Exactly. But what the reality is, downtime is impossible. We're dealing with hardware, we're dealing with software, we're dealing with people. Three imperfect things, right? Of course, there's going to be downtime. It's a matter of how do you minimize the risk, mitigate it, and how do you respond when downtimes occur. So it's not, it's guaranteed that, it's not a matter of if, it's a matter of when and how badly that you're going to go down. Stuff is going to go down. So, why do we have to take stuff down? Obviously, hardware failure being the single biggest culprit. As soon as you turn on a piece of hardware for the first time, you've started a clock to when it's going to crash. Might be next week, might be next month, might be next year. We had a server, as an example of how, stupid this can be. With 8 SSDs in a RAID 0 could sustain 3 SSD failures before the volume goes offline. Lost 3 disks in 4 hours, about 4 days ago. That wasn't a production server, it was one we're using for some test scenarios. Brand new SSDs, less than 6 months old, right? Who would have thought it? But if you start looking at, these idea of nines of availability, which is how the industry often measures this thing, 99% availability is 3.7 days a year. It's a long time.
Of downtime.
Yeah, it's a long time. 3 nines, 8 hours. 4 nines, 53 minutes. 5 nines, 5.3 minutes of downtime a year. It's very, very difficult to achieve 5 nines of availability because even in the event of an unplanned outage, when something has to fail over and reboot, there's a couple of minutes involved in that. So you need a lot of luck, a lot of redundancy, and a lot of planning, and a lot of money spent to get to that level of 5 nines. For most organizations, 3 nines is kind of what they sort of strive for, which is, a couple of hours of outages every quarter or so for, regular preventative maintenance. And that's generally, considered pretty acceptable, I think, as long as it's planned for accordingly. So within Windows Server R2 and Hyper-V, what are the components we have in terms of preventing failure? So first of all, for hardware failure, you cannot prevent hardware failure. You can only have 2 of them and have a standby for when it does happen. But there's some framework within Windows in terms of being able to hot add memory, hot add hard drives, so that when things happen, you don't have to go down to recover from it. You can just recover from it. Within the physical server, live migration for planned downtime and failover clustering for unplanned downtime. With I/O, NLB and teaming, storage multipath, and SMB multi-channel. So this involves, not the server going down, but a channel going down. And in real terms, this translates into a cable failure or translates into a switch failure. We see an inordinately high failure rate on 10 gig cables. For some reason, they will just, cable will run fine, it will just fail. And it seems to be, we use a lot of 10 gig cable. Much higher failure rate than we see, for example, on traditional 1 gig cables. So, you got to plan for these things. If you're running fiber channel is glass cable. It's got a bend radius before it breaks. And you get, someone who's running cable and they just kind of jam it or something a bit and they kink it, you get a cable failure. So I/O redundancy is really built around, cable and path failures or, potentially switch failures in the middle. Switches don't fail often, but when they do so very spectacularly. Application service failure. So for non-cluster-aware applications, there's a feature within Hyper-V called application monitoring, which allows you to monitor services running within an application, determining if they fail, and then possibly either restarting the service or failing to another node. You have guest clustering through iSCSI Fiber Channel or VHDX, and you have guest teaming of SRIO VNIX to ensure that you have maximum uptime. And then finally, for disaster recovery, asynchronous replication with Hyper-V Replica, so off-site, so you can replicate to another server within your data center, off your cluster, or to another data center entirely. And then also synchronous replication of CSV, so you can do replication from storage array to storage array, so that you have an identically mirrored storage array. You're starting to get, the higher up you go in this chain, the more expensive things get. Replicating your CSV volumes, that's another SAN. That's expensive. You're talking in increments of, tens of thousands, not thousands or hundreds of dollars.
Incrementally expensive, except for Hyper-V Replica, of course.
Of course.
Of course.
We have
free in inbox.
We have an ongoing joke, of what things cost in data center dollars. And, and a $20,000 server is about 10 data center dollars. Data center dollars worth about $2,000, which means that's about the minimum you're going to spend on anything in a data center. So, we jokingly use the term data center dollars, just to take the edge off some of the bills. All right, so moving along, a key tenet to all of this is the ability to move virtual machines from location to location, either from host to host or locations within a host. Now, we're going to do a lot of demos in here to show you kind of what this looks like and how you do it. But here are the basic options. Virtual machine migration and storage migration. Quick migration. Quick migration is the ability to move a virtual machine from one host to another within a cluster by first saving it and transferring it. Live migration, which is moving it without taking the virtual machine offline. Now, here's an interesting question that often comes up. Quick migration versus live migration. When is quick migration better than live migration?
Well, what's kind of odd about quick migration is it's often faster, actually. So if you can actually survive application downtime, you need to quickly evacuate a host to patch it, and you are willing to risk that downtime. Yeah. Oftentimes, you would go and use a quick migration rather than wait for everything to be
With live migration, you migrate the VM. While the VM's migrating, the VM's also changing. Mm-hmm. So you've got to now migrate the changes. While you're migrating the changes,
differential changes. It's kind of a recursive algorithm.
And so eventually it gets to a point where you catch up. But certainly there's more data moves at the end of the day. As a result, the migration actually can take a little bit longer. So quick migration is typically the fastest way to evacuate a server. Live migration does so without downtime. You have Hyper-V Replica. Then you also have just import and export as a way of moving a VM. So for storage migration, I'm going to show you an example of this now in a second by actually taking my live running domain controller and storage migrating it to a cluster. Scary, but we'll do it. So we have essentially what's happening here is the virtual machine's receiving, the VHD is receiving reads and writes. It's copied to the new destination while it's still running, receiving reads and writes. The writes are mirrored. Once it's all synchronized, the virtual machine is switched to the new disk. And that's all done on the fly. There's a micromillisecond pause in disk I/O, and it's designed to handle that while it just transfers it to the new disk, and then the old disk is destroyed. And so what that looks like, think of for VMware, storage vMotion is the VMware term. What that looks like is this when we actually go do it. So if I go, let's take.
Now, while you switch over, a good sample exam question about storage migration might be, what is a good way to perform maintenance on a disk without causing downtime to a virtual machine? In this case, you could storage live migrate the VHD files off of that disk, do your maintenance, storage live migrate them back once it's healthy.
Exactly. The other scenario that we've seen it used for is when we want to take, take a particular VM and we want to move it to a new SAN enclosure, a faster SAN enclosure, without having to take the VM offline. Mm-hmm. So in the past, you have to shut it down. You have to export it, or export-import it to get it moved. Now you can just say the VHD, you go from this folder to that folder.
And we don't really care what type of storage array or storage interface, right? You could go move it to SMB, other different types of shared storage, so long as we have connections and access.
So if I look at my domain controller here, this one is, let's remove, I don't know what that file is. Can't do the domain control. It's actually got a reference to a non-existent file. So let's just do this Win client machine here. So I look at this Win client machine and I go look at the settings of it. You can see it's actually stored in a storage folder up on my Scale.it file server. Mm-hmm. Now let's say I want to move that to another storage location entirely, right? So let's say I want to take that and move it to off of the Scale.it file server onto the local CSV volume on this cluster node. So if I look at this cluster node I'm running on, I've actually got a CSV volume here, volume 1, and I want to create a new folder in here. I'm going to call this one VM storage, and I want to take it off the file server, because maybe the file server is going down for maintenance or something. I don't know. I want to get it off the file server onto the local CSV of my Hyper-V cluster. So I've got a folder for it. We're just going to take the VM, move, next, move only the storage, so this bottom part right here. I want to move all the virtual machines data to a single location. Browse to the local folder. I identifies the available space, current location size, identifies the files and disks it's going to move, click Finish, and you'll see it actually begin to perform the move. And if you look at the status down here, moving storage, synchronized, this is going to take a little while. It's a fairly big file, and the network connections I've got are only 1 gig, so it's going to take a few minutes to actually conduct the move. So we'll just leave it running in the background, but the point is that this admin VM, this Win client VM, which is right here, is still 100% active and using while the VHDs are being migrated. Massive, massive enhancement for Hyper-V because it enables all sorts of scenarios, moving from one LUN to another, moving from a file server to a local disk, from a local disk to a file server, from one file server to another file server. All those scenarios all of a sudden become possible when you put this in place.
Now, a lot of people ask me, hey, if you now have the flexibility to move out of clusters and move between 2 standalone hosts, do I really still need clustering anymore? And the answer to that is absolutely. When we're talking about doing a live migration, this is for planned downtime, planned failures. And the reason why is that both hosts need to participate in this handoff as we're copying the information. If you have one of the servers crash, it can't participate in this handoff. And so you have what we call an unplanned failure, where we actually have to take recovery actions. That's where failover clustering comes into play. It detects the service is down and restarts it, or it detects a node is down and restarts it. So even though you now have more flexible live migration, it doesn't mean the clustering is any less important for unplanned failures.
Now, that being said, I have seen people use this as what I call a poor man's cluster.
Poor man's cluster, yep.
Yeah, which is 2 hosts and a file server, and I didn't cluster anything, and I want to be able to move them between the 2 hosts. You can do that with shared nothing live migration. You can store the VHDs up here and just move the VMs back and forth. But if the node dies, it doesn't auto-recover.
That's the challenge we have, yeah. So we definitely want to encourage clustering nevertheless, yeah.
Poor man's clusters are fun, though. They're only like $2 data center dollars.
Very cheap.
All right, so that's storage live migration is chugging along. Now up to 15%. The funny thing is this will get to like 30% and then tell me it's done. So I don't know quite why it does that, but that's what it tends to do. The little thing's got to bounce up and down somewhere. So that's the move wizard that we just showed you. Live migration of non-clustered virtual machines. This is the notion of what we called shared nothing live migration. The idea that I can take a VM and I can move it from one Hyper-V host to another without having any cluster component between the hosts. So this is done by doing first a storage migration, and then once the storage migration is done, then doing what is essentially a live migration over Ethernet.
But we still expose it as a single operation.
Exactly right. So to show you what this looks like, we're going to come in here, and so it looks like that's finished now. Settings. Take our Win client here. Close that down.
Now, while Cora is working on that, I want to bring up another best practice, a kind of a common problem that we see customers run into, and that's trying to live migrate between 2 different processor families, such as an Intel to an AMD live migration. And this actually won't work, and this is due to the actual processor architecture, how it builds the memory. It's just done differently on an AMD machine and an Intel machine. So you can't take that run-in memory, copy that running memory across these 2 different processor families. And that limitation isn't unique to Microsoft to Hyper-V. That's going to be consistent across any hypervisor that you use here. So generally, what would you do if you want to do a migration between these 2 different systems? Well, you can't do it with the live running memory. So you would have to shut down that, flush out the in-state memory to disk. Then you can go and actually move that between these different systems.
Absolutely.
But Corey, what happens if I have Intel from 2 years ago and I have Intel from today? How do I do the live migration between the same family but different versions?
In order for that to work, within the properties of the processors, you've got to turn on what's called processor compatibility. So if I just look under the compatibility section, I would check this box. Now you've got to check it on when the VM shut down. But what that does is it limits the feature set the processor exposed to make it more broadly compatible.
And it steps it down, right? We go to the lower level.
Correct. So now you get broad compatibility across multiple different processor sets. So this is something that is a really unless you know you're not going to change CPUs, it's a good thing to always check.
Yep, and it could be something, a very popular exam question. I've actually seen it on some of our older versions of these exams.
Absolutely. As well. So now what we're going to do is we're going to take this, this Windows 8 client, and we're going to do a shared nothing live migration down to this server called HV3. So we see that the storage migration is completed. I've now got the disks down on the local CSV volume. So we're going to take that, and we're going to move it. So we're going to move the entire VM. So not just the virtual machine storage, this is the top option, moving the entire virtual machine. Name of the destination computer, HV3. Move the virtual machine's data, move the virtual data by selecting where to move the items or only the virtual machine. What this means is the top one essentially moves the entire package. The middle one allows you to specify different folders. So if you want to put the snapshots on one folder and the VHD on another, and then the bottom option moves the virtual machine but leaves the storage in place. So destination folder, click finish, and this will take a little while, but we're going to let it kind of chug along in the background. So you can see if I just kind of click out of this, here the virtual machine is moving, kind of chugging along, and if I look at this guy Win client right here, it's still running. And we're just going to kind of leave this guy running and connected, and what you'll see is that I'm already P'd into this VM while the VM has been transmitted to another host entirely, and they're not in a cluster. So pretty powerful stuff. And if I get I think I can actually ping. I don't have ping enable on the machine. So that's what's going on there in the background. So that's chugging along, 6%. This will take a little while to get over there. Last time I ran this, it took about 15, 20 minutes. So that'll just we'll just let that sort of run in the background while we're working through stuff here. So here's kind of a look at what happens in memory. And so we were alluding to why live migration might be a tad slower than quick migration. This is sort of an illustrated example of what happens in RAM. So why that's the case. So after you've completed the storage migration piece, which is the first piece, you migrate the configuration, which is essentially the XML files, and then also all the contents of memory. You'll notice that while that migration is happening, there's some changes. The little red dots are happening. They've got to get replicated. So that little extra bit is what takes it a little bit longer.
We're basically tracking the pages in memory that get dirted.
Absolutely.
Do that in a recursive subsequent call.
And then finally, the MAC address is updated, and the final copy operation takes less than a TCP timeout, which is about 25 milliseconds. So at most, you will see maybe a dropped ping or two, but is not enough to cause any application to disconnect. So as far as users and applications are concerned, it never went down. If you're running a ping, you may see a missed ping, because the pings are typically less than 1 millisecond, but that's basically it.
Now, at the end of this operation as well, we will actually go and clean up that old Hyper-V host, free up those resources as well. But before we move on to this section, I want to answer a few more questions that we get here. One of them is the best practice around simultaneous live migrations. So in this, the 2012 release, we support multiple simultaneous live migrations, both storage live migrations and network live migrations. We don't actually place any hard limits of the number that you can do. So a lot of people think, well, maybe I'll just put it up to 1,000 and try to do as many as this host can have at the same time. It's actually not recommended. What we really want to encourage people to do is find the sweet spot of how many simultaneous live migrations. And that's going to be dependent on the actual application running inside the VM. Now, the reason why is if you think about what's happening when you do a live migration, you kind of do that initial file copy, and then you have to do that secondary, tertiary copy. Now, the pipe's only so big, so maybe the first live migration, you can do 1 in 1 minute. Maybe with 2, you could do 2 in 2 minutes. But as you start to gradually scale up and you're trying to do, let's say, 20 at once, they're going to go as 20th as slow. Now, since they take 20 times as long, we then have a lot more additional pages on the original VMs, on the original hosts that are changing in memory. Those changes then have to be replicated. And again, that's going to take even longer, which means more changes, more replication. So sometimes it's actually not going to be faster. From our internal testing, we found the sweet spot's usually about 4 to 7 VMs simultaneously. But really the biggest thing is what's happening in memory. If you have something like a VDI, a thin client VM, where no one's really doing anything, they're browsing around on a local tool or Internet Explorer, not much memory is changing for that secondary copy. If you've got like a high-end SQL application, a lot of memory is changing. that second copy is going to take a long time. That third copy is going to take a long time too. So that's kind of the balance they're finding that sweet spot.
Yeah, there was a lot of misconception around, serial, parallel, do a bunch at the same time, and the reality is it tends to be quicker if you do them one at a time, just one after the other, just for that reason that it gets to do one task.
Right. Now, Corey, again, before we move on, another couple questions came up. Now, we talked about live migration over RDMA earlier, speeding that up. But we also want to talk about live migration compression. Could you just touch on that a little bit, this enhancement?
Yeah, there's not really a lot to it, per se. It's a matter of being able to compress. It comes at the cost of CPU, but you compress the data so the live migration goes quicker. And it's just a matter of when you're configuring this, and so I believe I can pull this up right in here under the settings of the virtual machine under live migrations. Where we to expand this advanced features, where you can choose both the authentication protocol and performance availability. So for example, you can just do straight TCP/IP, which is the lightest on CPU but a little more on data, do compression, so there's less data that goes across the network, or you can do it over SMB, which will use RDMA if it's available. So default is compression, but you can adjust this based on what you want. If you know you've got RDMA enabled network interfaces between everything, you can switch it to SMB, which will attempt to leverage that, which is the fastest possible option.
Cool. Now, final two questions I've seen come in, and I get these a lot, talking about live migrations between different platforms. So first of all, can I live migrate between VMware and to Hyper-V or back? And the answer to that is no. There are actual technical limitations, or even if you're going Intel to Intel, how memory is actually built and managed. So you can't just do a live migration from one to another. Whenever you migrate between these platforms, there will be some downtime. Second question about these cross-platform migrations we get a lot is, can you live migrate up to Azure? Again, the answer to that is no, we can't. There's a few limitations on just basically how memory is managed up in Azure, even though we use the same type of virtual machine and VHD files. Now, Corey, you briefly mentioned earlier, I'm hoping you could just cover this again. What is the process to go and move a VM that I've built for my own data center and make that running up in Azure?
There's a couple of things you have to do with it. There's good documentation on this on Azure's website and their documentation, but it basically boils down to a couple of things. Number one, you've got to make sure the VM meets the requirements for Azure, which is single NIC, DHCP, with RDP enabled. Those are the big things, right? It's got to be VHD format. So if it's VHDX, you convert it to VHD. You upload it, you then create a new VM using that VHD from your library, attach your new virtual machine definition of that VHD, boot it, and then if all goes well, you should be able to RDP straight into it.
Okay.
It doesn't all, you might have to try it a couple of times. If the RDP doesn't work, the only choice you've got is to bring it down, test it, re-upload it again. What I generally recommend to folks is, before you upload it, put it up, take the VHD, put it on a Hyper-V box that's got a DHCP enabled interface, make a new generic VM and turn it on and see if you can hit it over RDP. And if you can, then you're usually going to be okay.
Great best practice.
So that's because honestly, the uploading bit can be painful. Because if you've got a 40 or 50 gig VHD, upload speed being what it is, it may take hours, if not days, to do an upload. Now, I believe Azure's, I thought they announced like a hard drive shipment service now or something.
I don't know about that, but
yeah, we saw an announcement too long ago where you can maybe like ship a hard drive to Azure with your stuff on it, and they'll actually connect it and put it in your subscription for you.
Very nice.
So we'll see what that happens. I hope that was public information. It came to me in an email, so there we go.
We'll see.
All right, so what we're going to do now is take a look at Hyper-V Replica and kind of look at what that's all about. Hyper-V Replica is the ability to take a VM and create a replica copy of it in an offline state on another server, nothing to do with clustering. Okay, and so the idea here is this is a hot standby. Now you might say, well, I can restore from a backup. Well, that's fine, you can, but you've got to go through the time of conducting a restore. This means you can power on this VM, and it's as current as up to 5 seconds ago. So your cluster goes down, completely dead. You've got a standby copy you can power on over here. We actually use this in our own environment consistently because our infrastructure, our core infrastructure, our management infrastructure runs on Hyper-V clusters, and our immediate sort of hot, I guess warm standby solution is a single server with replicas of everything. So should this cluster for some reason just die, we can power up all our infrastructure over here and get everything back online relatively quickly. And we use DPM for the SQL databases, so we can bring this up, restore the latest SQL database, and we should be good to go. So for prerequisites, first of all, obviously Windows Server 2012 Hyper-V. This is 2012 supports Replica. Hyper-V 2012 R2 supports Replica and extended Replica. You obviously need sufficient storage and connectivity. You have to enable a couple of Windows firewall rules. Now, I will gripe about the Hyper-V UI guys for a second, because when you go in and turn on Replica, it pops up a cool little message box that kind of sounds like it's doing it for you. But really what it's doing is saying you should go turn on these firewall rules, and everybody forgets. You forget, I forget. We were just talking about this in the break about how we always forget this. So you got to remind me, and we'll try not to forget this when we do it.
Demo will be good.
And it's either HTTP or HTTPS. And then finally, you can do either CRED SSP if everybody's in the same domain, or you can use certificates. And there are hosting providers that, as an example, will offer Hyper-V Replica Endpoint as a service, and they use certificates for authentication. So here's kind of the components of Hyper-V Replica. You have the replication engine that does all the replication, the change tracking module that records write operations and ensures they get sent over the wire, the network module that handles the authentication, compression, and encryption of the network traffic, in a clustering environment, which we'll look at in the next section, the Hyper-V Replica broker role, and then the management tools, which are basically Hyper-V Manager, PowerShell, and if you're doing the Replica broker, which is used in clustering, the cluster management tools. So that's all fine. Let's go take a look at it. So first of all, I've got two standalone servers here. I've got HV3 and HV4. And what I'm going to do is configure one of these VMs to replicate from HV3 to HV4. We're going to take this guy here, server 2, and configure him to replica to the other server. So the first step I've got to do is actually enable replication. So we go
and that's what on the host?
On the host, yep. Yeah. So under Hyper-V settings, you can do this with a couple of PowerShell commands. Enable as a replica server. We're going to use HTTP with Kerberos because I'm all in the same domain here. And I'm going to say a replica from any authenticated server and put it in C:\replica. And we're just going to hit OK on that. And here's the little message box that can kind of tricks everybody. Make sure you turn the firewall rule on. It's not doing it for you. It's reminding you to do it. So we'll do that in just a second. I'll do the same thing on the other replica server. So open up Hyper-V Manager, and we'll go Hyper-V Settings, Replication Configuration, and we'll just sort of mirror that. Now, if I was a service provider, I might choose certificates and put a certificate in there. Now we're going to go turn on the requisite firewall rules. So for that, we're just going to go wf.msc. We'll be doing this on both servers. Inbound rules. And we kind of scroll down a little bit here. You'll see Hyper-V Replica Listener. So there's two rules right here. There's an HTTP and an HTTPS listener. We're just going to enable both of those. And we'll do the same thing over here. Now, you don't need to do this in every single server. You can do this using group policy. So, I just think it's fun to enable firewall rules. I don't get out much. So those are turned on. Now, the reason I'm doing it on both, by the way, is because I want to be able to reverse replication. You only need to turn this on the server you're replicating to.
The recipient.
Right.
Okay.
But if I want to, at some point go, let's reverse the direction of replication, I need to make sure that the corresponding rule is in place as well. So we're going to go ahead and right-click this VM and just enable replication. I'm going to hit Next. Replica server is going to be HV4. It's going to go verify it can actually talk to that server, verify that Kerberos is intact, verify the port's open. Choose the VHDs I'm going to replicate. How often do I want to replicate? We're going to do this every 30 seconds. I want to maintain hourly recovery points for 24 hours. So I can choose if I need to fail over to the replica, I can now go. I can basically choose an hour that I want to, a particular hour that I want to go back to. We'll send the initial copy over the network. We can do it to a media. If we do it to media, this is, let's say I'm replicating a 400 gig VM to a service provider. I might replicate to a hard drive and say, here, load this. I don't want to send this over the network.
Send it over, yep.
And we'll do it immediately. And you'll see this replica begin in the background. This will take a couple of minutes to complete.
Now I wanted to touch on the replication frequencies here. In your example you did 30 seconds, and there's actually 3 different replication options available. So 5 minutes is what we originally came out with our first release, but we had some customers saying, hey, you know what, 5 minutes of potential data loss is too much. I need more frequent replication. So then we provided the option for a 30-second replication. Now at the same time, we also have some customers that live in kind of remote locations where internet cost is expensive, or they don't want these regular spikes every 5 minutes with network traffic. So we provide a third option as well, replicate every 15 minutes. So keep those 3 values in mind. They're probably going to appear on the exam. 30 seconds, 5 minutes, 15 minutes are your different replication frequencies.
And so you can see this from the screen here right now. The replica's sending. It's 34. You can see kind of chugging along with percentage-wise. We're going to leave this running in the background. We're going to come back to it in a little while and look at some other elements of it. And so you can see right now the health, the status, it's in progress, everything's normal, and we'll be able to view the health of this once it's all finished and see, you know, is it current, is it up to date, what are the statuses on it. So these settings right here that we're looking at are essentially the configuration settings that I just put in as we created the replica. The additional one on the bottom, which is called Failover TCP/IP settings. What if you're replicating to a data center that's got a different physical subnet and you don't, you know, for example, a different DNS server and you don't have network virtualization in place? Well, one of the neat things you can do when a server is configured for replication is under the network adapters, you can configure Failover TCP/IP. Okay, and so what this allows you to do is to put in an alternate TCP/IP configuration that only becomes valid when the replica is started. So let's say, you know, you're currently on the 10 subnet, you're replicating to a host that's on the 11 subnet using a different DNS server, different default gateway. When the replica is started, the new IP information is actually injected in the VM so that it can be valid on that network when it boots up. So very important thing, you know, if you, and again, talking about scenarios where, you know, you conduct a replica, you boot the VM, but you can't ping it. Why not? Different subnet, you didn't do the replica TCP/IP configuration. In terms of checking and verifying replication health, it will be normal if less than 20% of the replication cycles are missed. If more than 20% are missed, or you've missed the last hour, or there's no reverse replication, or something's believed to have gone wrong, it goes to a warning state. And if it's not replicating, it goes to a critical state. So it's very easy to identify if everything is healthy or not. Also, you know, notice that, you know, normal isn't 100% replica all the time. There's an acceptable level of failure within replica where it's still considered good.
And I mean, what could be an example of why it cannot do this replication?
You know, if you're in a WAN scenario, a saturated link, or a link went down, or something of that nature.
So it could be a good way to kind of troubleshoot. Best practice here. Definitely look at the network as kind of your primary thing with replication.
Absolutely. So there's 2 ways you can do failover. There's test failover and planned failover. With a test failover, it's non-disruptive. It just verifies that it can do the failover. It doesn't actually take anything offline. The planned failover will perform a number of steps. It will, first of all, requires the source virtual machine be powered off. Okay, so you got to shut down the source virtual machine. You go to the replica site, you do a planned failover, it powers on that virtual machine, injects the network information, and then reverses the direction of replication automatically. So any changes you hear automatically go back to the original. So it completely flips the direction of replication around. That's what a planned failover does. A failover is an unplanned failover where the source, the original VM, is not available, and that simply brings the VM online, injects the new IP information, but it doesn't reverse replication because it assumes that one's gone. And it doesn't power off or do anything with that other VM because it assumes it's gone. So you would only then reverse the replication manually once the original site's recovered, get everything synced up again, then maybe do a planned failover to get it back. And you can see there's some other available actions: pause, view, extend, things of that nature. Let's go take a quick look back and see if replication's finished. It is. So we can go into replication, and we can see where we can do planned failover. We can view the health, which we can see when the last replication was, the amount of data that's moved back and forth, the average latency, how many errors, and then we've done 4 replication cycles already because we're doing them every 15 seconds, or sorry, every 5 seconds. And then I want to make one little adjustment over here. because I didn't actually, this is the brand new server we installed earlier today. I just need to make my external network adapter. Make sure I get on the right interface here.
Now, while Corey does configure that, I do want to kind of quickly talk about the two different types of replication options and the biggest limitation around Hyper-V Replica. Now, generally when you're thinking about storage replication, you have what's called synchronous or asynchronous replication. With synchronous replication, which is what Hyper-V Replica does not use, we actually make sure that transactions are committed at both sites before they're committed. And so basically at site 1, you'll perform an action, you'll write to the VM, it will send the copy of those changes to site 2, but then it has to wait for an acknowledgement to come back to site 1 saying, hey, this process is complete, the replication has happened, and you have 2 sites in sync. Now, the advantage of that is you don't lose any data. Zero data loss with this solution, because it's not committed until both sides see the same data. The downside of this is performance, because as you're making a transaction on site 1, you need to send the acknowledgement to the second site, wait for it to come back before it's committed. And so this can actually limit the distance between your different sites. Now, asynchronous replication, which is what Hyper-V Replica uses, has the benefit that there's no distance limitations. Everything happens on the first site, gets pushed over to the second site at these regular intervals. The downside of this, of course, though, is you could potentially lose data. If you're replicating, let's say, every 15 minutes, you have a crash 10 minutes after the last replication, there is some possible data loss. So kind of, consider that in mind as you are looking at this. But don't forget, it's free, it's an inbox solution.
Absolutely.
And people say, hey, this only replicates VMs. Don't forget, you can put anything you want inside that VM. So as long as you're running in a fully virtualized environment, you can go replicate other components in your data center.
Absolutely.
Now, we should still be cautious about replicated things like domain controllers, SQL databases, because similar to the checkpoints in the snapshot conversation, you still need to think about synchronization if you're restoring something from a state that could be 15 minutes old.
I have a company I know that uses this for offsite replica of data files.
Okay.
They just throw them all in the VM and they replicate it to an offsite location.
Perfect.
And it just takes care of it for them. They're just using the VM as a container for data. So this is I'm going to do a little planned failover here. So we're just going to shut down this VM, which is the first requirement for a planned failover. So get this guy shut down. It'll take just a couple of seconds. In theory, anyway. There we go. He's turned off. So now we go to HV4 and we go, all right, let's go ahead and do a planned failover. So go failover. Here's the latest recovery point. And you see the VM has now been booted. Replication directions are going to be reversed. And we are up and running on the replica. So if I look at my replication, I can now choose to reverse the replication, and we're essentially good to go. So let's do that. I'm going to go through the wizard. At this point, we're just really clicking next because it's going to remember all the settings. And we're done. So that's how you fail over to the replica copy. So that was a planned failover I did there. And you can see it's sending the replica back and getting everything synced up again. So that's how you do it. It's very simple, very straightforward, very easy to do. All right, so that pretty much takes us up to our clustering module.
That's right. So we're going to take a quick break. We'll be back in 10 minutes, and then we'll be starting our final module of the day, implementing failover clustering with Hyper-V. Welcome back to Server Virtualization Jumpstart. End of day one, coming to our final module.
You make the title sound exciting.
I do. You got to have a lot of energy behind it.
Well, I understand you're going to talk about quorum soon.
Yeah, we're going to do a little bit of cluster talk on this section here.
I may be dozing down there.
Okay. We'll try to keep it a little more engaging on these basics of quorum.
We would have started, for those of you that are watching at home, we would have started 30 seconds ago, but both he and I completely forgot to plug our cables in here, so we weren't plugged into the matrix.
And we weren't highly available either. Usually one of them should be plugged in, right?
Oh, God.
Oh, there's a cluster joke. Okay.
Oh, Lord.
Well, we'll move on from here, and what we're going to be doing as part of this module is really looking at our availability solutions that we're providing, focusing on failover clustering.
Wait, does that mean you're the redundant node?
Oh, got me. And as part of this, we're going to go kind of end-to-end, look at the different types of virtualization clusters. So we're going to start off by deploying a basic cluster, look at a scale-out file server cluster, look at a Hyper-V cluster, and then look at some optimization around them. So I'm actually going to kick it off, first of all, by jumping straight to a demo on my system, and I'm going to go build you a failover cluster. Now, what we're looking at here is Failover Cluster Manager. And this is basically our Windows Server cluster management utility. Now, when we start to talk about Virtual Machine Manager, you'll see that we have most of these capabilities also available in VMware. So within Failover Cluster Manager, the very first thing that we always do when we build a cluster is we want to make sure it's going to work. And we do this using our built-in best practice analyzer. Now, a little earlier, we mentioned there's a Hyper-V at best practice analyzer just for Hyper-V. This is the one that's used for clustering. And essentially, this could be run before you build the cluster, during cluster creation, or even afterwards. And this is actually required for support as well. So if you're going to go run a cluster in production, you're going to want to go and hit Validator Configuration to ensure that it's supported.
Now, as a guy that's built plenty of clusters in production, this thing is invaluable. It really is. Because not only from the standpoint of before you build a cluster, but if your cluster is having an issue,
it's a troubleshooting
first thing you
tool,
do
right?
is run validation. And it's going to go through and test everything, like every function a cluster would ever need to do to be able to do it. And tell you what's failing and what's not failing.
So great utility here. And you know, I've personally used this when I've just had trouble using my cluster in my office. You know, I run this validation and it will tell you things such as, hey, a network cable's unplugged at this port. And sure enough, I've actually had that problem. Somehow a network cable fell out.
I'm curious as to why you have a cluster in your office.
Got a cluster everywhere. I'm Mr. Cluster Guy.
I've got fans and fridges, not clusters.
Way more fun. So what we're looking at here is, first of all, specify what nodes we're going to test. Now, I'm just going to go select a subset of tests here, just for the sake of the demo. We've already gone and run one of these tests ahead of time, and we'll take a quick look through that while this is running.
Now, the other reason, by the way, he's selecting only some of those is because the storage test takes a while.
It can. Essentially, as we're going through this test, we want to guarantee every component works. So this means we test every disk against every node. So as you gradually start to scale up and have 64 node clusters with dozens of disks, it can take a while. Now, in fairness, in the 2012 R2 release, we optimized that algorithm a lot, so it's 3 to 5 times faster than our previous releases. Nevertheless, it can still take a while.
Yes,
so
3 to 5 times faster than 30 minutes is still quite a while.
Absolutely.
And I've had some complex clusters I've built where it's been 30 minutes of validation as it tested every single possible combination, but it's worth it. It really is.
So here's just a quick example where we just looked at the Hyper-V configuration settings and everything passed. But let's take a look at a report we did a little earlier that actually has some warnings and kind of understand what's happening here. Now, first type of configuration that we look at is the Hyper-V configuration. Now, these set of tests are only going to run if the Hyper-V role is enabled on at least one of the nodes. Basically, it's going to go look at all the servers, make sure that Hyper-V is enabled. If it's a guest cluster, meaning it's a virtual machine, it's going to check whether you have the correct virtual fiber channel adapters set. So they're going to take a look at the various resource pools that the cluster's using, trying to make sure we have consistency across naming, sizing, things like that. So one common problem that we used to see was people would go and run a variation on host 1, call it switch 1. They would then go move that VM over to host 2 on switch 2. Then trying to make sure we have VM doesn't understand switch 2. It only understands I need to access through switch 1. So that's just kind of an example of the best practices that we're going to validate there.
In 2012 R2, we've got resource pools that can help with that.
Absolutely. Yep. So we do our resource pool compatibility as well. So we're going to take a look under inventory. This isn't so much of a functional test. This is really designed as a tool to help enhance your ability to go and really understand what's running in your environment. So this really came as a request from some of our compliance customers, people working with credit card information, financial data, legal documents, government information, medical records, because they often have to inventory their actual hardware, make sure that it's compliant through Sarbanes-Oxley, all those other different types of, PCI, all those different types of requirements to have this type of sensitive data. Now, the nice thing about this as well is anytime you perform an action on a cluster like add a new node, create a resource, we go and create another report for you. So we're always going to keep track, always going to inventory it. Now under networking, it looks like I have some problems here. We actually have some failures. And what this would mean is this particular cluster wouldn't be supported. So if I go and drill down into my actual test, we get information about the actual IP address. But here we go, is we have some problem with our actual network interfaces here. They do not have matching IP address suffixes, which means that they're not going to be able to communicate correctly.
And what you mean by that is they're on the different subnets.
Correct.
Okay.
They are on different subnets, so they cannot go speak to each other. So this is something that we want to avoid before this cluster goes out in production.
I've never heard anyone call it a suffix before.
There you go. Use that other terminology here. Then some of the other tests we look at are things such as patches, making sure that you have consistent patches across all of the nodes. Now, a best practice, but not a requirement, is having consistency across these different servers. And the reason for that is so that the VM should behave and operate the same regardless of what host it's on. You wouldn't want to lose a lot of hours kind of troubleshooting an inconsistent behavior of a VM due to some type of difference in the host configuration. So again, while it's not required, it's recommended to have some consistency across the host, both in the hardware and in the software level. So let's go ahead and assume that we've gone and run this full validation test, everything's supported. We can actually create a cluster just with one button. We say, sorry, just one wizard here. We basically say, what are the nodes? So we already entered that when we tested it. And we say, what is the name of the cluster? So we'll call this our Jumpstart cluster. How is our client going to connect to it? Well, I'm actually using DHCP in my environment already, so we're just going to give it a DHCP IP address.
I have a question.
Yeah.
The little checkbox on the bottom, what does that say?
This says add all eligible storage to the cluster.
Geez. And you know, I seem to remember something about that maybe we'll want to kind of address real quick.
Yeah, good point here. So what exactly does add all eligible storage mean? Basically, what we are doing here is we're going to go and look at every node, figure out what disks it has access to, generally shared storage disks, so things such as iSCSI, SMB, serial attached SCSI, or fiber channel. And if we see those consistent shared disks across multiple nodes, we assume that you've masked them and prepared them to be clustered. And so if we keep this enabled, we're going to automatically add all that storage. If we disable it, we can go and manually add the storage later. In this case, I prepared about 7 different disks we're going to use, so we'll go ahead and use the storage. What it's now going to do is check that the computer objects are valid in Active Directory, making sure that I have a unique name, making sure that the DHCP IP address is free, and it should be because we already requested that from our DHCP server. Then it's going to actually go and build our cluster for us, creating networks between the different nodes, using that storage, making that storage cluster managed storage, and then going and basically doing some communication testing, adding some drivers through the file system stack, and basically making these nodes be able to communicate with each other. Now we'll give this a few minutes. In the meantime, we'll jump back to the presentation, let our cluster form in the background, and we'll take it from there later.
All right. So moving on, so there you kind of see the process of building the cluster out, which, as you can see, is pretty straightforward. It's come a long way from the olden days of an engineering degree and certified configurations and whatnot. You can now, while you shouldn't, you can mix and match different pieces of hardware, and as long as all the tests pass, you're good to go.
It's going to be supported.
Now, with so first of all, clustering and Hyper-V go hand in hand. You don't build Hyper-V servers without clusters to back them, because the availability requirements go up and up and up as you add more and more VMs to Hyper-V hosts. So if you're going to do Hyper-V, you're going to do virtualization, you have to be able to do clustering, you have to understand clustering. There are 2 fundamental types of clusters that you've got to be familiar with. One is what Simon's building right now, which is a Hyper-V host cluster. So it's a cluster consisting of more than one Hyper-V server brought together with some element of shared storage. Now, the other type of cluster is an SMB 3.0 scale-out file server cluster. Hyper-V is optimized to work on SMB file shares. And so if you're going to have a file server act as the shared storage, and if you kind of sort of step this back for a second and just think about it a little bit. If you're going to have what Simon's building right now. So what's the storage in your cluster? iSCSI?
Yep, iSCSI.
Okay. So what you've had to do is attach essentially iSCSI storage to all 4 of your Hyper-V servers.
Correct.
Right?
Start the initiator, point to it, accept it from the initiator.
Yep.
Kind of a handoff process.
Exactly.
Yeah.
And if you were doing this on Fiber Channel, you'd have a similar sort of conceptual process. If you want to add a 5th node, you've got to go into your storage, and you've got to plumb your storage, attach your storage to that 5th node, bring it in. If you use an SMB file share, you don't have to do any work with storage to add another node. All you've got to do is add the node. Because the file share is already there, and there's no one-to-one mapping between the file share and the host, other than just they're on Ethernet together. They don't even have to be technically on the same subnet. They're on TCP/IP and Ethernet together. You can add another node, a 6th node, a 7th node, and they can just use that shared storage. That whole step of mapping storage vanishes. You don't have to do it anymore. So that introduces the idea of an SMB scale-out file server as the storage point, which is another type of cluster. So we talked about the cluster-in-a-box stuff earlier. That's where that fits into the picture, where you can go in now and create a cluster. The cluster consists of a storage space for shared storage, and then you're presenting file server endpoints. So what I'm going to do is kind of jump into one of those that I've previously created and kind of show you what that looks like. So you've done the wizard. In my case, the wizard's already done and the cluster's is up and running. So I'm using it in production for the demos that I'm running. So here I am in Failover Cluster Manager. I'm getting to Failover Cluster Manager on one of these nodes.
Now, while that launches, Corey, you've been running data centers for 10, 15 years. What storage do you use today?
Today I use a mix of Fiber Channel Direct Attach and Scale-Out File Server.
So you are really implementing this real-world production systems. Is production ready today?
Absolutely. So we use our Hyper-V servers run on Scale-Out File Servers. Period. We don't run anything but Ethernet to our Hyper-V servers.
And would you invest in another storage technology in the future, or you're at least for now that's going to be the?
Well, ask me in the future when I know what my options are.
Theoretical question, maybe.
Yeah. But our file servers are a mix of cluster-in-a-box and traditional Fiber Channel. So just depending on, we're moving towards this cluster-in-a-box model of storage appliances because they're cheaper and easier to manage, and it's easier to just add little blocks like that.
Okay.
So what I've got here is a scale-out file server node. So let me grab the Failover Cluster Manager. I started on the wrong node earlier, so apologize for that. And what I have is the exact same type of cluster, except this is a 2-node cluster. This is a cluster in a box. So I've got a single 2U enclosure consisting of 2 nodes. And then for storage, I have storage spaces providing the storage. And so you can see I've got a number of disks that are available to me. And then these are presented through storage pools, which are generated through the storage spaces engine. You can see the virtual disks, and you can see the physical disks that back it. In order to present a scale-out file server as a cluster object, all I do is I create a file server role. So I've got SOFS01 here. We're going to do another file server. So just check file server type. It's going to be a scale-out file server. Name, SOFS02. It's all DHCP. And we're done. So I've just made a file server object on the network. What I would now do is add shares to that file server. So I come in here, right-click, add file share. Now, this by the way, little kind of behind-the-scenes tip here. When you go add file share, you get that little error. It's got to register the name in DNS. If it doesn't, and if you kind of go try to add the file share too quick, it just hasn't registered in DNS. And the trick to that is just run this command. So I'm going to go to administrative PowerShell prompt and just do a flush DNS. So an ipconfig flush DNS just to flush my local cache. And at that point, I should be able to refresh this and add a file share. There we go. So little sort of behind the scenes sort of tip for that. And so this is going to run through now my standard create a file share wizard. And what I'm going to do is create an application file share. Okay? And these settings you pick here are just going to just defining defaults that are going to be applied later. So there's no real meaning to applications. What makes it application is the settings I'm going to apply later. So I'm going to put this file share on cluster shared volume 1. I'm going to call it TSOF02 cluster shared volume 1. We're going to call it VM2, VM store 2, just to give it a name.
Now, I noticed here that you selected C cluster storage. Now, just for some context here, C cluster storage is actually using cluster shared volumes, this distributed access file system. So important to know with the scale-out file servers, we do have this dependency on cluster shared volumes.
Absolutely.
So just an important note there.
And so because I selected a highly available file server, it defaults to enabling continuous availability. Hit next. It's kind of jumping a little bit on me here with the RDP connection. And now we're at the permissions page. Now, this is an important step, right? So if a Hyper-V server is going to use this file share, you have to grant permission to the Hyper-V computer account. So what I'm going to do is customize permissions, and you would ordinarily use groups to do this. I'm going to just add the machine directly. So I've got 2 Hyper-V servers in here, HV1, CIB, computer objects. So I've got HV1 and I've got HV2. So I'm going to add both of those with full control. HV2, full control. Hit OK on that. And so this is essentially what I need to do to the permissions on the file share. Now, you might think this will get a little bit unwieldy to manage. Well, first of all, you would never generally add individual computer accounts. You put them in a group, you add the group, right? Secondly, if you choose to manage this with VMM, which you're going to be showing yesterday, VMM will take care of doing all the permissions for you. So if you decide to assign SMB storage to a Hyper-V host as one of the storage options it can use, SCVMM will take care of adding all the requisite permissions for you. There's one other thing you have to do that I'll show you here in just a second. So next on that, hit create, and this is going to go ahead and create the file share. So now what I've got is SOFS02, VM store 2, and I've now got a folder on the network where I can put VMs, right? And that's a scale-out file server. Now what that means is, because it's a scale-out file server, both nodes are active on this at the exact same time. And if one of the nodes goes down, the disk I/O can transparently move to the other node without any perceived downtime.
So this basically means a node that was hosting that access for that VM can fail.
Yep.
And that Hyper-V could continue VM could continue to run.
Right. It will detect the failure and just transparently move to the other node instantly.
So this is essentially a way to get high availability for your storage access.
Correct. It's the exact
VMs.
same conceptual stuff as you get with, for example, fiber channel, where you run multiple fiber channel cables from the SAN to your switch, from the switch to your hosts, and if one of those routes goes down, the HBA and the storage adapter know how to just dynamically reroute on the other available paths. Hyper-V and Windows know how to do that over Ethernet now. So if you have 2 Ethernet cables or 2 paths into the same storage endpoint, and one of them goes down, it knows how to dynamically reroute without any downtime. And the final thing you've got to consider in here is, because you're using these computer accounts, they have to be enabled for delegation. So all your Hyper-V servers have this requirement of delegation being enabled. So to do that, I'm just going to open the Active Directory Administrative Center, which is the new users and computers. Been around for a couple of versions now. Let's do a quick search for, let's do HV1. Let's do CIB. HV1, and just open the properties of that computer account, and we've got this delegation tab down here. So click on delegation, and this is set to trust the computer for delegation. This is not the default. When you create a computer account for the first time, it'll be set to not trust for delegation. So when you create the Hyper-V servers, you've got to go in and set this AD attribute and reboot it. Once that's done, you're good to go. You can start assigning the computer accounts access to file shares, which is what allows VMs running on those computers, or those Hyper-V servers, to actually use those file shares. So that's the basics of a scale-out file server for Hyper-V. If you want to get more in depth on things like the multipath, things on how the SMB witness works, and the the real details on the file server component, you have a look at some of those other Jumpstart sessions that cover that topic specifically. Because I could literally spend 3 hours on the file server. It's that different. There's that much there. There's that much to look at, and looking at how we do failover, how we do multipath, how it does load balancing and teaming, to really make this a powerful, powerful tool. But in terms of virtualization in general, this is the process for building that scale-out file server, same as you just did. Build a file server object, add a file share to it, make sure the computer accounts have access to the file share, make sure the computer accounts have delegation. You're basically good to go.
Sounds good. Well, you spend 3 hours on that, I'll spend 3 hours on Quorum. And we got a whole extra day for everyone.
Oh, dear Lord. You don't want that, folks. Trust me. I don't know who'd bore him to death more, you or me. So that's essentially, we talk about using a virtual machine on an SMB3 shared folder. This is essentially what we've just talked about here. Hyper-V administrators, computer account, and Hyper-V host, and then the cluster computer account all need the right level of permissions. For a scale-out file server, there's 2 modes for the file server: scale-out and general cluster. A little kind of, I guess, production tip. Do we like those?
Yeah, production tips.
Production
Sounds
tips.
like a good way to word it. Yeah.
This is going to be really weird. Okay, so you will probably discover this at some point on your own, and you're going to be confused, and you're going to go, something's broken. I did the first time this happened to me. So I've got this VM store 2. Okay, this is a scale-out file server designed explicitly for application data, not for Word documents and PowerPoint documents. And people think, well, it's a scale-out, highly available file server. I'm going to put all my, user profiles on there. Do not do that. It will.
Great point.
It will suck. And here's why. There is no caching at all on this file share, right? No caching at all. So the result of that is when you dump data onto this file share, it's going to be extremely slow. So you sit there and go, I got to, the first time this happened to me, I've got a 10 gig Ethernet connection going to this file server, and I'm uploading data at 50 megasecond. I was sitting there going, okay, what's broken? And what I eventually learned was that because these are designed for application data, there's no write back cache. As a result of that, every transaction has to fully commit before it moves on to the next one. So the result is very slow in end-to-end performance. You run a VM on that same file share, copy data into the VM, it goes at 10 gig a second. Because it's designed for the applications that are running to handle the write caching and all those elements that are involved. So the trick to this is if you're building an implementation like this and you're planning on putting a lot of VHDs on it, little kind of side trick to get the data onto the share a whole lot quicker is you can actually make a second file server on this exact same folder with a different share that's not a scale-out file server, that's a traditional file server, and use that as a way to upload data. So you can upload data through the traditional file share to the exact same end storage location, but then when you create the VMs, you create them on the scale-out file server where they're going to run as fast as they possibly can. So a little sort of a,
good best practice,
behind the scenes, I don't even know if I call it a best practice, but sort of behind the scenes tip for if you're building this and want to populate it with a lot of data really, really quickly. Now that being said, the file server with R2 now introduces a write-back cache on a scale-out file server to vastly improve write performance in general. Not really a topic for this session here, but certainly take a look at that if you're interested in this whole new generation of file servers. So that, here we go. So virtual hard disk. So we already kind of addressed this a little bit earlier, but when you're building out clusters and you're looking at doing guest clustering, using virtual hard disk sharing as shared storage is a viable option. I'm not going to cover that again. We've covered that already. But certainly using a VHD, if you're going to use shared VHDX as a method for doing guest clustering, the scale-out file server that I just showed you is what you have to put that shared VHDX on. You can't just throw it on a local disk. It's got to be on a highly available scale-out file server. That's a requirement for using shared VHDX.
All right, so we're going to go in and talk a little more about failover clustering itself, kind of the core concepts, core functionality of how it works. So with this release, 2012 and 2012 R2, we support 64 node clusters, up to 8,000 VMs in those clusters. So these include built-in hardware and software validation tools. Of course, we support the shared storage, but I kind of just want to spend a quick minute to talk about exactly how clusters work. Now, first of all, the key requirement is you need redundancy everywhere. So redundant servers, redundant network cards, redundant paths to storage, and then redundant applications supporting it throughout the infrastructure, like redundant Active Directory services. And again, just to eliminate that single point of failure. Now, next key component that we have here is that all of the hosts that are part of the cluster, they're constantly communicating with each other. They always want to understand what is the state of every other node in the cluster. And the reason why we do this is to make sure that if one server crashes and we can't access it anymore, the other nodes in the cluster know exactly what was running on it. So if I had VM1 running on node 1, node 1 crashes, we want VM1 to start somewhere else. And so the way we kind of keep this consistency shared across all of our different nodes in the cluster is actually through the registry. So if you go into a cluster, and we'll switch over to our demo here, I'll show you our cluster that we've already created. Switch over to our cluster here, click Finish. Now we've got our cluster up and running. What we're essentially doing for each of these 4 different nodes in the cluster is replicating our registry. Now, basically, what we store in the registry is every single role in the cluster, the properties for the role, and the state of that role. So, for example, if we have a virtual machine in our cluster, we're going to store the name of the VM, whether it's online, offline, pending, the resources, and basically the properties of those resources. So, names, what they're dependent on, things like that. Now, as soon as one of those resources changes on one node, let's say I create a new VM called VM2, we're going to instantly replicate that information to every other node in the cluster so that we make sure that we have that consistent view. So let's actually go ahead now and create a new virtual machine. Now, what you're going to notice as we do this through Failover Cluster Manager is a pretty consistent experience to doing this through Hyper-V Manager. What we'll actually do is go and invoke the new virtual machine wizard from Hyper-V Manager. So you actually have the exact same steps, exact same questions as you go and configure this VM. Now, once this is up and running, we'll walk through this in a second. Kind of the final piece that makes clustering working is our health detection model. Now, what we're basically doing is each node is constantly pinging every other node in the cluster, making sure it's online through what we call heartbeats. If one of those nodes doesn't respond after a certain number of health checks, we consider it down, we take failover recovery actions, and basically what that means is we figure out what that bad node was running, such as VM1 and VM2, and then we go start them else somewhere in the cluster. And this is what protects us from this unplanned downtime. And again, different from live migration where you need both nodes to participate, unplanned downtime, crash happens, we detect the crash, we restart it somewhere else.
From the standpoint of the operating system in the VM, someone yanked the power cord.
Exactly.
And that's the same on all implementations of virtualization. It's the same on VMware, same on Citrix, for example. That if you do have that type of a downtime, that's the way that it fails over.
Absolutely, yep. So let's go back to the demo here, and we'll go through this VM creation process. Same type of information you saw before when we looked at this before with Corey. And we'll call this Jumpstart VM 3. Now, here's kind of one of the tricks here. When you're going and deploying this on the cluster, you're going to want to go and actually deploy it on our cluster shared volume disks. Now, what I actually haven't done so far is I haven't actually gone and configured those disks. So, shame on me. I forgot to go deploy my CSV disk. We are going to back up 1 second and go and create a CSV disk. Now, you saw when I was creating the cluster that we automatically added any new cluster disks. And so here I have 7 disks in my cluster. 6 of them are available for storage, and one of them is known as a witness disk. And we'll talk about this a little later. But essentially, what I want to do here is make these disks accessible by all of my nodes simultaneously by adding them to cluster shared storage. Now, this would be equivalent in VMware world as VMFS, the VMware file system, where we have that distributed simultaneous access. So now that they're CSV disks, we'll go ahead, create our VM, and actually go place it on that CSV disk. Now, while I walk through the wizard, can you just kind of explain what's the benefit of CSV and why did we build it as opposed to the traditional one VM, one LAN model?
Well, What CSV allows is for more than one virtual machine to access the same file system at the same time. And so essentially, the danger in having two nodes access the file system at the same time is that they can overwrite each other's data, right? And so the way that CSV works, it exposes both volumes to all the nodes in the cluster, but it designates one node as what's called the coordinator node. And any metadata activities such as create file, move file, delete file that involve the file system are done strictly through the coordinator node. And that's just a role that moves back and forth dynamically. Once you have services up and running that are just reading and writing from a file as opposed to creating files, because that's a fixed location and a known location, all the different nodes can actually read and write from those files at the same time, and VHDs are one example of that. So in the case of a scale-out file server, that's what allows it to happen. Certainly, allows more than one role on more than one server to access the file system at the same time. That's kind of a key for this whole scenario to operate properly.
Yeah, I guess one of the key goals of that as well was just to simplify SAN management as well.
Yeah.
Have fewer disks instead of having to try to have like a separate disk per VM, so that if one VM crashed and had to fail over, it wouldn't have to move the disk with
I
it.
had a very healthy debate with a SAN guy a number of years ago about should you have one massive volume on your SAN, or should you purposely carve it up into LUNs and present those LUNs individually?
Now, is this CSV or just independent of that?
In general, right? CSV included. And it was a very healthy debate. There's a lot of, arguing and some fights in the parking lot when we're all said and done. But, his point was that depending on the hardware you're using, the way that the caching on the controllers might work, you might be benefited from having multiple volumes presented. So as opposed to 20, have maybe 3 or 4, because you get more efficient caching on the controller for read and write versus one huge volume that has one cache for everything. So we kind of came to the conclusion that it depends on the hardware that you're using, what's good and what's bad. So again, it comes back to really knowing and paying attention to what you're buying to build these things out, as to what their recommended practices are for their kinds of hardware. Some controllers, the cache might be smaller and less efficient with one big volume, whereas it may support multiple caches if you have multiple volumes.
Great point. Well, let's jump back to the demo here. Now that we've gone and actually enabled our CSV disks, we go ahead and actually store our VMs on this CSV disk. Now, what you're going to see, no matter what node in the cluster, you're actually going to see a shared namespace under C, cluster storage. This gets created as soon as you go and actually create your first CSV volume. And basically what this does is, it means that a VM running on node 1 can access its data through C, cluster storage, volume 1. But if that VM is now running on node 64, guess what? It gets to use that same file path, C, cluster storage, volume 1. And so it's that consistent access point that allows us to do things such as live migration, have some more flexibility, and just really simplify the management. So let's go ahead and pick volume 1 for our Jumpstart VM. Generation 1 or Generation 2 virtual machine, so the exact same settings you get through Hyper-V Manager. Let's go and turn on dynamic memory. We could go connect it to one of our virtual switches if we desire. We'll keep it offline for now. Same options with creating a VHD now or later. Install our OS now or later. Click Finish, and this first wizard is going to wrap up, and then quickly you'll see the second wizard here, this high availability wizard. Basically what happens is, as soon as we're done creating the VM using the Hyper-V wizard, we then automatically go and add it to the cluster. If you go click the View Report button, you get again a detailed and documented set of steps for everything that's gone and happened with this new VM deployment. Click Finish. It's going to stay in the offline state. And you have the same management capabilities that you do through Hyper-V. Go click on the settings for this virtual machine. That should look pretty familiar to you. We go enable replication for the virtual machine, going through this same process. So pretty consistent look and feel here.
Absolutely. Now, because you mentioned replication, we're going to come to that in a few minutes. Replication is different on a cluster.
It is.
We've got to introduce something called the Replica broker, which will, towards the end of this module, we'll spend a second on that. So I've got, that's kind of ready to go here. But that's, if you're going to do replication and you're going to do it on a cluster, you need the broker role configured because it's got to be able to replicate regardless of the node that the actual VM is running on.
Think of it as almost a highly available replication service.
Yeah, absolutely.
Fails over between the nodes. So let's kick it back to you, and let's continue going through these best practices we have here.
All right, so in terms of continuing along, so we just mentioned the kind of the general description of what the cluster is and how it works. When you have VMs on a cluster, it's not as simple as throwing everything there and leaving it. You've got to start thinking about the VM load you have, how many cluster nodes you have, where you want those individual VMs to run. So for example, the wizard you just went through used the C cluster shared volume wizard. As we've talked about with SMB file shares, you could just point that at SMB file share.
That's right.
The configuration of the VM, everything will be created up there. So you could essentially do a cluster with no local storage, correct?
Correct.
So that if you look at your cluster, under your storage node, it'd be empty. There'd be no disks.
That's right.
And so when you're creating a cluster, that's new, and that's a new capability. That a storage-less cluster that leverages SMB storage that's managed separately. The virtual machine startup priority. Right? If you have a cluster that goes down, you want to make sure that you bring up, for example, domain controllers first. So it allows you to configure things like which VMs come up first, the priority delays between them, so that you don't have a boot storm that occurs. And this would be more important for infrastructure clusters as well. And then finally, preferred owners. Right? And this is pretty important as you start to balance things out. That if you have multiple hosts, you've got 4 hosts in your cluster. Maybe I've got 16 total infrastructure VMs. I want to put 4 on each cluster to get maximum CPU and RAM performance. I don't want to load everything on one. And there's this rule which is n+1 availability, where you've always got to make sure you maintain enough extra space so that you can absorb 1 node's worth of failures or 2 nodes worth of failures. So as an example, I've had folks go in and build a cluster, but overcommit resources. So, I build a cluster and I've got 64 gigs of RAM in each node, but I spin up 72 gigs of VMs. Well, if one node fails, there's not enough memory to bring everything back up again. So, maybe you look at a scenario where I've got, 72 gigs worth of VMs, but I've got 3 64 node clusters. Now I've got enough extra space that I can absorb those VMs if they fail. And it's all really just good planning, to be quite honest. And how many nodes of failure do you want to tolerate? Maybe you want to tolerate 3 nodes of failure in your cluster and still be able to run everything. The more nodes you add, the less the cost of the cluster becomes, because you have less overhead. 2-node cluster, it's really 50%. 3-node, it's 1/3. 4, it's 25%.
Great points. Great points.
And then with the preferred owners, there's a concept called anti-infinity, which you had mentioned earlier. So you want to just kind of talk about that for a couple of minutes.
Yeah, I do. So anti-affinity is basically enforcing VMs with the same type of properties to live on different hosts to avoid that single point of failure. So again, the 2 most common applications we see on this is if you have 2 virtualized domain controllers or other types of infrastructure servers. You don't want them sitting on a single host. You lose that host, you lose your whole infrastructure. Similarly with a guest cluster, right? I have 4 virtual machine nodes. They're all running a SQL database. I want to make sure they're distributed as well, because again, I lose that one host, I'm going to lose my entire guest cluster. So anti-affinity through Failover Cluster Manager is actually a property you configure with PowerShell. When you go and use this through Virtual Machine Manager, there's a nice GUI interface for availability sets. We'll take a look at that tomorrow. And essentially, it's just saying we need to go spread out these VMs across our different hosts. Now, going back to some other properties, I'm actually going to jump over to my demo again here. I'm going to show you quickly some of our VM prioritization. Now, we want to think about prioritization as our ability to go and rank VMs based on importance. And so configuring that is pretty straightforward. Where is it? We go down to our change startup priority, high, medium, low, and no auto start. And we'll cover no auto start in a minute. But essentially, this is saying when we go and start our VMs, or we start our entire cluster and lots of VMs are starting simultaneously, this is going to prioritize which come online first, second, and last. So why would you want to do this? Well, a good example is you have infrastructure servers that need to come online first. They're going to be your high priority. Then critical line of business might be medium. Then other supporting services might be low priority. And then for your human resources department, let's not even try to start it. Let's let our entire infrastructure come online, stay healthy, and only then will we go and start those unimportant VMs. And so that was that 4th option, no auto start.
A pretty typical setup for that, by the way, is domain controllers are high, databases that things rely on to start are medium, and when you get things like link, Exchange, SharePoint that use the data, or applicant that use the databases, they go to low, and then other stuff like management and monitoring kind of goes to no auto start. You just sort of bring those up. Once that's the way we generally operate. Domain controllers, databases, applications, and then what we call the surrounding components, which are the management and monitoring components, where they don't have to be up for things to be up. Well, obviously, we don't know how healthy things are, but they, once everything else is up and we're no good, well, then we can bring those up manually.
Great. And another good example is multi-tiered applications. You have the back-end database needs to come online before the front-end website, something like that. But beyond just doing startup and making sure they start up in order, we also honor this when you do things such as maintenance on a host. If you say, hey, I need to go take everything offline on my host, I want to go and drain all of my VMs, what we can actually do is we switch over to this interface here. So we could take a look at the nodes in our cluster. We could select pause a node and drain roles. And this will basically go and live migrate our VMs over to different hosts. And it will do that in a prioritized fashion. Now in this case, I only have a single VM. That's the one that's going to go live migrate here. And actually, I never even turned it online, so it's going to do an offline failover. But essentially, this helps you prioritize evacuating nodes as well. For example, maybe you have some type of virus, you got to quickly get rid of things, live migrate high importance.
Can you maybe address patching of the cluster?
Ooh, patching, that's a good question. A lot of people ask about, what are these best practices around patching? So first off the top of my head, when you look at kind of the default patching policies in Windows Server, first thing a lot of people get themselves into trouble with this is the default patching time is actually set to 3 a.m. on every node. Now, it will be staggered slightly, and in general, you're going to want to disable automatic patching on your node, but if there's a critical patch that comes through, a group policy that's going to force those cluster nodes to install the patch, every node installs it at 3 a.m., and then reboots, you've actually taken down your whole cluster. So first, you're going to want to try to stagger those default times across your cluster.
And well, the thing I was going to add to that is you want to, if you're planning that, you've got to factor in time to live migrate.
Time to live migrate. Okay.
Because if it takes everything 30 minutes to live migrate to get, because you've got very large implementation, you've got to make sure that you build into the time between those cluster cycles time to live migrate all those resources off.
Great point as well. And then the other kind of interesting technology around cluster patching is a component called cluster aware updating. This is a Windows Server add-on role, and what it will basically do is go and patch any type of cluster, whether it's a physical cluster or even a guest cluster. And if it's a physical cluster, it will live migrate the VMs between the different hosts while patching the servers. If it's a guest cluster, it will do a failover within the VMs and patch those virtualized clusters. And if you have a non-Hyper-V cluster, we'll still patch that. It'll just do traditional failover as it goes and moves those applications between the different VMs, different hosts. So that's our cluster aware updating.
Now, in addition to that as well, within Virtual Machine Manager.
Stepping ahead a little bit, but absolutely, Virtual Machine Manager also has its own updating mechanism called Update Manager. And that's actually going to patch basically any type of infrastructure server that VMware manages. With the exception of vCenter servers, they use kind of a whole different patching system. But this could go patch your library servers that VMware manages, your cluster hosts. It can patch 2008 R2 cluster hosts that it manages. So basically, it's a patch management solution within VMware. Now, I get a lot of questions. Patch your library servers, right? They kind of do the same thing. And essentially, they're built on the same algorithm, which is pause a node, so put it into maintenance. This means that nothing will then move onto that node. So basically the node's locked. We then drain it, live migrate everything off. Once it's completely drained, we're going to go install the patches that are needed from a baseline, so we figure out what patches are needed. If a reboot's required, we'll reboot it. After the reboot, we're going to check that the node comes online successfully, that the patch installation code is successful, and finally, that the node can rejoin the cluster. Once that node, those 3 checks, we say patch was healthy, take it out of maintenance mode, installation can come back on, go to the next one, and basically cycle through these clusters.
Absolutely.
We say,
I think to kind of answer your question, use what you have.
Yep.
If you just have a standalone Hyper-V cluster and you don't want to use cluster aware updating, you would want to stagger everything out and maybe even do it manually. If you have cluster aware updating and you're comfortable with it, use that because it does all the work for you. If you have VMM, use that. And if you want to even go to another level of automation because, maybe there's some custom things you've got to do. That's where Orchestrator can fit in. Now, that's obviously tomorrow's work, but all those levels are available for managing the patching on the cluster.
Absolutely. And one final thing to mention about cluster-aware updating is it has what's called a self-updating mode as well. And what this basically means is the cluster can patch itself. So you don't need a separate server that's set up to do your patching. What will actually happen is you have your 4-node cluster. Cluster-aware updating will actually be a clustered resource and move between the active nodes and then manage those other nodes that it's not running on. So this basically gives you high availability throughout your patching infrastructure. Now, we actually had one customer that we spoke to. They were part of a large social media network. They have 64-node clusters. And they do regular patching, every week, every 2 weeks. And they have thousands of VMs running across them. And their story is they're just in a basic patching cycle. They say, we don't need to think about it anymore. Once a week, we kick off cluster-aware updating. It takes several days to complete. The environment's dynamic. A few days later, everything's patched, everything's moved, the entire infrastructure is healthy. So if you really want to kind of eliminate that repetitive task, patching nodes, definitely go check out these built-in tools. Now, final thing that I want to next thing I'm going to discuss as a best practice here is around starting up our VMs. Now, as we kind of mentioned earlier, one challenge that a lot of people have with starting up VMs is it takes up more resources than running a VM in production, generally speaking, right? If you have a high-end SQL database, maybe not. But if you're just running kind of a standard VM, when you boot it up, you get a big peak as the drivers are loaded, file systems loaded, connecting to the network, startup scripts, user roles, Active Directory, kind of a lot of churns going on. So you'll see a spike in CPU, and then gradually it will kind of level off. Now, a challenge that we saw with a lot of customers in our older releases was if they had a cluster that went down and they didn't have prioritization, they would say start everything up. All of the VMs would start up at once. And maybe you had a host that could usually run 10 VMs under standard workload. You're now trying to start 10 VMs at this accelerated workload. This would trigger what we call a startup storm because you're basically over-allocating resources during this startup phase. Bad thing about that, it could cause the cluster to crash.
Yeah.
Everything then fails over to the next node, which is also facing the startup storm, causes that to crash, and then we've effectively created a domino effect, take down everything. Again, that was older version, all updated, all fixed in 2012 due to things such as VM prioritization. Now, the second component around this startup and trying to avoid these startup storms is a feature called persistent mode. Now, persistent mode was something that you had to turn on. It was enabled automatically in 2012, and it was actually exposed in the GUI as a property. In 2012, R2 hid it entirely. It's on by default, and you would only turn it off by actually going through a PowerShell commandlet and purposely disabling it. And what persistent mode is going to do is it's going to automatically start your VM on the last host that it was purposely moved to. So let's say, for example, I have my 4-node cluster. I got 10 VMs on each node. Now, when a failure happens, node 1 goes down, those VMs fail over. That's not considered a planned move. That's considered a failover. Now, if gradually all of those nodes go down and we lose our entire cluster, the problem that we would have is once we start to get some nodes coming back online in the past, all of the VMs would try to go and flood those first 2 nodes that came up, triggering the startup storm, and then causing the same problem. So 2012 R2, with this concept of persistent mode, what we're basically going to do is say, once the first nodes come up, only start the VMs that should be running on there. Only start these VMs on here, these on here, these on here. And what this is essentially doing is it's making sure that the VMs are only running on the nodes you want them to run on. Now let's say, for example, only 3 of our nodes come up. One of the nodes is still offline. Well, those VMs that were waiting on this, that were persistent on this, they are going to come online eventually on a different node, but we're going to wait 2 minutes by default. Now, this 2-minute delay means, yes, your VMs won't start for 2 minutes, but it's going to give these other hosts a chance to start up, get past that startup storm, settle, and then gradually go and add a new VM. So we do recover, but this is just some built-in protection during startup to provide higher availability.
I think that stuff becomes far more important as you build bigger, more complex clusters, because it's very hard for you to manage as a person. So you let the logic and the operating system kind of take care of that for you.
Absolutely.
And
yep.
it'll, it's the learned experiences of every customer of Microsoft bundled into one package that represent, what collectively is the best thing to do to get this off the ground.
Absolutely. Now, one final setting I want to go through before our VM health monitoring is a concept of preferred owners and possible owners. The way you want to think about this is preferred owner means it's the first place choice for a host. Possible owner, a second place choice. And so we have customers that, started building clusters 5-10 years ago, have some older hardware, bought newer, better hardware, added it to their cluster, and have slightly diverse cluster nodes. Now, you might have a high-end VM that needs, 128 gigs of RAM. Yet your old host maybe only had 64. And so you need to ensure that that particular VM will only go and run on that particular node. So you do this with this concept of preferred owners. You say by default, I want my 2, 4 most powerful hosts to be first place, the preferred owners. Then if we have some others that maybe it will work on it but isn't optimal, we'll say those are possible owners, our second place choice. Now if neither the first place preferred owners, second place possible owners are available, we won't actually start that VM. We'll keep it, we'll basically make it reactive, so if we want to start it, it's available, but it's not actually going to go start on those other nodes. So this gives you some more flexibility in your placement policies as well.
So the final piece we'll look at here before we look at the replica component for clustering is something called virtual machine monitoring. And this is a feature that's built into clusters that allows the cluster to be a little more intelligent about when it chooses to fail over. So we can actually watch services running inside VMs. And if those services fail, it can take actions on the VM, on the cluster, to determine whether or not it wants to fail it over. So for example, the VM doesn't have to go down, but maybe a service on the VM goes down.
That's right.
And so it can trigger actions like restarting a service, restarting a VM, or triggering a failover on a VM to another node if it happens so often. So it's a way of taking, the cluster can look deeper into the operating system. Obviously you need Windows Server 2012 or later for this to work, but it's not just, is the operating system up, but hey, are all the services actually up? Because maybe there's a network adapter that failed or something, or maybe there's a connection to a database that failed and I've got to fail the other node for that to work. So this is built in. Last sort of big topic for today really is the idea of Hyper-V Replica. So when we left off Replica, if I can just jump back for a second here, we had done a replica from HV3 to HV4, and then we had done a failover, and we're now replicating from 4 back to 3. What I want to do now is introduce another concept of replica, which is called extended replication. This is new for R2. What extended replication enables you to do is go from you got your primary VM, replicate to your secondary, but then your secondary can now replicate to a third location. And the fundamental request from a lot of customers that drove this is, hey, I want to replicate within my data center, then I want an offsite replica, just in case we get hit by an asteroid or something. So this extended replica allows you to go to a third server with your replica. Now, in my example here, I want my replica, my third replica, to be on a cluster node. So to do that, I've got to go configure my cluster. And so what I'm going to do on my cluster is add a new role, and this is called the Hyper-V Replica Broker role right here. Hit next. Name, we're going to call this one ClusRepl, because I'm completely not creative at all. And I need to give it an IP address. We're going to go 280, I can't go 280, that'd be wrong. 234, I'm guessing, at an IP address. Hopefully that's an available IP address. This is a little demo set. I mean, not my servers, they're your colleague Rick's, they're his servers I'm borrowing. So Rick, I hope I didn't just create an issue in your network. So we hit next on that. Brought it online, hit finish. So now we've got this additional role called ClusRepl, which is a cluster object resolvable on the network that I can now use as an inbound replication point. And so, bit of luck, so this is online. Right click on it, and what you're going to see is I now have replication settings. And so these are the exact same settings that I had on the 2 hosts I did earlier. So enable this as a replica server.
Pretty consistent experience as well.
Use Kerberos. and I'm going to replicate to my cluster shared volume. All right, again, because it's a cluster, I've got to make sure that this actually comes in as a cluster object, so it's got to go on shared storage. So we'll just replicate to this folder right here. We'll hit OK on that. I've got to turn on that old firewall rule on both nodes. So we're going to do that one. So we'll quickly turn that rule on. Hyper-V replica rule. Enable that rule. Here's the other node. I'm doing this real quick for those of you that are watching me, because you've seen me do this before. So we're just doing it quickly. So those firewall rules are enabled. Now, if I go over to HV3 and do my extended replication, this is now going to be clus repl, which is the broker's name. Goes out and verifies it. We can no longer do 30 seconds. We can now only do the next increment up. So if I did my initial replica, by the way, at 5 minutes, 15 will be the next increment I could use. So that would be the only choice I have. So we're going to do 15 minutes. This will be, say, an off-site replication. Maintain the latest recovery point. Send the initial copy over the network. Start doing the replication right away. Click Finish. And away we go. So this is now sending the initial replica. And what that's doing is creating those files on the cluster shared volume. It's creating a highly available VM that's in an offline state that is a replica. The broker is going to keep the replication synchronized so that if I choose to fail over, I'm actually failing over to an already highly available VM. Right? The broker is the role that ensures that, if one of the cluster nodes goes down, because the broker is just a cluster role, it'll fail to another node, replication will continue. But that's the requirement for inbound replica to a cluster. You can see this right here through a little animation as to what actually happens, that it'll actually replicate directly into the broker role. So, live migration. Talked a bit about this already. Let's take a quick look at how we actually initiate a live migration. I've got a VM right now that's running on this Hyper-V cluster. Let me go back to my cluster manager. So initiating a live migration is done through Cluster Manager. You can see, by the way, here's the server 2 VM that is currently being inbound replicated. It's powered off right now, which is what we want. But we're going to take this DC VM and we're going to run a live migration. So we simply click Move. We've got either quick migration or live migration. We can also do a move storage. Right, so we're going to do the storage migration. Maybe to take this VM's VHDs, as we talked about earlier, move them to another LAN on the SAN. So do move, live migration, and we can do best possible node, which is going to take all those things you just talked about into consideration, what's running on each node, the load, the priority, choose the best one and put it there, or we can select manually a node. I've only got one other node, so it's only got one place to go. Hit OK on that, and away goes the live migration. You can see it's going through that process we talked about. This is the exact same process that we did for the shared. Nothing live migration, except obviously it's going a lot quicker because the VHDs are not going anywhere. It's only the memory state that's actually moving. And so that migration's done. I've now moved that VM to another node. It's on HV2.
Okay, now you mentioned this best possible node thing. I kind of want to spend a minute and explain what exactly is happening there. Now, as you go select best possible node, what we're actually doing is we're going to go and move this VM to the node that has the most free host memory. And the reason why we kind of built this algorithm into the product was based on feedback from Virtual Machine Manager. As you're going to see tomorrow, VMM has a feature called Intelligent Placement that basically allows you to prioritize the importance of your host based on does it have the most free memory, storage, networking, or CPU. And going through our customer analysis, we found over 90% of our customers say memory. Memory is my biggest constraint, probably for you in your data center, right?
Well, I actually disk I/O more than anything, to be quite honest. We've got tons of memory. It's funny how the world is kind of changing. Memory's getting cheap.
It is.
Disk, as the world moves to SSD, is becoming expensive. It used to be memory, it used to be disk was cheap.
But now you've got storage spaces, though. You've got your nice commodity JBOBs, too.
There are still eMLC SSDs involved at, $2,000 for a terabyte. So storage is not cheap. There's a lot of data center dollars in there.
Well, anyway, we were saying that we do this based on most free memory. And so rather than have our administrators think and do a constant scan, which node should I go move this to, we automatically constantly track memory utilization. You say move this to the best available node, we'll automatically move it to the node with the most free memory. And if you do a VM maintenance, place it into pause node, drain the roles, it's going to go and move those VMs to the best available node, the node with the most free memory.
So, with that, that pretty much wraps up all the content we've got for day one.
Well, that's great. I definitely wanted to go and touch on two questions that I've seen come up a few times.
Absolutely.
First one is for you, related to replication in Azure.
Okay.
So there's a few questions. First is basically, can we replicate to Azure? And secondly, what is the Windows Azure Recovery Manager?
So can you replicate to Azure? Not directly. The Windows Azure Recovery Manager is, and well, first of all, this isn't my major area of expertise, so please someone correct me if I get this wrong. You can move VMs into Azure using App Controller to keep things synchronized. The Azure Recovery Manager is a set of tools that allows you to have a replica of a VM in Azure, and then in the event of a local VM failure, use that as the recovery option for it.
Great. And then one of the new capabilities, a new Windows Azure service that we're offering with the actual built-in recovery manager, allows you actually to do site-to-site failover and basically manage it from a single location. So, the challenge that we had sometimes was customers would do DR from site A over to site B, but they might lose full access to site A. Couldn't go trigger over replication, couldn't go trigger over failover. Well, what we're able to do is use our Windows Azure and go use that as our single management interface, do full site failovers. So not down at the individual VM level, do it at the full site level. And to learn more about that feature, you could go to our Windows Azure and look at the new Windows Azure services that are available.
So I guess to one point of that question, if the question is, can you use this replica function to replicate to Azure, the answer is no. They don't expose that.
Correct. Now, our final question we're going to wrap up here at the end of the day. We've got several questions about how do I upgrade from 2012 R2 up to 2012 R2.
Good news is it's phenomenally better than the upgrade from 2008. So the first thing you want to know about doing an upgrade is that the running state of a VM is compatible. So what you can actually do is you can live migrate a VM from 2012 to 2012 R2 without the VM having to go offline. The save states are actually compatible, which is fantastic, because what that allows me to do is upgrade a cluster without having to take the VMs offline. So I can migrate all my VMs to one cluster, and actually, can you have R2 and 2012 in the same cluster at the same time?
No, you cannot.
No, you can't. So yeah, what I would have is a 2012 R2 cluster.
Right.
I would have a 2012 cluster, do a shared nothing, essentially live migration from cluster A to cluster B. So from the 2012 cluster to the R2 cluster, the VMs never go offline in that process. Now they're on the R2 cluster. Once all the VMs are there, I can retire, reinstall, reformat, whatever. I had a friend of mine used to call it, nuke and pave. That's the reformat and reinstall. And actually bring those additional nodes online in the R2 cluster. Or, for example, you could shared nothing live migrate from a 2012 cluster to an R2 host, upgrade your cluster, and then bring it from the host back to the cluster without any downtime.
So a few different options you have.
Yeah.
So within virtualization, key thing is if you're doing 2012 to 2012 R2, live migration is supported. Only up level, you cannot live migrate down level. But if you want to go from an older version, move your VMs running from 2008 R2 or earlier, two different methods you can use here. Actually, there's a few. Two methods we recommend. You can do things such as backup, restore. Can work, maybe not recommended. You might have to do some other fix-ups as part of that. The two we do recommend, though, are a export and import. So PowerShell has a series of scripts that allow you to export the configuration, import it back, assuming you're moving up level. Second thing is if you're doing this through a cluster, there's actually a built-in cluster utility. Used to be called the Cluster Migration Wizard. Now it's called the Copy Cluster Role Wizard. And that'll actually allow you to copy all the resources between the clusters. And well, actually, if we can switch over to the demo, I'll actually show you one of these quick demos here. So what I have running here is I have my 2012 R2 cluster, got my 2012 RTM cluster, not really doing much, just kind of sitting there. And down here on my new cluster, I'm going to say Copy Cluster Roles. This goes and launches the wizard. And essentially, we just go and point it to the old cluster. It's going to go validate that I have access to my old cluster nodes. It's going to go figure out what roles are currently running on that old cluster. I'll take a minute to load. And then it basically says, what can I migrate, what can I not migrate? And gives me a series of checkboxes similar to the validation reports saying this can be fully migrated, this could be partially migrated, this cannot be migrated. Kind of giving you some guidance before you actually perform this operation. So let's take a look at our VM, for example. We'll go migrate that. Well, one challenge that we have here is I got two different clusters. I may have two different virtual network names. So if we detect that the virtual network on your old cluster is not the same as your virtual network on your new cluster, we actually give you the ability to go and remap the names of your network switches. And what this will do is actually go and update the configuration file within Hyper-V, providing it with the new virtual network name so that we can make sure that it's going to be successful. Confirm the settings, copies everything over. Now, some caveats with this. First of all, this is not live, okay? This is not a live migration. VMs will be offline. Because essentially what we are doing is we are copying all of that configuration information, the settings for your VM or your file server or whatever you're migrating, to that new server. But we're not bringing it online yet. Now remember, for each of these different clustered entities, they all need an Active Directory object. That has to be unique. So what we do with the cluster migration is we basically do a clone of it. We keep the original one online, running, so it's zero downtime to your production system. You could go through this migration process, create the copy, test it, look at the migration reports, figure out what will work, what will not work. Then when you actually want to do this in production, you'll do the copy, you offline the old VM, online the new VM. Now, one caveat, this is assuming that you're accessing the same VHD, you do have access to that same shared storage, but you're basically just taking it offline from one node, bringing it online from another node. Now, if you're using different SAMs or different shared storage, after you offline on the old one, you'll do some type of file copy, then you bring it online on the new one. But essentially what we try to do is provide this end-to-end solution. But next question I get is, I have a two-node cluster. How do I do this migration? I need two clusters, right, to go from the old one to the new one. Well, believe it or not, you can actually have a one-node cluster. Limited functionality, it provides some restart mechanisms, but we're basically going to use our one-node clusters during this migration. Start with a two-node cluster. We evict one of the nodes, so we just have our old one-node cluster. Create a new one-node cluster on 2012 R2. We then do the migration, send all the files across, do the online, do the offline, destroy the old cluster, upgrade the node, add it back to the new cluster. And so that's kind of this, this stepping process to go and move your old cluster nodes over to new cluster nodes while using the same hardware.
Fantastic.
Fantastic. Well, we are going to wrap up here right on time. I want to first of all thank all of our support staff that's been available all day. They've done a great job answering questions. It's one of our biggest events we've had today. So thank you everybody that's been online.
Some on the order of 5,000 people watching from various parts of the world. Some of the other 20 people out there answering questions that are coming in at a rate of 250,000 a second.
So great job to our team.
And what we're going to do tonight is we'll take a look through some of the question logs and see if there's anything key that we want to kind of hone in on tomorrow first thing. So today, as you obviously gathered, was all about the core hypervisor and the technologies that rely on it, which is the world that I typically live in. Hypervisors, host clusters, file server clusters, all those topics. As we move into tomorrow, now we start going from the level of the platform and the technology to let's take an enterprise level view of this and how do I start building private cloud enterprise solutions using those technologies, which is where System Center fits into the picture. So we'll be looking at things like Service Manager, things like Orchestrator, DPM, Ops Manager, VMM in a lot of detail, and hopefully start painting this larger picture that virtualization through this solution isn't Hyper-V. Hyper-V is the thin layer at the bottom. It's everything else on top that builds the end-to-end solution.
Absolutely. And final thing I want to point you to are some of our different resources that we have available online. And essentially, we want to provide you with some guidance here. So if this course is not enough, we definitely encourage you to check out the Microsoft Virtual Academy, www.microsoftvirtualacademy.com. Lots of online training. We also have the mock exams and mock courses. So if you actually want to take a 5-day version of what Corey and I are talking about in a classroom with hands-on training, so you actually get a lab environment yourself, that will be coming out shortly.
We won't be there?
We will not be there. I did the 5-day version of this, and I'm happy that I'm able to cut it down to 2, or you just get like 5 days of clustering, so it's good for you guys as well here. And finally, we'll see you tomorrow. Actually, one last thing. There's still been a couple questions about where do people get their free exam vouchers. Stay tuned. We'll give you all the details on the exam vouchers shortly, but we will be sending an email with all of the information as well. So you will get all this information via email very soon. Thank you once again for joining. Thanks to our Q&A team. Thanks to our production team. We'll see you tomorrow.
See you tomorrow.